এটি যদি আপনি কেটে দেন তারপরও কিন্তু আপনার লাইভ চলতে থাকবে, লাইভ কিন্তু চলতেছে। এখন আপনি লাইভটি বন্ধ করবেন, এই জন্য আপনাকে স্টপে ক্লিক করতে হবে। স্টপে ক্লিক করলে আপনার লাইভটি অটোমেটিক্যালি বন্ধ হয়ে যাবে। তো এভরিবডি, আমি মনে করি আপনাদেরকে আমি আসলে সব কিছু
Good morning. NASA's fifth rover to the fourth planet is 2 days away from landing. The mission's target, Jezero Crater, holds great promise for the Mars scientific community. However, getting to it safely is quite a challenge. Hello, I'm DC Agel. Welcome to NASA's Jet Propulsion Laboratory in Southern California. This is the first of several informative landing week media briefings on the Mars 2020 Perseverance rover mission. So let's get to it. Here to talk about the mission and some of the cutting-edge technology on board Perseverance, we have with us today Thomas Zurbuchen, Associate Administrator for the Science Mission Directorate, NASA Headquarters. Jennifer Trosper, Mars 2020 Deputy Project Manager, JPL. Adam Stelzner, Mars 2020 Chief Engineer, JPL. Trudy Cortes, Director of the Technology Demonstration Missions Program, NASA Headquarters. Arissa Stilley, Mars 2020 EDL Operations Lead, JPL. Jeff Sheehy, Chief Engineer of the Space Technology Mission Directorate, NASA Headquarters. And Mimi Young, Project Manager for the Ingenuity Mars Helicopter. For anyone who would like to submit a question, you can do so by using the Countdown to Mars hashtag. Our phone lines are now open for media. You can ask a question by pressing *1 and enter the queue. And we'll kick things off with Thomas Zurbuchen.
Well, thanks so much. I'm so excited to join the colleagues here from JPL as we count down to Mars. And we just recognize what an amazing journey this has been. And I want to thank at this time the team for working so hard on this mission, and especially in the past year in adverse circumstances. And I want to recognize the many sacrifices that the team had to do and really exhibited this true spirit of exploration that we always talk about. I just want to thank them for that. You know, Mars captivates our imagination and has been part of our dreams for many decades. And Perseverance builds on the long history of systematic, science-driven exploration of Mars that has been enabled by ever better technologies and systems. Right now, InSight is taking measurements of Mars quakes. Curiosity is focused on geological and chemical evolution near Gale Crater. And 2 orbiters are out there, new in the last couple of weeks, joining other orbits from NASA and other agencies, learning more about this planet. Our journey has been from following the water to seeing whether this planet was habitable, to finding complex chemicals, and now we're at the advent of an entirely new phase, returning samples, an aspirational goal that has been with the science community for decades. It is novel technologies that have enabled those breakthroughs we benefit today, and it's novel technologies that are enabling the next leaps of exploration, landing with more precision and safely, learn how to make oxygen from CO2 out of the atmosphere and more, and a true extraterrestrial Wright brothers moment with the Ingenuity Mars helicopter riding at the belly of the rover right now as we demonstrate controlled flight in a different world. We could, in fact, not land in Jezero Crater if it wasn't for the technologies that are already added to this. Mars is hard, and we never take success for granted. And as we want to land on Mars, it's because it's, of course, important. And we'll do so with cameras on, so the entire world is inspired with us. And as we do new and tough things and demonstrate these new technologies. Because whether it's on the red planet or here at home on our blue marble, science can bring us together and create solutions to challenges that seem impossible at first. And I'm really looking forward to turning it over to you, Jennifer, who is, of course, the Deputy Project Manager. Take it away, Jennifer.
Thank you. Well, I am so excited to be here today. I can tell you that Perseverance is operating perfectly right now, that all systems are go for landing. Last Friday night, we actually sent a command to the spacecraft. We call it the Do EDL command, Do Entry, Descent, and Landing. It makes it sound simple. It's not simple, but it enters the spacecraft into the timeline where it starts to do the entry, descent, and landing activities. So that was a very exciting event. The spacecraft is focused, the team is focused, and we are all ready to go for landing. Now, I want to tell you a little bit more about where we're at. So if you could bring up my first graphic. This is something that you can actually look at. It's called Eyes on the Solar System. And it tells you where different spacecraft are in the universe. And so we can tell you that Mars Perseverance is 125 million miles away from Earth, and we are only 370,000 miles from Mars. So we are getting there. The time it actually takes for a signal to go from Earth to Mars is 11 minutes. And so that's how we're communicating with the vehicle right now. And now, one of the things that we've been working towards is really making sure that the aim point we're targeted for at Mars, so we want to aim like on a dartboard, that the aim point is accurate. And so one of the ways that we do that is through these plots that you can pull up the next graphic there. This is called a navigation B plot. And the actual target, the bullseye of that target, is the green box. The green box, if we think we're going to target anywhere in that green box, everything is great. What you see are some colorful ellipses in the upper right-hand corner of that box. Those and the pluses in the middle, the pluses are where we think we're targeting, and the ellipses are the uncertainties around those. So that means, those ellipses all being within that green box, it means that the targeting is on the bullseye, and we are headed exactly where we want to be for Mars. Now, getting those navigation solutions is not that easy, and we need a lot of support from the Deep Space Network. So you can go ahead to my next graphic. The Deep Space Network has stations all over the world. There's some in Madrid, Spain, some in Goldstone, California, and some in Canberra, Australia. You can actually go to DSN Now, and you can see the real-time live shots, just like we're looking at now, to see which stations are operating and communicating with which spacecraft. And Mars 2020 is taking 2 stations right now in Madrid, so I want to thank all of the Deep Space Network operators across the world who've helped us. They've had 24/7 coverage for us for the last several weeks so that we could get such good data to have those perfect navigation solutions. So thank you. And now, as I sit back, and this is my 5th landing. I've been on every rover that we've ever sent. And I get that usual sort of anxiety, but very much excitement for what we're going to see. I look at the decades that we've spent building these rovers and building these teams to send these missions to Mars. And I want to talk about that just for a minute. I think back to Sojourner, the very first rover we landed on Mars. You can see this next graphic. Sojourner was about the size of a microwave oven, very small. And even though it's our oldest a child. They're all kind of like additional children for me. It sort of behaved like a youngest child. It had a very free spirit, and it was just a fun mission to drive around. And then you can see the Spirit and Opportunity rovers were the next evolution. We built off of what Sojourner had done. Spirit and Opportunity actually could talk to Earth all by themselves. They still used solar panels, and they were these twins that explored all over Mars and outlived their lifetime by multiples of 10 and even 100, and they were just great rovers. And then we kind of took a pause and we really upgraded our systems. And you can see Curiosity down there in the lower left-hand part of this graphic. Curiosity, we went from solar panels to a radioisotope power source. The wheels increased in size. We could traverse over much larger rocks in different terrains. We had a sky crane landing system instead of airbags. I mean, we really made a step up. And then Perseverance, even though it looks a lot like Curiosity, is another technological step forward. And Adam is going to talk a lot about that after I'm finished here. And so in closing, the one final thing I want to talk about is it's not just about the rovers. And in fact, it's about the people who build the rovers. And it's not about the individual people who build the rovers. It's about all those individual people together, working together to make this mission work and all of these missions work. There are several dozen of us at JPL who've actually worked on all 5 of the rover missions, if you can believe it. And this next image is of the team. This is the Mars 2020 team, and there are many people who aren't pictured here. But I want to spend this moment to just thank the team for all of their work over the last almost decade to bring us to where we are today. The team isn't just a bunch of people who are all the same. It's a bunch of different, uniquely skilled personnel who know very deeply all the technical things they need to know in order for all those things to come together into a very complex system like the ones that we land on Mars. So thank you to that team. And I will end by saying, both for landing day on Thursday and for the whole surface mission, I wish that team great success that they have worked so hard to obtain over the last many years. And with that, I will hand it off to our chief engineer, Adam Stelzner.
Thanks, Jennifer. As Jennifer mentions, right, it is a huge army of human beings who have been working for decades in their careers to put us in a position to be able to put such a technological marvel as Perseverance on the surface of Mars. Here we see an image. This is on our first image here. We see a great shot, the hero shot of Percy. She is looks a lot like Curiosity, but she's packed with a whole bunch of new instruments, science instruments. Those will be discussed a bit in depth next week, but we've got Raman spectrometers. We've got a technology for future human explorations to Mars, which Jeff will speak about a little later on today. She's big. She's a little bigger than Curiosity. Although she is a twin, she's a few inches longer, a couple of about 250 pounds heavier, and she's a lot more capable. Next image, please. As you watch the two of them together, Curiosity and Perseverance, they look similar, but you can notice immediately that the wheels are different. I'll speak a little bit about the wheels in a moment, but Percy's got a new set of kicks, and she is ready for trouble on this Martian surface with her new wheels. She's also much more capable at driving. You know, Curiosity needs to either drive or think about driving, but not do both at the same time. And we have used a piece of technology that we originally brought on for train relative navigation, a special visual processor to allow us to move Perseverance at 3 times the rate of Curiosity. Now, with all that movement, we had to reinforce her wheels. This is an image of Curiosity's wheels. She took a beating on the surface of Mars because of these sharp rocks called ventifacts. I have a model of Perseverance's wheel right here, and you can see it looks quite different than Curiosity's. As you see from this model, Perseverance has a gentle tread pattern. Next image, please. And that tread pattern not only makes her wheels more strong, if we go to the next image, it also makes them more capable. the soft tread redesign, we call that tread the grousers. You can go to the next image. Allow the wheels to be much more strong against rocks. Maybe we don't have that image. And also to have better performance in sandy terrain. Of course, driving is not the reason for the season. We have a sampling system on board, and this is why we're actually on the surface of Mars. You can roll this. You can see the robot arm and the coring drill that it has at the end of it. Our mission is specifically to be the first piece of a Mars sample return campaign. And in this leg, we need to take samples of Martian rocks. Inside that golden bit is a sample tube that looks just like this. This is one of the world's cleanest items, even though I just touched it. This is a model, of course. Hyper clean. Inside that coring bit, once we've cored it, we bring the sample tube and the bit inside the rover, and you can roll this image. This is our adaptive caching assembly. This is a small little robot inside the spacecraft, inside the belly of the rover, that manipulates that sample tube with the sample in it, moves it from station to station, confirms that we've got the right volume of sample, takes images of the sample, eventually seals the sample, and returns it for storage until we've accumulated a big enough cache to be ready to put it on the surface of Mars. Now, this progress, this forward motion in technology has not been a monolithic march. It's sometimes 2 steps forward and 1 step back. We know how hard the last year has been. Over the development of Perseverance, we've struggled with some technology challenges. Please roll this film. This is an example of an early technology test for parachutes called LDSD, and you can watch a parachute failure here that unfortunately calls into question the ability of our parachute to help Perseverance land on the surface of Mars. So we needed to stand up a supersonic testing qualification program for our parachute, which we did, and over the skies of Wallops Island, please roll, we had this image. And you can see our beautiful Perseverance's parachute, the same size as Curiosity's, but stronger, made of Technora, Kevlar, nylon. Beautiful, strong canopy is ready to slow Perseverance down in just a few short hours. So as we move forward, you can roll this, as we move forward through technology, we have overcome challenges, much as the nation has in this last year. NASA, over the last year, getting Perseverance to this place, has persevered. Our nation has persevered. Our world has persevered through these tough times. And this journey, this persevering journey of technology development is teamwork. It is a NASA-wide teamwork, and here to talk a bit about that, the Technology Development Mission Directorate is Trudy. Please take it away, Trudy.
Okay, well, thank you, Adam. I just want to express a little bit of the sentiment that's already been expressed by Jennifer and Adam. On behalf of NASA Space Technology Mission Directorate, we're absolutely thrilled to be partnered with our colleagues in the Science Mission Directorate, leading this mission, and JPL, the multiple NASA centers who worked on this, industry, academia, some international collaboration went into this mission. And so we're just thrilled to be a partner with this on this next really truly groundbreaking Mars mission. STMD is quite proud to have 4 technologies, a record number for us flying along on the spacecraft and on the rover. There are 2 technologies that are landing instruments. One is a suite of sensors called the Mars Entry, Descent, and Landing Instrumentation. It's the second version that we're sending. The first flew on Mars Science Lab in 2012. with Curiosity, and it measures the conditions that the aeroshell will see. So it's about 28 sensors on both the heat shield and the back shell, and it'll give us data about the conditions that are seen with the hot gases, some of the winds that are seen, and it's really going to help engineers to reduce mass and optimize trajectory in the future. And then the new, really quite extraordinary capability that provides both hazard avoidance and precision landing at a site that's determined autonomously by the spacecraft, called terrain relative navigation, or TRN. And this technology is a critical part of operations. It's actually operational during the entry, descent, and landing phase. We also then have two technology demonstrations on board during surface operations. One is to take data on the Martian weather in a variety of conditions. I like to call it the Rover's onboard weather channel. I'm coming to you today from Westlake, Ohio. We had 12 inches of snow overnight. And we could just a little bit of Martian weather sounds pretty good to us right now, just a little bit drier and a little bit hotter. The other technology that's part of surface operations is one that will convert carbon dioxide to usable oxygen. This technology is called MOXIE, and I find that that's very apropos, because if any rover we've sent to Mars has MOXIE, it's Perseverance. So with more science and technology on board than ever before, the number that I keep hearing is about 50%. I do mean that literally and figuratively. And you're going to hear more about MOXIE in a few minutes from Jeff Sheehy, the STMD chief engineer, who's going to talk to you about that. So for myself, as the director of a program that advances technologies for future exploration needs, personally, I think one of the most interesting aspects is how the NASA team tested these technologies on the ground here on Earth to get them ready for flight. For example, with TRN that I just talked about, the precision landing technology, the JPL project team used some pretty unique ways to prove out the system performance here. First, they put the system through some typical environmental testing. So whatever the spacecraft is going to see on the way to its destination, mechanical vibration from launch, temperatures and pressures, which we call thermal vacuum testing, and then electrical compatibility to make sure when components are powered on, they don't interfere with each other, that type of thing. That's pretty pro forma for us. It's pretty standard. The second thing they did was focus on the software and algorithms, which are a huge part of TRN. So they did simulations in a lab to model the different scenarios that the system will see, when landing on Mars. And then next, if you could roll this video here, please. The team installed the system on a helicopter and flew it out over Death Valley in the Mojave Desert. It's really as good a simulation as we can get, where the system will identify known hazards that have been mapped, and then the maps are carried on board the system. Really close as we can get, and quite conveniently then closely located to JPL, so that was easy to run. Just like the system has to do on Thursday to get us to a safe landing spot in the Jezero crater. So then the final step in all this, and if you can show this next video, please. The team used suborbital rockets to take a next step. This was through STMD's Flight Opportunities Program. In fact, it was the Mast and Space Systems Zombie vehicle, which is a vertical takeoff and landing vehicle.
Hi, everyone.
And really, that was the final step to give decision makers, the comfort that they need to greenlight the system to be used as the primary system for Mars 2020's lander vision system. And those tests, by the way, I'll mention, took place back in 2014, over 6 years ago, which is another, just in closing, I want to make this point. This development that takes place over multiple years, all the technology development that goes into leading up to the mission, and then the demonstrations that actually take place on the rover when we land. They're really the primary way for us to continue to make these advancements that are so critical and required to send, more sophisticated robotic explorers, as well as humans, to places in the solar system we've never been able to send them before. And in closing, I'll say STMD, we say it often because we really truly believe it, technology drives exploration. And what I think is so great about Mars 2020, Perseverance, and Ingenuity is that they're all excellent examples of that happening in action. And we look forward to seeing all that action start on Thursday and taking place then. And so now I'd like to turn it over to Arissa, who's going to talk to you about even more about TRN.
Hi, I have the pleasure of coming to you from the mission support area here at JPL. So I'm just a few steps away from where I will take in Perseverance's landing on Thursday with some of my EDL colleagues here at JPL. Each team on Perseverance has a different perspective when we look at this beautiful ancient river delta that we see in Jezero Crater and the lake bed. The first two images I wanted to share with you kind of demonstrate this. The left side is a spectral data image from the Mars Reconnaissance Orbiter. So the scientists, right, they see the geologic diversity and the biosignature potential that we're looking for with this mission. The right side is an example of the EDL hazard map. And so for EDL, we ask the question, what could kill us on landing day? In the southeast are rocks that are strewn throughout the Jezero Crater landing site for us. The southwest and to the north, we have sand dunes. And then that beautiful river delta we keep talking about, well, that looks like a 250-foot cliff to us as we're landing, and we certainly don't want to land on that. This map is the best hazard map we have ever created for a flight mission. And it has to be, because this is the information that seeds the decisions that TRN is going to be making during Perseverance's landing. So what other improvements have we had to make to be able to go to a place like Jezero Crater? Over several missions, let's go ahead and show the next slide actually. You can see an improvement in the size of the landing ellipse. So some of those earlier improvements were based on the way that we do navigation. Curiosity had a smaller landing ellipse than historic missions because of something we call entry guidance, which is the spacecraft waking up when we start to sense the Martian atmosphere and start to steer our way through the atmosphere to a target. And this is actually an algorithm adopted from Apollo guidance that was used on the Apollo missions. The biggest difference for Perseverance since the Curiosity mission is using what we call range trigger. So this is a change in the way that we deploy our parachute. Curiosity deployed based on an estimated velocity, and for Perseverance, we're using an estimated range that allows us to more precisely control the distance from the target that we're doing that. And the effect it has is to shorten the longer axis or the major axis of our landing ellipse, which is why the Perseverance ellipse looks much more circular than previous missions. And this is also what allowed us to then start looking at places like Jezero, where it's harder for us to avoid the hazards. But as you saw in the hazard map, our ellipse is full of hazards. So let's move on through EDL and get to that part where we start to see TRN do its work. So I just mentioned parachute deploy. Now that we're on the parachute, if we can roll the footage, we've got one more beautiful parachute deploy video for you from the Aspire testing that Adam talked about. A few details about our parachute that we're flying. The materials are hand sewn and a mix of super lightweight nylon and really strong Technora that has a better strength to weight ratio than steel. When our parachute is packed in its mortar tube, it has the density of oak, and when we deploy it, it comes out at 100 miles per hour, has to inflate to a 70-foot diameter parachute in about half a second, and will put up to 60,000 pounds on the spacecraft and the parachute. And like so many other things within EDL, the parachute has to work. If it doesn't, it's not going to be a very good day for any of us. Once Perseverance is descending on the parachute, we can now release that heat shield that protected us during entry, and for the first time turn on the radar and start to look at the ground. And this is when we're ready to let TRN loose. TRN works in two parts. So if we go ahead and roll the next video. So the first thing we do is take images with a camera on board, compare those to a map on board, and then that allows Perseverance to reduce the error in where it thinks it is from kilometers to tens of meters. We do that with a really capable camera. The camera has a 90-degree field of view, and can you go ahead and roll the next footage that shows the feature matching? A 90-degree field of view, and has a okay, I don't think we have it. That's fine. The feature matching you saw Trudy talk about, where it's comparing features back and forth between the map on board and the photos that are taken. We're able to do that quickly because the camera has like a 1/1000th of a second exposure, which allows us to get clean images while Perseverance is swinging around on the parachute. And it has about a 0.1 second readout, which allows us to spend less time taking or waiting on the image and more time processing it. The computer on board is also specifically built to do this work. So it's one of the fastest that we've ever sent on an interplanetary mission, built for space and for image-based navigation, which also gets to do some of that work, again, as you heard Adam talk about, on the surface when Perseverance is driving around. The second part of TRN is once Perseverance has a better sense of where she's at, she then uses a second onboard map based on where we can currently divert to at that point in time, and searches that area to find the safest place that she can fly to. That search is worth over 120 football fields worth of real estate on the Martian surface at that point. So Perseverance chooses that target, and then and that all happens in the 2.4 seconds it takes for Perseverance to send commands for us to separate from the back shell and start a free fall. So when we have that knowledge and we're done with our free fall, we fire up the rockets. I like to think of it as the jetpack or the descent stage that's attached to the rover, and start a divert to that safe landing point. We go from 170 miles per hour at that point down to around 2 as we slow down and get ready for the sky crane maneuver. So if we go ahead and roll the next, we throttle down 4 out of the 8 engines so that we don't impinge the rover during deploy. And this gives you a view of how that deploy looks during landing, where we both release the rover and then fire pyros that are going to release the landing gear or the wheels to get Perseverance ready to touch down. Once we're safely on the surface, the final 8 out of 158 pyros fired to release the bridles and the umbilical, the electrical cable that have been connecting the descent stage and the rover throughout EDL, so that the descent stage can then fly away to a safe distance. And now we're on the surface of Mars. We have a brand new baby spacecraft in its new environment, ready to start rolling around. If we're lucky, the EDO camera suite that we've also got on board Perseverance this time will have been taking some amazing photos during those 7 terrifying or exciting minutes, and will give us some images of EDO that we've never seen before. With that, I'd like to pass it off to Jeff Shihai, who's going to talk to you more about MOXIE.
Well, thank you, Arissa. Coming to you from Northern Virginia, the suburbs of DC. Under normal circumstances, I would have loved sitting at the table there with the group and being at JPL to celebrate MOXIE landing on Mars with Perseverance, but these are not normal circumstances, so here I am. I'd like to talk about what MOXIE is, how it works, who designed and built MOXIE, how we'll operate it on Mars, and what we'll learn from it. So the full name of the technology demonstration is the Mars Oxygen In Situ Resource Utilization Experiment. Now that's a bit of a mouthful, so we pull a few letters out of that and we just called it MOXIE. In Situ Resource Utilization, or ISRU, means using the resources we find at the destination to produce useful commodities. If we're going to the moon, we'd have the resources that are on or the surface. On Mars, we have that, but we also have an atmosphere that we can use. The atmosphere is about 100 times thinner than Earth's atmosphere, and it consists mainly of carbon dioxide, about 95, 96% CO2, but we can use it. So MOXIE is a small-scale proof of concept demonstration of atmospheric in situ resource utilization, or ISRU. We have an animation of the MOXIE design that we can show. There it is. We can see that packed inside this gold-colored box are 3 main subsystems. There's a compressor to pull in the gas from the atmosphere and feed it into the system. There's a solid oxide electrolysis system, we call it the SOXY assembly, that does the chemical conversion. And then there's a collection of process monitoring and control sensors. MOXIE uses a thermal and electrochemical process to convert carbon dioxide into oxygen. At the cathodes in the electrolytic cells, CO2 plus 2 electrons become CO, carbon monoxide, plus doubly charged O anions. These anions migrate to the anodes, where two of them combine to become the familiar O2 molecule, with 4 electrons returned to the electrochemical system. The carbon monoxide byproduct is exhausted to the atmosphere. Something like MOXIE, any instrument you want to put on a spacecraft, starts out as a vision in the mind of a principal investigator. Principal investigator for MOXIE is Mike Hecht from MIT. He had a plan for what he wanted MOXIE to accomplish on Mars. Jeff Melstrom at JPL led a team of clever engineers who worked extremely hard and came up with several innovative solutions to implement Mike's vision in a way that would fit on the rover, survive the trip, including those 7 minutes of terror that we heard so much about, and work once it gets on the surface of Mars. We worked with a company called Oxyon Energy. They led a team that worked collaboratively with JPL and with Mike Hecht to develop the guts of MOXIE. That's that solid oxide electrolysis stack that I mentioned. A company called Air Squared led the development of the compressor that takes in the carbon monoxide atmosphere. Part of that effort was funded through the NASA Small Business Innovative Research Program. There's Jennifer highlighted the big team that worked on Mars 2020 and Perseverance earlier. There's no question that the team that designed, built, and tested MOXIE needed a lot of MOXIE to overcome all the challenges that were encountered along the way. There were times when some of the managers worried that the technology couldn't be developed in time to get it on the rover for delivery for launch. But as you can see in the next video, and I think it's up there, there's the beautiful gold box being lowered into the rover. So this is the day in March 2019 when MOXIE was installed into the belly of the rover. So there's a filter on the outside of the rover that takes in the atmosphere and feeds it to this box. The box utilizes the power system on the rover to power its operations. And so MOXIE was built and delivered on time, and it's in the rover on its way to Mars. It'll land about 50 hours from now, I think, just about. When we get it to Mars, MOXIE is scheduled to be turned on 3 times in the first 30 days or so of the Perseverance mission. The first time will be mainly to see if MOXIE responds to commands, and the second time will be to thoroughly check out all the subsystems. We'll heat it to the target operational temperature and apply operational voltages. And on the third run, we'll actually make oxygen under some conservative operating conditions. After that, during the mission of Perseverance on Mars, we expect MOXIE to have at least 10 opportunities to produce oxygen. Those operations will be distributed across times of day and seasons of the year, because the Mars atmosphere varies with time of day and season of the year. So we want to see how MOXIE works under different conditions of the Mars atmosphere. For each of those operations, we expect to produce oxygen for about an hour at a rate of about 6 to 10 grams an hour. So you might wonder, why are we doing all this? What will we learn from MOXIE? What is this tech demo going to teach us? You can see in the image there a depiction of a first human landing on Mars. And one thing that stands out in that image, other than the obvious fact that humans are on the surface of Mars in that image, that's a big deal. But you can see on the vehicle, the landing vehicle, these big propellant tanks covered in gold-colored foil that serves as part of the insulation system on the liquid propellant. Liquid oxygen is an excellent rocket propellant, and for the return trip on eventual human missions, if we could make it on Mars, we wouldn't have to pack it into a launch vehicle fairing, launch it from the surface of Earth, push it all the way to the destination, and land it on the planet. MOXIE's, I might say that, when I first heard of this notion, I thought, I wouldn't want to be the first astronaut that's told you get to come home if you can make the propellants for the return trip. But actually, the the MOXIE, the production capability for making the oxygen propellant will be put in place before we ever launched astronauts to Mars. So the vehicle that they needed for the return trip would be fueled up and ready for them before they even got there. Now, MOXIE, as implemented on the rover, is about 1% of the scale that would be needed to produce enough oxygen to fill up the liquid oxygen tank on a Mars ascent vehicle. So the reason we're doing a MOXIE is we'll take the lessons we learned in developing it and everything we learned from operating it on Mars, and we'll put together a plan to scale up the underlying technology, test that out, and then deliver it to Mars. Ultimately, as we build up a sustainable presence, first on the moon and eventually on Mars, various in situ resource utilization processes will be used to produce propellants or construction materials or life support consumables, even energy to power payloads. But leading the way will be MOXIE, which is the first ever in situ resource utilization demonstration on another planet. Now I'll turn it over to Mimi Ong, who will talk about the Mars helicopter.
Thank you, Jeff. So like MOXIE, Mars helicopter is the technology demonstration motivated by the potential to add aerial dimension to space exploration. So our team started with the question of whether it is possible to fly a helicopter at Mars, because the atmosphere there is extremely thin, 1% compared to what we have at Earth. So we systematically worked through a series of technical steps. And so we started with first demonstrating lift. Please roll the video. With a 1/3 scale vehicle here in a chamber of Mars-like atmospheric density, and somebody's outside trying to joystick this to fly. We achieved lift, but not control. We learned that the dynamics on Mars in this thin atmosphere is very different. And so next we built a full-scale vehicle with onboard real-time closed-loop control and demonstrated successfully for the first time ever a powered control flight in Mars-like atmospheric density. From there, we went on to build a full-up Mars helicopter, which will not only fly at Mars, but can operate and survive autonomously at Mars. And let's roll this video. And all the while weighing under 1.8 kilograms, that's 4 pounds. So what you're seeing on the video here is one of our many flights that we experimented with this 1.8 kilogram Mars helicopter. And you see the helicopter flying. It looks very easy when you look at it, but you're looking at a room with atmosphere about 1% compared to the room that you're sitting in right now. And those blades are working very hard, being controlled hundreds of times per second. So at this time, the Ingenuity Mars helicopter has been fully tested as much as we can on Earth. We've flown, we've test flown, and we have tested for environment. And next is time to demonstrate, prove, and learn how it operates at Mars. So to do that, at this moment, Ingenuity is approaching Mars, carefully held by Perseverance rover, and is accompanied by its base station, which is also riding on the rover. And so far, so good. In cruise, we've turned on the helicopter temperature, kept maintained as designed by the base station. We're maintaining the helicopter battery through the base station, and we are ready for EDL. And the day after landing, we'll turn on to check, confirm that the health is good. After that, the next major milestone will be when Perseverance rover delivers Ingenuity to the surface of Mars. If we could play this video, you'll see that the debris shield that protects the helicopter on descent is first deployed, and then the helicopter is deployed by what's called the Mars Helicopter Delivery System. It's a very intricate system that's going to take about 10 days to go through these series that you're seeing to drop Ingenuity to the surface. And that drop, the moment that drop happens, is the moment that Ingenuity has to start operating on its own in a standalone fashion. So this little 4-pounder, remember this entire vehicle is 1.8 kilograms, about 4 pounds, has to survive the cold, frigid nights of Mars, minus 90 degrees Celsius, keep itself warm. It has to garner energy from the sun through its solar panel to charge its battery. It has to talk to its space station. It has to do all of that in this little 4-pound. And the helicopter team will be working with the rover team and the scientists to look for the appropriate experimental site for our flight experiments. And then next, please. And now, after that, you'll see, after the rover deploys and drives away, there is Ingenuity helicopter. We'll have some tests of the rotor system for readiness, and then we will go for that very important first flight. Rover will stay at least 100 meters away and will be watching Ingenuity, and Ingenuity will take its first flight. The first flight will ascend to about 3 meters in height and hover for about 20 seconds. And it will perform the very first ever powered control flight on another planet. And as Thomas mentioned at the beginning of this event, it will be truly a Wright brothers moment, but on another planet. So after each of, and then if we can go on to the next step, please. So this is what we're looking for. So this is a picture of our Mars helicopter team. As Jennifer mentioned, it really takes teamwork. We're extremely tight. We've been working on this for over 6 years. Members from JPL, NASA AIM, NASA Langley of the ARMD, Revolutionary Vertical Lift Technology Program, industrial partners, AeroVironment, Qualcomm, Solero, and other companies. We've worked so hard. And so shout out to our team. We're getting to Mars on Thursday. And every step going forward will be first of a kind. And first step, so it'll be nail-biting, nail-exciting. So for all of you out there, on behalf of the Mars helicopter team, please join our journey. Back to you, DC.
Thank you, Mimi. We are ready to take media questions. Remember to press *1 to get put in the queue. And please direct your questions to one of our panelists. We're also taking questions through the pound countdown to Mars hashtag. And we have our first question from Marcia Dunn at AP. Marcia?
Yes, hi. Can you hear me?
Yes, we can.
Yes, for Dr. Zurbuchen, I'm wondering, if all goes well, what is the earliest year that you would anticipate getting these samples back? We hear just 2030s, but I'm wondering what's the soonest year in the next decade? How does that compare to when the first human crew might arrive? And lastly, you know, Mars landings are always so full of tension and stress. Adding on top of that, the attempt to bring back samples, how much more is that magnifying, amplifying all the tension? Thank you.
Thank you so much for your question. So let me do them in reverse. The first one is, it's not adding stress. I mean, we always bet all of our we do always the best job we can. We bet on success. That's just what we do. And whether or not we want to return these samples is not adding to it. We're, of course, planning for that. That's exactly what we should be doing for this amazing mission. And for me, we're entirely focused on one thing right now, which is a successful landing. We're not doing anything else with this team right now. They're focused on a successful landing. In terms of the earliest return, you, of course, have read both the work that we did and the independent review team, and they're telling us that basically launching in 26 and 28 kind of time frame is the right time to go there, which would bring the samples back in 31. And that, of course, is because of the planetary alignments, the home on orbit's going this way and in reverse, that set some of these windows that limit a part of that, as do some of the propulsion characteristics of the spacecraft that are under consideration. So the early 31 is basically the relevant time. Of course, I just want to say where we are right now is in the middle, like we do every year, and there's certainly in conditions and trying to make sure that we kind of bring all of our stakeholders along and make sure that we have the same enthusiasm for this mission. That includes the international stakeholders. Get this done in this time. The same is true for our human exploration of Mars, where a number of discussions are happening. Of course, the key element of the priority right now is to take humans out of low Earth orbit and really go towards the moon and kind of really make sure, as part of our Artemis program, we land on the moon and then build from there. So basically the earliest that we've talked in various plans and that have been talked about also in the previous administration is kind of late 30s, where such a thing could happen. But I just want to tell you what I'm talking about, bringing the community along, is really still happening, right? We have not had all the discussion with all stakeholders at the level of detail to really answer that question fully and with a lot of confidence. Technically, that's kind of no earlier than that we have talked about in the past. So that's how I would talk about those three.
Okay, thank you. Next up, we have Bill Harwood from CBS News. Bill? Bill Harwood from CBS News. Bill, are you on the line?
I am on the line. DC, can you hear me now?
Yes, we can. Thank you.
Sorry about that. So much for my AirPods. This is for Jennifer Trosper. Can you give us a sense of what we can expect after touchdown in terms of telemetry and imagery that would confirming a successful landing? I mean, some of this is in the press kit, but I'm trying to understand what we can expect that afternoon we might get in time for evening newscast, for example, just kind of in general. And a related question, can you talk a little bit about how losing data or not receiving data for some reason might not mean something bad happened? In other words, if you went into a safe mode or something, why we shouldn't all be, oh no, you guys would obviously try a lot of recovery and all of that. Can you just kind of address that a little bit for us? Thanks.
Sure, I'd love to. So we have several telemetry streams that come down during entry, descent, and landing. The Mars Reconnaissance Orbiter is watching, and we call it a pseudo-bent pipe. So we get almost real-time data with the one-way light time from Mars Reconnaissance Orbiter through UHF. That should give us the most information. There are reasons that could drop off during dynamic events while we're going through the entry, descent, and landing. In particular, you saw with ERISA, the mobility deploy. So it's possible we will lose data in that link, but it's also possible we'll get the data that has the most data, and that's where we would get some final, possibly camera images from the HAZCAMs on the front and rear in that data. We also have X-band data that goes direct to Earth, and in that we get some tones. Those tones just tell you what key events have happened, parachute deploy, for example. So we hope to get that. Earth does set shortly after landing, and so depending on horizon masks, it's possible that we would lose that link as well. After we land, we hope to get either of those links. We also are recording data with the MAVEN orbiter, so we will have data that we have to process and we'll get within several hours after landing. But then even if we don't hear anything at landing, if some of those data links drop out, we do have our first overflight of another orbiter, the Odyssey orbiter, about 3.5 hours later. And that's a small data volume pass, but getting that pass would get a lot of information about the state of the vehicle. If it's able to communicate, then landing was safe. After that, we have another pass in a few hours. It's about 6:30 p.m. on landing day, where we would get some more data. So if all goes well, we could potentially see some images by the end of the day. If not, it's possible that something happened that caused the vehicle to go maybe into a safing mode after landing. If we're in a safing mode, then we have fewer passes, we send less data, and some of our fault responses. So the rover's programmed, and we spend a lot of our time thinking about what could go wrong and how do we help it save itself. And so one example is if something went wrong with the main computer, it could take up to a week for the rover to go through all the autonomous actions that it's programmed to do, switch through all the telecommunications hardware, and then switch to the other computer. So there's a lot of investigation. We will look at everything, look at all these different, we have UHF stations, we have X-band stations on Earth looking at the spacecraft. So we will work very hard to understand the success, and if something went wrong, to figure out how to get the spacecraft back if possible.
Thank you, Jennifer. Okay, next up we have Chelsea Gold from space.com. Chelsea?
Hi, thanks so much for taking the question. My question is for Jennifer. Everyone talks about the 7 minutes of terror, which obviously sounds intimidating, but as someone who has worked through all of the rover landings from NASA thus far, you seem more than prepared for the couple days ahead of us. How are you feeling 2 days out, anticipating yet another, fingers crossed, successful rover landing on Mars?
I'm feeling great. There are no guarantees in this business. There are lots we always talk about what Mars might throw at us this time, and it's never the thing it threw the last time, and so we have to be prepared for that. But I tell you, I look at those navigation solutions. We did our last time to target Mars was trajectory correction maneuver number 3. We've never been able to not do the last 2 maneuvers and still be within our bullseye target. So the team is doing a great job. The spacecraft is solid. I led the test program. I feel very confident that it will do the things we do. But again, no guarantees, but I'm feeling great.
Thank you, Jennifer. Again, let's see. We have Joe Palca from NPR. Joe?
Hi there. Quick question about the navigation system, the terrain relative navigation system. Does that have a dedicated camera? And if so, is there a similar sort of camera doing the same thing for the rover once it's on the ground? And where is that camera? Is it on the sky crane or is it on the lander? I don't know who should maybe. I'm not quite sure. Trudy or somebody.
Trudy, you want to take that?
I'm not sure if Arissa wants to take that.
Either way.
Yes, it does have a camera system on it, but Arissa might be able to give you more details about it.
Arissa?
Yeah, so as we said, or as I said before, there is a dedicated camera for the entry, descent, landing part for terrain relative navigation that we call the LVS camera, or Lander Vision System camera. And if you looked at a picture of the rover, it would be sort of under the front left armpit of the rover looking down. And the computer that is in charge of doing the image processing and helping to get us to a solution we refer to as the VCE, or I think the visual, and I'm going to get in trouble now if I misremember, but I think it's the visual compute element. And that computer is the same one that's used on the surface on the rover for when it does autonomous navigation. The cameras that the rover uses to do that are different. So we have navigation cameras that are on the mast of the rover. So they're the ones similar to what Curiosity does. Those will take photos of where the rover is, along with the hazard avoidance cameras that are on the front, lower on the front and rear of the rover, and can combine those images to enable the autonomous driving on the surface. So there's different cameras for those purposes, but the same computer is doing the work.
Thank you.
Great. Thank you, Arissa. And now we're going to go to a question from social media. GS on Instagram asks, how does NASA test for the different atmosphere of Mars when practicing on Earth? This might be good for both Adam and Mimi.
Sure. Okay, so for helicopter flight, what we did is we used the space simulator at JPL. It's a 25-foot diameter chamber, about 70, 80 foot high. And we pumped that chamber down to near vacuum, and then we backfill with carbon dioxide to about 1% density in atmospheric density compared to outside of the chamber, compared to Earth. And that is representative of Mars, and we've been doing all of our flight tests in that. So that takes care, for flying a helicopter, that takes care of the atmospheric density. The second part is the gravity. The Mars helicopter will experience only about 40% gravity at Mars, and when we're testing on Earth, it weighs a lot more. So what we do is we attach a gravity offload on the top to take care of the difference between Mars and Earth gravity. So that's how we simulate Mars on Earth.
Thanks. For parachute testing, we go to very high altitudes in the Earth's atmosphere, so we get the right atmospheric density. Of course, because we're here at Earth, we have the wrong ratio of specific heats. We have the wrong speeds of sound, so we need to adjust our testing program as best we can to get the parachutes to open up in the right fluid mechanical configuration and states here on Earth. And we do the best we can, very high altitudes with supersonic rockets that get us up there.
Thank you, Adam. And next, we're going to go back to the media on the phone. And next up, we have Paul Brickman with UPI. Paul?
Yes, thanks. Hi, can you hear me?
Yes, we can.
Okay. So regarding coming in through the atmosphere, so Perseverance is like Curiosity, but heavier. Can you describe how the capsule steers itself during entry and, or if it does steer itself? I know that it has at least one ballast device that it drops, and so wondering if someone could say how those work and if that is what dictates the angle of entry, and can the capsule make any adjustments during that time?
Arissa, question for you?
Yep. The way that we do that is very similar to Curiosity. The main differences are when those devices were designed for the vehicle at Lockheed Martin, they have some flexibility in how much mass you put into them. So before we start entry, I think shortly after we separate from the cruise stage, about 10 minutes before entry, we actually will eject two masses that are called cruise balance masses. And that's what allows us to shift the CG. So on the way to Mars, we're spinning, right? Our CG is as centered as it can be. And then we release those cruise balance masses that cause our CG to have an offset, and that's what provides the lift vector that we use to steer both Curiosity and now Perseverance through the atmosphere. When we get to the end of that phase, we similarly eject now 6 smaller masses called the entry balance masses, and that's to put that center of gravity back to the center pretty closely before we deploy the parachute, so that we're not deploying the parachute at a big angle. So the way that we do that is very similar to Curiosity. We just adjusted the masses and took and did it that way for Perseverance.
Thank you, Arissa. Next up is Gina Sinceri with ABC News. Gina?
I'm not sure who can take this, but I know you have other assets from other countries orbiting Mars. How are they contributing to this?
Thomas?
So yes, there's a number of assets from other countries. Basically, in this entry, descent, and landing, the only assets that actively contribute are U.S. assets. We do not, for the immediate entry, descent, and landing activity, are relying on other assets. But Jennifer, I'm going to kick it to you to see whether there's fallback solutions and which other assets would be used. Jennifer, go ahead.
Yeah, so on the first sol, we call it Sol 0, the latest afternoon pass that we get, it'll be about 6:30 p.m. Pacific time. That will be with the Trace Gas Orbiter, the European asset. And so they are supporting this mission by relaying UHF data to us. So we appreciate that.
Okay, thank you. Next up, we have Jonathan Amos with the BBC. Jonathan?
Hi, DC. Greetings, everybody from London here. Can I just check, Jennifer, that you're not going to do a correction at all going into Thursday? Now, you're tucked right up in that top right-hand corner of that box. You're obviously comfortable with that. And then the other question I had, just going back to Curiosity, what's going to happen on Thursday? What should we expect to see? We remember Adam walking around the control room, and Alan Chen was the voice that we heard calling Curiosity down. Alan tells me he's not going to call it down this time. I wonder whose voice we're going to hear calling Perseverance down on Thursday.
Okay, I'll take the second one. I will answer. Swati Mohan will be calling Perseverance down. She's a guidance, navigation, and control engineer who's been working tirelessly on entry, descent, and landing. She is one of Al Chen's deputies. Al Chen will be in there as well. He'll be giving the final calls of touchdown, nominal, and things like that. And Swati will be giving the intermediate calls. So that's our EDL team. You'll notice a few differences. We'll be socially distanced. We'll have masks on. There will be fewer people in the mission support area. We actually, fortunately, have a second floor where we have a large number of folks as well. The surface team and the EDL, the entry, descent, and landing teams, will be on site as well. So we're spread out, but we have a lot of folks here. Back to your first question about are you really not going to do another maneuver? You're up in the upper right-hand corner of your targeted box. Is that good enough? Well, yes, we believe it is. Now, we have, if we got it really wrong, we still have the ability to do another maneuver if we need to. But those ellipses are the uncertainty ellipses on our estimates, and all those ellipses are still well within the green box, and the green box is conservative. So we have high confidence that we won't have to do another maneuver, but we're always ready. We have daily tag-ups twice a day to talk about whether there's something that we don't like about the navigation data. The plots are coming out all the time, so we are looking very closely, and if we need to do something, we will, but we don't expect that we will have to.
Thank you, Jennifer. Okay, next up we have Irish Television's Leo Enright. Leo?
Thanks very much indeed, DC. I wanted to ask a couple of questions about the terrain relative navigation. This is a technology demonstrator, yet it is also mission critical. So I'm wondering, how unusual is that? Is this something that's happened before, regularly perhaps? And I'm wondering, with a technology demonstrator, is there a plan B? Has the sky crane been told that if something goes wrong with the TRN, that it should make some sort of Hail Mary landing? And if I may also very briefly ask about this 120 football field size area that Arissa spoke about, could you just clarify the hover time available with this system? If you're coming down, if the sky crane is coming down on the home touchdown line, you just plonk it down. But if you have to go all the way over to the other end of the field, how long can you stay in the air, is my question.
Well, Leo, as always, a very detailed question, and thank you for that. Let's first start off with Thomas Zurbuchen.
Yeah, I'm just going to, before we go into technology, which I'm not the right person, I just want to tell you that, yes, we have, when we landed with Curiosity, kind of done a number of technologies for the first time. Terrain relative navigation is not an exception. I just want to tell you how we did this when we chose Jezero as the place to go because of its amazing science promise. We actually did so with an asterisk attached to it, which is basically we said we want to do an independent review based on the data and the planning that the team had put ahead of them to make sure that this technology works. And if the answer would have been from that review, well, we're not quite sure, we would have backed off into another landing site. And we were convinced, I was convinced, that the technology was ready to go. So the way we're doing this is using the rigor and using data to drive processes in a way that we can include these technologies, and we're proudly doing so. Now over to the specialist on technology.
Okay. Leo, did you have a follow-up?
I think there were...
Yeah, I was just wondering about a plan B. Is there some sort of Hail Mary landing that can be done if for some reason, say, the TRN cameras don't work or something like that?
Adam Stolson, the chief engineer.
Sure. Leo, we have, if TRN does not work, does not converge, and we don't get a TRN solution, we would go to a normal MSL Curiosity-like divert maneuver, and we would have a increased risk of terrain hazards, but a risk that we took eyes open at the Jezero landing site. So, yeah, there you
go. Okay. Thank you, Leo, and thank you, Adam. Next up, we have Jacques Goddard with the Times of London.
Hello, thank you. So we've grown to know a lot about how the spacecraft work. I wondered if you can give us a little insight, one of you, into how you folks work. I'm referring particularly to what you have to do over the next few weeks and months to keep yourselves on Martian time. So the sleep shifting, I think some of you wear special watches. Could one of you talk about that, really? What adjustments do you have to make to how you live and work in order to become a Martian? Thank you.
Jennifer, you want to take that?
I will take that. The surface team, so there are about 350 people and some additional scientists who will be working on Mars time. So right now they are adjusting their clocks. The way that we work is we typically will show up in the afternoon on Mars because that's when the data comes to Earth. And then we will work for 12, 14 hours until we get the uplink to send to the rover based on the data that we received. Now, the Mars day is 40 minutes longer, so that's what makes Mars time hard. So if you're up at, will probably be 2 p.m. will be our start time, and then that will adjust by 40 minutes every day, which for a while it works. We've kind of found that we only ask people to do this for 3 months. The first cycle, there's a 37-day cycle that you go through, and then you're kind of back to the original time. The first cycle, everybody's excited. This is cool. I'm on Mars time. And, you know, in fact, last on Curiosity, one of our engineers took his whole family on Mars time because it was summer and they weren't in school. And so we had this whole family on Mars time. By the next cycle, people start to get a little bit tired, and by the third, you know, by the time we finish Mars time, they are well ready to be finished with Mars time. It's hard on your body. It's like being jet lagged. And so everybody, we have different things that we allow folks to do if they need to stay local, or, you know, we have cots in offices and things like that to just help people manage in Mars time. The reason we do Mars time is because it is the most efficient way to have the rover make progress on a day-to-day basis. And that's really important early in the mission to get it kind of unbuckled and ready to go for the great science mission that we have.
All right, great. Thank you, Jennifer. Let's see, we're going to go to a few more social media questions. Jeff, apparently social media really is interested in MOXIE. We've got 2 of them for you. The first one is from Glenn on Facebook, who asks, could MOXIE generate anything other than oxygen?
No, MOXIE is specifically designed with the electrochemical system and the elements in that to take carbon dioxide and generate O2 molecule. There's all sorts of electrochemical processes that are used industrially, even very large scale here on Earth to make all sorts of things, but each of them are tailored for a particular purpose. And this one's designed not only to make oxygen from CO2, but to do it under Mars conditions.
Great. And the follow-up, Daniel from Facebook asks, is NASA starting to terraform Mars using MOXIE?
Yeah, that's a good, interesting question. Good question. And there's a lot, you know, in the literature about terraforming, ranging from, you know, fairly serious studies to science fiction sorts of works. And it's a dream of a lot of people to take another world and turn it into something that's more habitable or more like we're familiar, you know, something we're more familiar with. You know, I talked about scaling up MOXIE. The MOXIE, as we're sending it to Mars on Perseverance, is very small scale. It's going to make a little bit of oxygen. It's really going to prove the concept. I talked about scaling it up 100-fold or so to fill a propellant tank. If you were going to try to produce large amounts of oxygen or to take large amounts of CO2 out of the atmosphere, MOXIE wouldn't be the type of technology that you'd use. It's a fairly power-intensive technology. It's good for the purpose that, you know, NASA envisions for atmospheric IRU, atmospheric ISRU on Mars, but there are a lot of other technologies that people have written about. I'm not an expert in those, but in terms of either carbon sequestration, which is something or CO2 removal, which is something we may be interested in here on Earth, or generating life support consumables to change the atmosphere of another world. The solid oxide electrolysis wouldn't scale well to that sort of implementation.
Thank you, Jeff. And Thomas Zurbuchen.
Yeah, let me just add a couple comments. So first of all, the answer is no. This instrument, and I think you said that with more words. The answer is we're not terraforming. We're terraforming, or we're shaping the environment of Mars as little as a mouse in Nevada is changing the Earth, right? It really is not It's not a substantial kind of global impact of what we're going to do, and we have no intent. We think Mars is a beautiful planet that remains to be discovered. And I just love the path ahead that you just outlined of trying to scale that up so we can do more exploration with more people, with more systems, and even with those, the overall system of Mars would not substantially change. And no plans that we have in a large scale would create a large scale change on this planet.
Thank you, Dr. Zurbuchen. Okay, that's it for this morning's news briefing on the Mars 2020 Perseverance rover mission. If you're a member of the media and have further questions, please call JPL's Digital News and Media Office. We'll also continue to answer questions on social media as well as online. Thank you for your questions, and thank you for the panelists for joining us today. A reminder, at 12:30 p.m. Pacific today, there is a media briefing that takes a deeper dive into the science of the Mars 2020 Perseverance rover mission. And then tomorrow we have two more briefings, both in Pacific time. The first one's at 10 a.m. when we will have an overview, actually a more deeper dive into what's going to happen during landing. And then there will be one at 12 p.m. where we will be talking about searching for signs of ancient life and Mars sample return. Perseverance is set to land on Mars on February 18th with commentary beginning at 11:15 a.m. Pacific Standard Time. NASA's offering a lot of options for you to ride along with us to join the virtual NASA social and virtual guest events. Register for the mission to Mars Student Challenge and live stream the Mars landing. Visit gonasa.gov and /Mars 2020 toolkit. I'm DC Eagle. Have a good day and go Perseverance.
I'm Dr. Ellen Stofan, also known as Dr. E.
And I'm Dr. Thomas Zurbuchen, also known as Dr. Z.
I'm at the Jet Propulsion Laboratory in Pasadena, and I'm here to see the first drone that's gonna fly on another planet. It's the Mars helicopter. Come on.
So this is our baby.
No way.
Yeah.
That thing right there is the actual machine that is going to take off and land on Mars. It's going with the Mars 2020 mission. That is the Mars helicopter.
This will be the first powered flight in another planet.
This is that. Now, it's necessary to say first powered flight because in 1985, the Soviet Vega missions deployed 2 helium balloons on Venus. They transmitted data for over 46 hours while floating at an altitude of 54 kilometers in Venus's dense atmosphere, which at the surface has a pressure of over 90 Earth atmospheres. In contrast, Mars has very little atmosphere, only around 1% of Earth's.
Flying this kind of helicopter is equivalent to flying a similar helicopter on Earth at 100,000 feet. So you don't hear about many helicopters at 100,000. I think 40,000 feet is probably the record.
I checked. 40,000 feet is the record altitude reached by helicopters on Earth. 85,000 feet is the highest a plane has ever flown. On Mars, the air is even thinner than that.
Right, in terms of density is 1% of what you have in this room. So in this room, a cubic meter of air is about a kilogram.
Yeah.
The same cubic meter on Mars will be about 15 grams to 18 grams. So that
you have to push a lot of air down.
Yes, you gotta get a lot of air flowing, and so the obvious trick, if you will, is to spin the blades faster.
It can spin between 2,300 RPM and 2,900 RPM.
That is fast.
That is fast, yes.
2,300. Here I'm trying to work out exactly how fast that is. So I looked it up, and on Earth, helicopters typically spin their rotors at around 500 RPM. So the Mars helicopter will have to spin its blades 5 times faster.
But there are some limits. We really don't want to get the tips of the blades breaking the speed of sound.
Because then you have shockwaves and all
and you
sorts
get all kinds of funky aerodynamics and transonic flows and things like that. So you don't want to go there. So we, in our designs, keep the tip mark numbers down to below about 0.7.
So 70% the speed of sound.
Yeah, so it's very conservative.
One advantage of flying on Mars is that gravity is only 38% of what it is on Earth. Even so, making the craft lightweight was essential.
Keeping the mass of this vehicle contained during the entire design process has been the major challenge.
Every single part had to be considered. The entire vehicle is less than 1.8 kilograms.
Whoa.
So less than 4 pounds.
That's about the same as this laptop.
The blades are foam core with carbon fiber layup. Each of them is about 35 grams.
Wow.
Yes, it's quite light, yes.
35 grams is the mass of 6 quarters. Think about that. 2 35-gram blades lifting an 1,800-gram helicopter by spinning 40 times per second in just 1% of Earth's atmosphere.
How long can it fly for?
It's designed to fly up to 90 seconds.
A minute and a half of flight.
Yes.
To me, that sounds like forever. When you're talking about another planet flying autonomously by itself in 1/100th Earth's atmosphere, I mean, come on. Like, that's a long time.
It is, yeah.
One of the questions I had was, why didn't they use a quadcopter design? Well, because on Mars, the blades have to be so long that the whole craft would barely fit on the rover. 2 counter-rotating propellers provide the simplest design. They also generate lift more efficiently when stacked on top of each other.
The bottom rotor sees the sort of the more compactified flow. The top one pulls it, the bottom one sees sort of a more concentrated flow. Right. So the bottom rotor actually can do better than if they were separated apart.
But how do you test a helicopter designed for conditions on Mars on Earth?
What would happen if you just took your Mars helicopter and you tried to take off on Earth?
It would just make a lot of noise.
Really?
And it probably wouldn't get to full head speed either.
Because of how much atmosphere we've got.
Exactly. It's like trying to swim in a thick soup. We have a really amazing chamber here on lab called the 25-foot space simulator. And in that chamber, you could simulate any kind of atmosphere you want. You can go to Martian pressures, you can stay at Earth pressures, whatever you want. But that only took care of half of the problem. That was the aerodynamics aspect of it. There's the other part, which is the gravity. We needed a way to fake Mars gravity here on Earth, and the best way that we could figure out to do that was a gravity offload.
Gravity offload just means pulling up on the helicopter, so it only has to support about 38% of its weight, just like it will have to do on Mars.
And effectively, it was a high-tech fishing reel. So taking a brush DC motor, a reaction torque sensor, and a pulley, mounting that a couple stories in the air, and then attaching a fishing string to the top of the helicopter that would tug the necessary force required to offload the differences in gravity.
An actual fishing line?
Yeah, real fishing line.
But isn't that stretchy? Like, don't you want something that's perfectly rigid so as soon as you apply the torque, it gets applied to the craft?
Right. And we did a lot of testing with different vendors to find out which fishing line had the best spring constant for us.
What does the helicopter sound like? I imagined that in 1% of Earth's atmosphere, the helicopter would be pretty quiet.
Yeah, you're still at 1%, but it's still real loud.
Really?
Yeah, we have audio recordings of it too. But it's I would characterize it more like bah, something like that. When the gravity offload system was working and the chamber was pumped down, the helicopter thought it was on Mars. It felt like it was on Mars, the helicopter.
How do you actually steer this thing around and drive it?
So the way helicopters work is they have something called collective and cyclic. So what collectives do is they change the pitch on the blades uniformly. So throughout the entire revolution, if you move the collective, the blades will
change their angle of
change
attack.
the angle of attack, you'll get more lift. So that's basically what provides you heave control, right? You pitch more, you go up, pitch less, you come down. But then there's something called a cyclic on helicopters, which basically what it does is it modulates the pitch as it goes around. So it can pitch a little bit more here, less here. So it kind of like modulates. So what that does is it provides an asymmetric torque, right? When you're pitched up there, you get that additional torque. Now you get it, depending upon the stiffness of the system, you actually get it with that gyroscopic lag that can happen afterwards. So once you get an asymmetric torque, the vehicle wants to start pitching or rolling, right? So once it pitches and rolls, and you're doing it stably, you are now pointed in a direction, and your thrust vector now has a component that's horizontal in the direction that you pitched, right? So then you start translating in that direction.
I've heard that initially someone tried to fly it with a joystick?
Yes.
An early prototype?
If you were sitting right there on Mars and you were trying to joystick it, what is it like? And it's almost unflyable. And the reason for that, it's the aerodynamics of when you want to command a roll to the left, because you see yourself starting to move to the right, and you start commanding a roll to the left, there's a delay aspect. So that delay effect makes it very, very difficult for a human to try and pilot it.
You can't fly this from Earth.
Because of the 20-minute kind of time delay, so you have to really send sequences.
So essentially, you're going to push a button, and like 20 minutes later, it'll take off and do its thing, and then you'll find out.
The way this flies autonomously, it has onboard gyros, onboard accelerometers, and onboard camera, and altimeter, and an inclinometer. And so using that sensor suite, real-time measurement, against the terrain, and of course the gyros and the accelerometers sensing on board, the real-time estimation of the state of the vehicle is made continuously, again, hundreds of hertz, and then that's fed into the closed-loop control algorithm that takes the estimated state and then generates the correction that's needed at the blade level, and then the blades are continuously being controlled. So when you see video tapes of our successful flights, right, and the vehicle looks dead calm, is coming up and hovering and going laterally, coming back, the machines are working very, very fast and very, very hard. It just looks very calm, but yeah, so the blades are being continuously controlled.
That is amazing. Yeah. How will it handle a gentle breeze?
A lot of the movies depict
dust storms.
Depict dust storms as being very aggressive on Mars. The truth of the matter is that 1% Earth's atmosphere is very little matter actually hitting you.
Always. I mean, you're using that to lift yourself.
Exactly.
So obviously,
so there's enough to lift, right? But we also need to spin at 2,200 RPMs to be in the ballpark of lifting ourselves.
We built our own wind tunnel that we put inside this 25-foot chamber. How many fans was it, Teddy? 960 computer fans. So, but it did sound like a jet engine taking off. So we built a fan wall array. It's called an open cross-section wind tunnel, where you don't need the walls. Just the fact of having an array of fans, we are very confident of it being able to go at 11 meters per second. Even this vehicle, if I had known that somewhere along the way I'd be building a wind tunnel to do this, I would have probably not taken the job on, right?
How long does it take to recharge?
We recharge the whole day. So the whole day at Mars.
Right.
So
but does that mean that you could do one flight a day kind of thing, in theory?
In theory, yes. By design, it can.
What is the size of the battery?
Between 35 and 40 watt hours total.
That's equivalent to just 3 smartphone batteries. And get this, most of that energy isn't even used for flying.
It has to survive temperatures as low as about -80 to -100 degrees C at night. So we keep the batteries warm, and we surround the batteries with our electronics board, so the electronics boards also stay warm. We take approximately 2/3 of energy just keeping things warm and warming things up to operate. Only 1/3 of the energy is available for flight.
Do you have insulation on there to keep it warm?
Yes. When you look at the helicopter, right, you have the solar panel on top with the antenna, and then next is the rotor system, and then bottom, what you see, this cube, is what we call the fuselage. You are seeing it now actually uncovered because you're seeing the last day of final, we're recovering, for delivery to be integrated onto the rover. Okay, so usually you won't be seeing that. So the center of the cube is the ring of batteries, okay? There is space between the battery and the circuit boards that you're seeing, and then there will be a shell that we put on called the fuselage shell, and that will close like CO2, the gas around, and so the enclosure itself, we're using the CO2 gas as the insulation material.
Oh wow, no aerogel.
No aerogel. We did consider it was in the game. It was in the consideration in the beginning, and it turns out that just the CO2 as insulator itself was sufficient for us to close our thermal model.
Right.
And so, guess why we wouldn't want to use aerogel if we have a choice?
Wait.
Yeah, there you go. You're welcome to our team.
Now, before the helicopter can experience the frigid conditions on Mars, first it has to get there. And that's a reminder that not only is this an aircraft, it's also a spacecraft.
It has to survive launch. It has to survive launch loads, which, easily exceed about 80 G. because of the vibrational loads are ATG.
Yeah.
Then it has to survive the 7-month trip, complete with radiation. And finally, after pulling 9 Gs on entry into the Martian atmosphere, the helicopter needs to be deployed.
This is going to be on the rover. Before you take off, does the rover like pick you up and put you down somewhere?
We're going to be stowed underneath the rover on the belly pan on our side. And there's going to be several sequences of firings of explosive devices to actually rotate us right side up and then drop us on the surface.
For example, the very last thing that the rover does is it's got us by this bolt, it's holding us, about this high, and then it has to drop us, right?
Yeah.
So how do you undo a bolt on a spacecraft?
Just blow it up.
You blow it up. Basically, it's the materials, undergoes a phase transition, which certainly increases the stress in the metal part of the thing and makes the bolt break. It's called a frangibolt.
Then once we're on the surface, the rover drives over us. It gets about 100 meters away, and then we have about a 2-hour counter internally where we'll wake up after 2 hours, wait to hear some RF transmissions, and if we do get that link with the rover, then great.
Our base station on the rover would issue the fly now command. First flight will probably be a mutual selfie, you would think. This is, after all, the selfie age. So
I like that as the goal of the first flight.
Yes, it is. In
Go
fact,
up, take selfies.
the best time to fly this is at 11 o'clock in the morning local time on Mars. And the reason for that is we would have come out of the night where we would have spent a lot of battery power trying to stay warm. By 11 o'clock, the state of charge would have gotten to the point where we could fly without risking brownout on the battery and then dropping the whole craft to the ground. Also, 11 o'clock is where the sun would have warmed up things, so we don't quite have to heat up as much. And also, it's not late afternoon where, because of the warmth, the density has begun to drop, okay? And the winds have begun to pick up. Now, what we will investigate is after we get the first couple of flights under our belt, I'm sure we will try to fly in the afternoon and do more exploratory things. But the most conservative thing we can do is to sort of pick a mid-morning flight.
So what is the purpose of this mission? The Mars helicopter is first and foremost a technology demonstration to prove that we can fly on another planet. The helicopter can take color photos and videos, but its purpose is not to make scientific discoveries. Instead, it is to help engineers figure out how to design and build aircraft for future missions.
You can imagine something that's about 30 kilograms carrying, a 2-kilogram science payload, doing exploration, acting like a scout, like a small vehicle like this, scouting ahead for some future rover. Or it could be a gadget that goes and picks up some kind of samples and brings it back to a central lander for more sophisticated analysis. Or it could be a completely standalone craft, and maybe more than one, that are exploring places where humans and rovers can't get to easily. Some polar ice scarps, sides of cliffs and so forth. So the real emphasis here is to try to get back all the engineering data so that it can inform that future design.
Flying on other planets will provide a new dimension in space exploration. An aircraft is faster and capable of covering more ground than a rover, and it can provide higher resolution imagery than an orbiting spacecraft. So maybe one day aircraft will be the companions of future rovers or even astronauts exploring other worlds.
You can make it real.
And here we are with Mars Perseverance, 51 years later, getting ready to do the first ever Mars return mission.
Eventually, we can bring those samples back to Earth and determine for the very first time, did life exist on Mars?
In less than an hour, NASA's 300 million mile journey from America's shore to Jezero Crater on Mars will begin with the launch of this Atlas V rocket into space. And at the top of that rocket, with a beautiful sunrise and shrouded by that protective fairing, is the Perseverance rover headed to Mars, ready to ride a column of fire and smoke on its way to the red planet. What a beautiful morning here on the Space Coast. Welcome everyone. Behind us, the star of the show. This is a life-size mock-up of the Perseverance rover, which is just like the one we are launching to space. Hi everyone, I'm Daryl Nail.
And I'm Mujige Cooper. In the 50 minutes leading up to launch, we will show you how this mission will reach and search for ancient microscopic life on Mars and test new technologies critical to the ultimate goal, future human missions to Mars.
That's right, and we've got the rocket on the pad and it is ready to go. A beautiful day outside. We're L-47 minutes and counting until launch, and so far the countdown to Mars is on track. We've got great weather, the rocket's looking good, and it puts us on track for a launch at 7:50 a.m. Eastern Time, the beginning of a 2-hour window.
In today's coverage, we will hear Grammy Award winner Gregory Porter. We'll talk live with Derek Muller of the YouTube channel Veritasium, along with the aerospace engineers, scientists, and a NASA astronaut.
Oh, it's going to be a great show.
Yes.
I love it. I love it. And we have teams from coast to coast, folks, helping us count down to Mars. We will go live to the Atlas Spaceflight Operations Center, just a few miles away from us.
And we'll go live to California, to the Jet Propulsion Laboratory, where the Mars 2020 mission team is standing by to communicate with Perseverance after it gets to space.
And of course, we are here to tell you what the Perseverance mission is all about. It's an exciting day for all of us here. So we want to walk you through what you will see next during the countdown and the rocket launch. So let's send it over to Joshua Santora and Mick Woltman, who are with the ULA and Launch Services program teams. Gentlemen.
Hey, good morning, Daryl. I'm Joshua Santora, and I am here at Atlas Spaceflight Operations Center, joined by Mick Woltman from NASA's Launch Services program. Mick, you excited to go to Mars?
I am excited to go to Mars this morning, Josh. This is a great day. The sunrise out there looks awesome on this rocket, and ready for a great launch today. Thanks for having me on the show.
Man, happy to have you along, providing a ton of good context as we go through. Before we dive into the story of Perseverance, we want to give you a preview of what's ahead today in the countdown. Things really got going this morning just after midnight, actually, and Atlas V is just about ready to fly. In a few more minutes, we're going to get the final check of the weather, and that weather report should be coming back really positive. It's been great all morning. We have the terminal count ahead after that. We will be proceeding through the last few minutes of the countdown, and then the drama will be at its peak at launch. When the clock strikes 0, the engines ignite, and the spacecraft and rocket take flight. After successfully passing through max Q just shy of 2 minutes into flight, the solid rocket boosters will be expended and will be jettisoned. Nearly 2 more minutes, and the payload fairing, what you might call the nose cone of the rocket that has been protecting Perseverance, will no longer be needed. It will split in 2 halves and fall away from the accelerating vehicle. 1 minute later, the Atlas booster will have finished its task of lifting Perseverance above Earth's atmosphere and being on the way to orbit. It too will separate, exposing the Centaur RL-10 upper stage engine that will almost immediately begin its first burn that lasts approximately 7 minutes. After coasting for more than 30 minutes, the second burn, lasting around 8 minutes, will take Perseverance out of Earth orbit and into solar orbit on its way to Mars. That sets up spacecraft separation and the final milestone we're hoping to hear this morning, the acquisition of signal. And I say hoping to intentionally because it's quite possible that Perseverance will be in perfect condition, but we won't make contact during the broadcast. So lots more to come, lots ahead, but Daryl, we're going to throw it back over to you now to tell us more about this amazing mission.
All right, thank you, Joshua and Mick. We've got a lot of really smart people and talented people that we're going to be talking to today, but let's begin with a scientist who's coming up in just a bit. I want to talk a little bit about Mujige Cooper, who's here. She is a planetary protection lead for this mission. Thank you so much. You've been working on this for a while, Moo.
Yes, this has been 7 years in the making, and I'm so excited to share this moment with you and with those that are viewing today. I'm just ecstatic.
It's fantastic, and we're in a launch period. People probably want to know, why are we launching today? Why are we launching right now? We're in a period that only comes around once every 2 years.
Yeah.
Explain that.
The orbits of Earth and Mars are on the same side of the sun so that we can reach that destination with less fuel. So it's the best time. Short journey, less power.
We like that. And we're studying the climate, the geology, and searching for ancient life. But Moo, what kind of life are we talking about here?
Well, when we search, we're not going to find dinosaur fossils, right? We're likely,
no?
unfortunately, likely we're going to find it in the form of microscopic life.
We're hoping
ancient
to.
life.
We're
hoping.
Yeah, we don't know if it's there, right?
Yeah, don't know.
Okay, well, that's why we're going.
Yes.
All right, thank you very much, Moo. And back here on Earth, our friends at Twitter are celebrating Mars 2020 in a very special way we want to let you know about. Check this out. If you tap the like icon on any tweet containing the hashtag countdown to Mars, you'll see an animation brighten up your screen. You can check it out. Also, the like button itself has a special little animation that you can see right there in the corner. See that? Did you see that little sun and the rocket?
You should
went
hit
around
it there.
That's right. You just hit it and it goes.
Oh, there you go.
It will also work in any language from our partner countries, including Spanish, French, Norwegian, and Italian.
Wow, that is pretty incredible.
That's pretty neat.
Yeah. And despite the daunting challenges, NASA has a long history of missions to Mars, going all the way back to 1965 with the Mariner 4 spacecraft.
Yeah, we've covered a lot of ground on Mars since then. So let's head out to California and join JPL's Raquel Villanueva. Raquel, what can you share about our history of exploring Mars?
Well, Daryl, in the past, we explored the red planet with orbiters and landers, but it was the ability to move around Mars with rovers that truly helped unlock its secrets. Today, I'm joined by Perseverance Deputy Project Manager Jennifer Trosper. She has worked on every single Mars rover mission for the past 3 decades. Now, Jennifer, how does today's launch fit into the history of exploring Mars?
Well, we have always been interested in Mars because it's the thing that's most like Earth that we know of. And it's a little bit different today, and so understanding what happened to Mars will help us understand more about our solar system and also more about Earth. Now, as we said, Mars exploration started in 1965 with the Mariner spacecraft flying by Mars. And in 1975, we actually landed the Viking 1 lander on the surface of Mars. And then after that, we started sending orbiters with more sophisticated instruments. Those instruments would do global mapping. They'd find the minerals. They'd find the topography of Mars. They'd actually study the weather of Mars. But we found out that those orbiters needed partners. They needed partners to go down to the surface of Mars and explore like a geologist on Earth would, where he walks around and takes pictures and maybe she takes some measurements. That's what these rovers needed to do, and that's really what started the Mars rover program for us. Our very first rover we sent in 1997, it was a Sojourner rover. Sojourner weighed about 25 pounds and drove all of about 400 feet, but she really showed us what value a rover on Mars could have. And so then the Mars program started the Follow the Water theme to try to understand Mars better. And the first 2 rovers that were sent to Mars to follow the rover were Spirit and Opportunity. They landed on opposite sides of Mars in 2004, and they drove 30 miles combined. And they both found evidence that there had been water on Mars in the past. But we still weren't sure whether that water fostered an environment that was good for life. And so then we sent Curiosity in 2012. The Curiosity rover was big, it had a big robotic arm, it had a drill, it had a science lab in the front. And Curiosity was trying to understand the habitability of Mars. Could Mars have ever fostered life? Could life have ever grown on Mars? And within months of Curiosity landing on the surface, she actually found an ancient habitable environment on Mars. But we still don't know if life ever did form on Mars, and that's the goal of the Perseverance mission.
Wow. Thanks, Jennifer. And now that we understand how each rover mission helps shape the other, let's get to know Perseverance.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
And a great breakdown of the rover there. Welcome back to the Kennedy Space Center in Florida, where our next Mars rover will be propelled into space by an Atlas V rocket. And the man who leads the company tasked with safely getting Perseverance off this planet is Tory Bruno. He is the CEO and president of United Launch Alliance. We appreciate you being here, Tory, this morning.
Oh, happy to be here.
How is the launch team doing? How are you doing?
Well, the launch team is doing great. They've been on station for hours. They're calm, they're confident, they're going through the script. I'm a little nervous, but I always get nervous before all of my 400 launches so far.
Wow. You get a little nervous. Why do you get nervous?
Well, you know, a rocket is such an incredibly powerful and complex machine. Everything has to go right. Nothing can go wrong. And it's just, it never gets old. It's always the same.
It's always exciting.
Yes.
And this is a particularly exciting mission. Talk a little bit about that. This is the largest and heaviest rover that we've ever sent to the Red Planet. So how did you configure your rocket to do this launch effectively?
Yeah, this is our second most powerful Atlas, the 541. We call it the Dominator. It's got 4 giant SRBs, each putting out 350,000 pounds of thrust to augment the center core. And so it has got the power to get out there to Mars, as well as the precision. It's the most accurate rocket in the world, because when we let it go, it's got about 200 million miles to travel on that transfer orbit.
And precision is key.
That is right, yes. So the power source for the Mars rover is a contained radioactive battery. I've seen it up close, and we had to alter the way we behaved around that.
Yes.
How has that changed your team's efforts?
Oh yes, the operations around that are completely different. Now, we have a lot of experience with these. We've flown all of America's RTGs, and we're the only provider that is certified to handle them. But, you know, it is still 11 pounds of plutonium, as you saw. And in this particular case, the one very special thing was to install it in the VIF, where we would normally never breach the containment around the spacecraft, because it has to be clean and biological free. But we created a portable clean room and brought this nuclear battery out and installed it in the machine while keeping everything perfect.
Awesome. Can you explain what the VIF is, actually, before I let that go?
The VIF is the Vertical Integration Facility. So these rockets are so gigantic, we build them in a factory, but we can't assemble them there. Atlas and Perseverance are standing 20 stories proud right now on the pad. So they come to Canaveral in pieces on our rocket ship, and then we assemble them in the Vertical Integration Facility. And normally the last thing would be to bring an encapsulated, under the fairing, perfectly clean and prepared spacecraft and put it on top, which we did, but then we opened it to install the MMRTG battery.
Now that came late in the process, and that was intentional.
Yes.
You mentioned there's a certification for who certifies the rocket?
So NASA certifies the rocket, and then NASA and the Department of Energy certify a provider like us to handle a nuclear payload because of all these special requirements.
Very good. You know, when you were preparing for this mission, you couldn't have imagined, a year ago that you would have a coronavirus pandemic wreaking havoc on this state. How did you handle that, and how did you overcome it?
Yes, well, the one big lesson learned here is you can't buy back time. So when this broke out, our response was early, it was aggressive, and fortunately it was effective. So we did all the things you might be familiar with. We wipe down every surface every hour, we deep clean every evening, we are wearing PPE, we have our teams spread out, we actually change the flow of the work to keep our people safe, but to also keep these vitally important missions going. And of course, I can't say enough about our team. They're so disciplined and so courageous to persevere through all of this, and now to make our third launch under all of these mitigations. I'm just so proud of them.
Well, Tori Bruno.
Mars continues. The perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
NASA's Mars Perseverance rover left Earth 6 months ago. Now we are preparing for touchdown on the red planet tomorrow. The rover will attempt to land in Jezero Crater, which is the most difficult landing site on Mars ever attempted. But the Perseverance rover and the team are ready. Welcome to NASA's Jet Propulsion Laboratory in Southern California. I'm Marina Jurica, your host today, as we bring you a mission landing update as the team continues to prepare for tomorrow and what lies ahead. On our panel today are NASA Planetary Science Division Director Lori Glaze, Perseverance Deputy Project Manager Matt Wallace, Entry, Descent, and Landing Phase Lead Al Chen, Deputy Chief Engineer for Medley 2 Caitlin Lyles, Deputy Project Manager for Surface Activities Jennifer Trosper, Perseverance Project Scientist Ken Farley. For anyone watching who would like to submit a question, you can do so by using the Countdown to Mars hashtag. Our phone lines are now open to the media. You can ask a question by pressing *1 and enter the queue. To start, I'd like to welcome Lori Glaze. Good morning, Lori.
Good morning. Great to see you. Wow, I'm getting so excited. We're now just a little over 26 hours away from touching down on the surface of Mars. And I was just thinking this morning, remembering back to the launch back in July and that exciting moment when Perseverance and Ingenuity began this incredible journey from Earth to Mars. And now we're here just 6 months later, ready for that final leg of the journey to put us on the surface of Mars so that we can really begin the overall objective of this mission, which is to really do the exploration of Jezero Crater. Perseverance is taking our next step in exploration of Mars, especially addressing the question about whether life ever existed elsewhere in the universe. Can I have the first graphic, please? Thank you. In studying Mars, we've taken a methodical approach to better understand how to even look for life. And all of our rovers have played important roles in trying to improve that understanding. Perseverance, of course, is going to be our 5th rover, the first being Sojourner, which launched in 1997. And that methodical approach started really with the Spirit and Opportunity rovers, following the water, trying to understand the history of water on Mars and understanding if there were ever a time when there was enough liquid water present on the surface of Mars to support life. And then that was followed, of course, by Curiosity, where we really took the next step, which to understand the habitable environments, whether there were habitable environments on Mars, and of course, Curiosity being able to confirm the presence of a lake of liquid water on the surface of Mars that was sustained over a period of time, and also identifying the complex organic molecules that would be the building blocks for life. And we've built on all of that knowledge to prepare ourselves now with the Perseverance rover, which is going to take that next step to really actually look for those signs of life. And we've brought with us an incredible payload of instruments that can, of course, do incredible science on the surface and also help us to identify the rocks that we'd like to take samples of and eventually bring back to Earth. And if you can run the video, please. This is just showing the rover as it's drilling down into the surface to collect those samples. We're going to try and bring back a scientifically diverse set of samples. You'll hear more from Ken Farley later about that. And this is just so incredibly important to bring these samples back to Earth because we can then use the full breadth of our capabilities in the laboratories we have here on Earth, using all of the scientific expertise from around the world to address this incredibly hard question about whether or not those fossils of the microbes actually have been preserved in the deposits of Jezero Crater. And so with that, I'd like to hand things over to Matt.
Thanks, Lori. I just want to re-emphasize something that Lori mentioned, which this is really a different rover. You saw the profiles of the previous 4 rovers. I had the good fortune to work on all of those, and this one's really at the top of the food chain, I'd have to say. You know, we're carrying almost 50% more science and technology payload than Curiosity, despite the similarities in the 2 vehicles. This is really a much more capable system, and I think not only do we have the transformative science, which Lori and others are going to talk about today, but as mentioned, we have a lot of feed-forward technology on this mission, whether it's the Ingenuity helicopter or the ability to make oxygen from the CO2 atmosphere on Mars. A lot of exciting technology work that will feed into future missions, including some you'll hear about today, the Medley 2 package. Really just a great mission coming up. But before we can get that surface mission going, we have to land safely on Mars, and that is always a challenging feat for us. This is one of the most difficult maneuvers that we do in the space business. You know, almost 50% of the spacecraft that have been sent to the surface of Mars have failed. And so we know we have our work cut out for us tomorrow to get down to the surface safely at Jezero. We're going to ballistically approach that planet at about 12,000 miles an hour. And the trick we have to perform is to slow down to just a couple miles an hour so that we can gently touch the vehicle down on the surface and safely do so. That all has to happen in about 7 minutes. And it all has to happen autonomously. Perseverance really has to fight our way down to the surface on our own. It's something like a controlled disassembly of the spacecraft, and it's always something that we think a lot about, we work hard on, and we prepare for. And once we get down to the surface of Jezero, she won't necessarily find the most welcoming site we've ever been to. Jezero is a fascinating scientific location. It's got great craters, it's got rock fields, it's got sand dunes. All of those things are interesting for the science community, as you can see here in this imagery. But all those things also represent landing hazards for the spacecraft. And so we do have a new hazard avoidance capability we call terrain relative navigation, which we'll employ for the first time. That's really enabling us to go to Jezero when we couldn't before. Jezero is actually a site that was scientifically interesting to many previous missions, and we just couldn't get there until this point when our technology was ready to support it. So all that's coming up. We are currently about 150,000 miles from the planet. We are picking up speed as we approach, and the gravity starts to pull us in. We have transitioned into our EDL mode of operation on the spacecraft with the command we sent last Friday called do EDL, do entry, descent, and landing. We're keeping a close eye on our navigation situation. We have to hit an entry corridor that's really just a handful of kilometers across after traveling hundreds of millions of miles to Mars. And that's always something at this point of the mission that we're keeping a close eye on. We are updating the parameters, so we're ready to land right where we want to in Jezero. Our batteries are now topped off at 100% state of charge. Our pyro systems are armed and ready to execute the deployments necessary to execute entry, descent, and landing. We have tested out our engines and our guidance sensors. They are ready to go. And really just have a few more interactions with the spacecraft, but if necessary, Perseverance could land itself already without any more help from us here on the ground. So the spacecraft is ready. I think the team is also ready. We've been thinking about entry, descent, and landing for probably every workday over the last 8 or 9 years. It's always something that consumes our development and our testing and our design work. We've been practicing the entry, descent, and landing process using something we call operational readiness testing, especially over the last 6 months or so. It's going to be a little bit different this time, obviously. On previous missions, we're going to be having to deal with the same pandemic that everybody else is dealing with here. So our workplace is a little different. We've got masking requirements and social distancing requirements. Our mission support area will be a little less dense than we have before, but make no mistake, this is going to be a landing on Mars, much like the previous that we've had on other missions. And so I think with that, I'm going to turn it over to our entry, descent, and landing phase lead, Al Chen.
Thanks, Matt. Matt just told you a little bit about the spacecraft and team readiness, so why don't I do the traffic and weather as we get closer to Mars here. If you bring up this next image here, you can kind of see our Martian dartboard, if you will, figuratively here. If we're inside that green box is our bullseye. That's where we want to be, and that's anywhere in that area, the entry, descent, and landing system can finish the job of getting us down to Jezero Crater. As you can kind of see from those rainbows of little ellipses there at the top of the box, we are comfortably inside that box right now. So we think that the landing system can finish the job from here. So we have hit that bullseye. That's pretty incredible considering our last maneuver was back in December. If we move on to the weather, I guess we just entered spring in the northern hemisphere, which is actually the beginning of the Martian New Year. So I guess a happy belated New Year, Martian New Year to those of you who celebrate. But the weather conditions look pretty favorable for us right now. As you can see from this image, the conditions are seasonal. There are some clouds that are out there and some polar cap edge storms, but nothing near our Jezero landing site that's over there in the white. The skies look very clear and good for landing tomorrow. But even with clear skies, landing is the most critical and dangerous part of the mission. We just can't guarantee success. So let me walk you through the critical events of EDL, all of which need to happen without any help from us here on Earth. Perseverance will have to do this all on our own. So before we get to the top of the atmosphere, we separate the cruise stage that's helped us all the way through the 6 or 7 months since launch. We'll hit the atmosphere going at about 12,000 miles per hour and use that atmosphere to really slow down. We'll have to survive the intense heating and G's, the deceleration that come with that, but also steer our way to the target as we use thrusters on the back of the vehicle to steer our vehicle all the way toward the target. Once we slow down to supersonic speeds, going about 1,000 miles an hour or so, Perseverance will deploy a large 70-foot diameter parachute while still traveling almost twice the speed of sound. So that'll slow the spacecraft down even further. While still slowing down on that parachute, Perseverance will need to figure out where she is. So she'll separate that heat shield. That's kind of like the lens cap for us, but that heat shield protected us through entry. And it'll get a good look at the ground using the radar system to figure out how high we are and how fast we're going. And then also a new system that we call terrain relative navigation that gives our vehicle eyes and the ability to really see where she's going and figure out where she is. But even when the parachute's done working, done slowing us down, Perseverance will still be going about 160 miles an hour down. And that's too fast to land. So at that point, we'll drop out of the back shell, fire up engines, those engines that are on the descent stage, that's the rocket-powered jetpack that's holding onto the rover, and fly to a nearby safe spot using that terrain relative navigation system to target a nice safe spot. Once we're about 70 feet above the ground, we'll start the sky crane maneuver. And that's where we separate the rover below that rocket-powered jetpack, deploy those wheels of the landing gear, and put her down safely at a little less than 2 miles an hour. Once that's over, the descent stage will fly away to a safe distance. So that's all about how Perseverance is going to land tomorrow. Let's talk a little bit about how we're going to hear about it. So if you pick up the next figure here, there's a couple ways that we'll be able to hear what's going on from Perseverance as it's happening. The first is this direct-to-Earth path. So the vehicle can communicate direct to Earth via something we call tones. Because Perseverance is busy landing, she can't really spend the time to point her antennas toward Earth. And Earth is really far away as well. So these tones are very limited in information. All we have there going direct to Earth is kind of one of 256 tones. They're like keys on a big piano. And sometimes we can use those tones to tell us different things, like the heat shield has come off or something like that. Unfortunately, once we get down to about backshell separation, Earth will set below the horizon for Perseverance, so the tones will end. But that'll take us all the way from from cruise stage separation all the way down to backshell separation or so. Next, we have a second path that's through the Mars Reconnaissance Orbiter. We've developed a new system a new set of software on the Mars Reconnaissance Orbiter to allow us to relay data as it's coming from the vehicle, so all the way up from Perseverance while she's landing, up through MRO, and then down all the way to Earth. That gives us about 8 kilobits per second of data. That's kind of like half the speed of old school dial-up, if you remember that. But that'll allow us to see a lot of different things, like what the vehicle is doing. If you queue up the next little video here, we'll be able to show you what's going on in real time and show ourselves as well. We'll be able to see what mode we're in, where we think Perseverance is looking, how fast we're going, and how high we are above the ground, even an estimate of how much fuel we have left as well. So we hope to use that to assess what's going on and to show everybody else what's going on as it's happening. There's also another path that we get data from another orbiter that's going overhead, the Maven orbiter, but that data won't be available until several hours after landing. So I just want to be clear that with all these different communications paths to get data back down to Earth about how entry, descent, and landing is happening, none of them are required for landing. Perseverance will try to land herself no matter what, even if we don't get any of that data tomorrow as it's happening or afterward. The vehicle is programmed to try to finish the job on her own. One of the things that we will get, actually, as part of the communication stream that we're sending back is information about the intense aerodynamic forces and heating that are happening to the vehicle, and that'll be from sensors on the Medley 2 system that Caitlin will talk about next.
Thanks, Al. So I'm happy to be joining you all virtually on behalf of the Medley 2 team to talk about why we're excited to be part of this mission. So as you've heard, landing on Mars is a very difficult thing to do, largely due to the fact that we don't fully understand the harsh entry, descent, and landing, or EDL environment. So the goal of Medley 2 is to collect data to help us better understand that environment, specifically the heating and pressure that Mars 2020 experiences as it passes through the Mars atmosphere. This will also help us to understand what we can expect for future missions. So Medley 2 stands for Mars Entry, Descent, and Landing Instrumentation 2. The 2 is there because it's a follow-on to a set of sensors that flew on the Mars Science Laboratory, which delivered Curiosity to Mars in 2012. Both the Medley and Medley 2 sensor suites were developed through a partnership between NASA Langley, Ames, JPL, and Lockheed Martin Space Systems. And in fact, our centers have been working together for many years on Mars missions, particularly on EDL technology and trajectory development, going all the way back to the Viking days. If you could pull up that first image, please. This shows an overview of our sensor locations. Medley 2 has 28 sensors on the Mars 2020 aeroshell. The aeroshell consists of the heat shield, which is shown in the back of the image, sort of the tan, brown colored item, and that's what faces the atmosphere during entry. And then also the back shell, which is the white PCC up front, and that's what covers Perseverance. Medley 2 has sensors on both the heat shield and the back shell. We have 7 different types of sensors that fall basically into 3 different categories: pressure transducers, which measure pressure, thermocouples, which measure temperature, and heat flux sensors, which measure the heating in the vicinity of the spacecraft. We'll start taking our data a few hours before entry, and we'll continue through parachute deployment. And all of that data will help us to understand several things about the extreme EDL environment. One of those is what's the impact of wind on the vehicle's trajectory. We learned with Medley that MSL's path was affected by winds in the seconds before the parachute deployed, and so we'd like to learn more about that this time around. We'll also learn about the energy and the hot gases that are close to the vehicle, and that heat is really generated in a couple of different ways. One is just from the friction that comes from flying so fast through the atmosphere, and another is radiant heat. So if you think of what it feels like to put your hands in front of a fireplace and you can kind of feel the heat coming off of it, that's the type of heat that we're trying to measure there. And finally, we'll be looking at the performance of the insulation material that protects Perseverance from the extreme heating environment. And the way we do that is to take temperature measurements at different places throughout that material. So what differentiates Medley 2 from the first Medley is that we're going to be collecting better data over more of the entry timeline. We'll do that by spreading out our sensors in more locations, gives us better coverage. And we're also measuring 3 different pressure ranges this time, whereas we only had 1 on Medley. We also have heat flux sensors, which actually touch the atmosphere. So rather than sitting below the surface of the material, these are actually right out there on the surface of the vehicle, touching the atmosphere, and that gives us more accurate measurements. And all of that allows us to seek answers to questions that were raised by Medley and to explore areas that we couldn't address last time. And when we combine the data of Medley 2 with the first Medley, we're going to be able to really improve designs for future entry systems, both for robotic and for human missions. And the way it'll do that is to help us to improve the computer codes we use to predict the environments. Because the Mars atmosphere is so different from Earth's, it's very difficult to test for Mars entry conditions here. And so we rely on computer codes to essentially over-design the vehicle to make sure that we can survive worst-case conditions. But that means the vehicle probably ends up heavier than it needs to be. So if we can understand the heating better, then we can make the heat shield much lighter by up to about 35%. And that'll translate to lower cost, more science, and more supplies for human missions. And then if we can better understand how the vehicle flies, we can have safer and more reliable landings. And that'll help us to reduce the footprint for landing, which means we can put landers closer to interesting science or put people closer to the supplies that we sent to Mars ahead of them. So not only can we extend what we learned to future Mars missions, but like Mars sample return, but we can also extend it to EDL missions at other planets or moons like Venus or Saturn's moon Titan. If you could please pull up the second image. This is an image of a few of our team members after we completed the final Medley 2 end-to-end checkout in late 2019. And this was essentially when all of our hardware was installed on the heat shield, which you see on the right, and then the back shell on the left. So everything was installed and hooked up, and we verified that it worked. So we're all giving the thumbs up because that was a pretty good day for us. And I just want to wrap up by saying that we're very excited for Medley 2 to extend the groundbreaking entry data that was collected by the first Medley. It's going to tell us what Mars 2020 actually experiences during those important few minutes of EDL. And it fills critical gaps in knowledge necessary to advance EDL technology in the future. And in fact, the backshell sensor suite is going to collect NASA's first ever measurements of the heat experienced by the backshell of a Mars entry vehicle. So we're excited about that too. But overall, Medley 2 will give us the most complete data set ever collected from a Mars entry. And with that, I'll hand it over to Jennifer, who will talk about what happens after landing.
Thanks, Caitlin. Well, it turns out after landing, it's not over. In fact, it's just beginning. The science mission is just beginning. I say that, but I definitely know that all of us up here, along with all of you out there, will be breathing a great sigh of relief when we get down safely on the surface. But once we do get down safely on the surface, we're all on the edge of our seats to get those first images from Mars. And so I want to talk a little bit about how we get those first images, when they might come. And then I'll also talk just in general about the things that we do after we land on Mars to get the rover ready for the science mission. So the images. During entry, descent, and landing, at the very end of that UHF pass with MRO we talked about, it's possible that we will get HazCam images. The HazCams are on the front and rear of the rover. That we'll get HazCam images with the lens covers still on in that pass. If we get that, that's golden. Everybody's very excited. We may not get that for the reasons Al talked about. Some of these links drop out. Then we have an opportunity in the later afternoon, about 3.5 hours after landing. There's the Odyssey orbiter flies over, but it's a very low data volume pass, so we will get data on that if things have gone well, but we likely wouldn't necessarily get images. So we have to wait until our 6:30 p.m. pass, which is the Trace Gas Orbiter, a European asset, where we can get a lot more data volume, and hopefully we'll be getting some initial images on that. Those would be the front and rear HazCams with the lens covers deployed, because the rover will have deployed them by then. We potentially would get some of those thumbnail movies for EDL cameras if all has gone well. So we're going to start getting some fantastic imagery and see our new landing site here on Mars from the rover's point of view. Now, the internal checks that we do right after landing are somewhat limited. The rover's had a long day, so mostly just does a few releases of our high gain antenna, those lens covers I talked about, and then we take a nap and we charge the batteries up to get ready for all the things that are happening the next several sols. So if you can go ahead and roll the next video, one of the things that we do across the first few sols on Mars is we know the tilt of the rover, we have IMU data, but we don't actually know the orientation of the rover that accurately. And so what you see here is the remote sensing mast that was folded up on the rover so we could fit in the back shell, has to be deployed. The high gain antenna you can see is over to the right of the image and flat. That needs to be deployed and point at Earth. We actually use the cameras on that remote sensing mast to look around and find the sun. Once we know where the sun is, we're actually able to put that data into the rover's computer, and we have all the other information we need to point that high gain antenna at Earth. And that's what we'll do to command the rover. We send commands through that high gain antenna. So that will happen that first week on Mars. We'll be doing those things. And then we hope to be driving in a few weeks to the helicopter flight demo site. So we'll be looking for a good site, flat site, not many rocks, so we can fly the helicopter. And then after that, we will be driving to our first science sampling site that we hope to get to in the summer or so. So with that, I will say I'm very excited. The team is now shifting their schedules to be on Mars time. Right now on Mars, at our landing site, it's about 2 p.m. local solar. So the team is going to get used to getting up later and then working a little bit into the night. That's not bad to be on a different shift, but the problem with Mars time is that the Mars days are 40 minutes longer than the Earth days, and so you're always shifting by 40 minutes every day, and that gets you jet lagged. But we do this because we want to be very efficient with the mission that we're doing and get the rover unfolded, get the helicopter mission going, and get there getting our first samples. And I have to say, after 5 missions, yesterday somebody asked me, what are you doing to prepare for Mars time? And I thought, I finally have purchased a sleep mask, which I didn't have. Maybe it took me 5 missions to figure this out, but sometimes it's hard, to sleep and everybody's sleeping in the middle of the day. So I'm ready, have my earplugs, and we'll be on Mars time. And to talk more about the science mission, I'll hand this off to Ken Farley.
Thanks, Jennifer. Tomorrow's landing of Perseverance on Mars is the spectacular crux move of this mission. And it really marks a fundamental transition from the getting there phase of the mission to the doing phase, to actually exploring Jezero Crater, as Lori mentioned. There are 450 science team members from around the world, and I will say we are very much ready to take the stage. I want to tell you a little bit about what we have been doing for the last few years and what we will be doing in the next few weeks. The first important thing to understand is that Perseverance is a very capable but a very complicated piece of hardware to operate. And it's autonomous, but we have to tell it everything that it is going to do. We have to tell it where to drive. We have to tell it what observations to make. We have to tell it what samples to collect. And this leads to a daily cycle in which data flows back from the rover to the science team. The science team needs to digest that data, interpret it scientifically, and then together come up with a plan for what we are going to do tomorrow. And then that plan needs to be turned into code and beamed up to the rover to execute. This is a very fast-paced, high-stakes operation. It's kind of a race to get it done. And it also involves literally hundreds of people having to work together seamlessly. And I can tell you, this is not what scientists usually do. Scientists do not usually perform under these kinds of circumstances. And what that means is we have had to train. And so I want to tell you exactly how we went about doing this. We need to get really good at this daily cycle. And if I can have the first video. Here you see an example of one of our training exercises in which we sent a small team of scientists out to the Nevada desert with instruments to simulate what was on the rover. Meanwhile, the rest of the science team, some at JPL and some at their home institutions, did a full-up role-playing exercise for about a week where we went through this daily cycle, and we learned a lot about how this is going to unfold, so we have gotten better at it. And through this kind of exercise and a variety of other kinds of training exercises, we've really sharpened our skills. And one special skill we've had to pay attention to, and it's different than ever before, is the science team is not going to be shoulder to shoulder doing this. For the foreseeable future, we are going to be operating remotely. So literally, the science mission is going to be executed from people's living rooms and bedrooms all around the country and all around the world. It's spectacular that we are able to do that. It's a big challenge, and I think we are ready to do that. Immediately after we land, Jennifer has told you a little bit about what's going to happen. We are going to get some images, and those images will be enormously important for the science team. We have a lot of orbital data, pictures taken from orbiters, but there's nothing like actually seeing images on the ground to get kind of situational awareness. And for a geologist, that is very important. The first few minutes on the field site when you can look around is enormously enlightening. So we'll use that kind of information, the images we get, as well as a little bit of initial exploration, to decide what to do. And if I could have the next image. We are very likely to move towards one of several pathways that we have already identified from orbit, one of which you can see here, the green line snaking across the delta. This is a pathway that the science team has identified over the last few years that strings together the key scientific targets that we wish to investigate. These are places where rocks outcrop that we think will tell us the most about the geologic history of Jezero Crater. They are the places where we think there may be evidence for past life on Mars, where we might find biosignatures, and places where we are likely to collect samples. So getting onto that trajectory will be something that we do very early in the mission. So I can tell you that the science team is very excited for this transition, and I personally am extremely excited for those first images that are going to come back. They will be fabulous from a scientific point of view, and also as a huge milestone after so many years of effort in this mission. And now I will turn it back to Marina to handle questions.
Thank you so much, Ken, and thank you so much to all our panelist presenters. We are now ready to take media questions. Remember to press *1 to get put in the queue, and please direct your questions to one of the panelists. We're also taking questions through the Countdown to Mars hashtag. Our first question comes from Chelsea Goad from space.com. Good morning, Chelsea. Chelsea, good morning.
Good morning. Can you hear me?
Yes, we can hear you.
Okay, great. Thank you so much. My question is for Matt. You mentioned the similarities and also the differences between Curiosity and Perseverance. I'm curious how similar or dissimilar is entry, descent, and landing from what we saw with Curiosity? And what is so different about Perseverance's entry, descent, and landing and what we can expect tomorrow?
Yeah, that's a great question. I'm actually going to go ahead and throw this over to Al Chen. He is our EDL phase lead, and he'll give you a rundown.
Yeah, from the outside, the entry, descent, and landing system looks pretty similar to Curiosity, but there's a lot of under-the-hood smarts, if you will. There are two pieces of new technology that are helping us land at this rugged site. The first is something we call range trigger. That's using the ability of the vehicle to know where it is to deploy the parachute. Previously on Curiosity, we deployed the supersonic parachute just based on hitting a particular velocity. But this time, we're actually asking the vehicle to figure out how far she's flown since entry and deploy the parachute based on that. That reduces the area that we're going to land in, that landing error uncertainty ellipse, quite a bit, almost a factor of 10 in area versus what we had promised for Curiosity. The second major piece of new technology that's helping us land is terrain relative navigation. So whereas on Curiosity, we took pictures after the heat shield came off, but didn't really do anything with them on the fly. They're kind of like tourist pictures in some sense. Perseverance will be taking those pictures and then matching them up with an onboard map based on images from the Mars Reconnaissance Orbiter. It'll use that set of images it's taking and that map to figure out where she is. And based on that she can then fly to a nearby safe spot once she's done with the parachute and on engines. So that allows us to make sure that to allow a site like Jezero, where the whole landing error ellipse is not a giant flat parking lot. It's full of the stuff that the scientists want to see, but the stuff that I don't want to land on. So that allows us to find little kind of small parking lots amongst those. So those are really pretty key technologies to helping us land. There are also a couple of new systems on board as well to help us understand what it's like to land. The first is that Medley 2 system. That's an upgrade of the Medley system that was on Curiosity. And the second is an EDL camera system that will also have a microphone. So we'll have a lot of new imagery and high-resolution imagery and high frame rate video of what it's like to actually land on Mars. So I'm really excited to hear and see what landing on Mars is really like.
Absolutely.
I'll just add two more comments, which is there's a couple pieces of hardware which we've improved since Curiosity, and I'll just make mention of them. One is the heat shield. We found in our static testing of the heat shield that there were some strength vulnerabilities there, and so we improved not only the design but the manufacturing techniques for that heat shield. The other significant one is the parachute, this big 70-foot supersonic parachute. On one of the technology programs in the Mars program area, we found a potential vulnerability with transient loading as that parachute is inflating and in different configurations. And that led us to conclude that we should strengthen the canopy of the parachute. That's something we did, and not only did we strengthen the canopy, but we took the parachute off and we did supersonic high altitude parachute testing using sounding rockets out of the Wallops facility. It was a major test campaign, something that really hasn't been done in more than 40 years. And the team pulled it off successfully, so a couple more differences there.
Thank you, Al and Matt, and thank you, Chelsea. Our next caller is Irene Klotz from Aviation Week. Good morning, Irene.
Hi there. Thanks so much. My question is for either Matt Wallace or Jennifer Trosper. I appreciate the downplaying expectations with the 50% of Mars missions failed, but NASA has successfully landed 8 of its 9 spacecraft on Mars, including the 4 previous rovers and landers dating back to Viking. So do you have what is the risk of the Perseverance landing overall, and what's the riskiest part of it?
Yeah, it's a good question, and it's a valid observation. I guess I'll say a few things and see if any of the other panelists want to say a few words. We've never really come up with a good way of calculating the probability of success. These systems are so complex, and they're interacting with an undefined environment in many ways, that it's very, very hard to give you a number. You know, I think that, but it's those two factors really that lead us to tell you that there's never any guarantees on this process. You know, Mars still has things we don't understand about it. This is still exploration. We're going places that where we're trying to answer questions that we don't have the answers to yet. You know, on Curiosity, and Al can say a word or two about it, we found that the local gravity field at Gale Crater, where we landed, affected our control system. That was a somewhat unexpected thing. You know, it was within the capability of the system to handle it. But those are the types of uncertainties in the environment that we're dealing with. I think you just also have to factor in, again, the complexity of this system. You know, we've got 2 million lines of software code running, hundreds of thousands of electronic parts, you know, miles of copper conductors. We've got more than 70 pyrotechnic devices that all have to fire, closed loop guidance and navigation control systems that really have to operate with sub-second precision for all of this to work. You know, there's no go-backs, there's no retries. It's a difficult and dangerous part of the mission, and I think you have to always respect that as a development team, and I think our team has. So I don't have a specific answer for you on the probability of success. I think we've done everything we can to make it successful. And we'll see how it goes tomorrow. Did you want to add anything, Al? Or?
Yeah, I mean, I guess I'd say that there's nothing like trying to at least use the same kind of landing system again to really find the warts in it. And as Matt mentioned, right, we were able to find a handful of things that didn't go quite the way we expected them to go on Curiosity. And that's humbling, right? I think as soon as if you don't stay humble in this business, and especially going to Mars, you're going to pay for it. So I think it's been key for us to learn from the things we didn't get quite right. But I think, as Matt said, we don't know that we have caught them all yet. We've just done our best to make sure that we've done everything we can think of to make sure that we have a good day tomorrow.
Thanks. Is there one part of the system in particular that gives you greater pause than something else?
Am I supposed to pick a favorite child now?
No, you're supposed to pick your least favorite child.
I think it's hard to point to. I mean, I think that part of it is just the overall complexity, right? Everything that has to happen. Obviously, there's a lot of concentrated risk in that supersonic parachute opening. That it's a very big parachute, right? That's the size of a Little League infield in size. And it snaps open in about 0.6 seconds while going almost Mach 2. So there's a lot of risk concentrated there. But as Matt noted, something we haven't done for 4 decades plus, we actually did high altitude supersonic testing this time as part of this project. So we have perhaps a little bit more confidence that this is going to work.
Thanks very much.
Thank you, Irene, and thank you to Matt and Al. Our third call is from Marcia Dunn with the Associated Press. Good morning, Marcia.
Yes, hello. This question is for Ken. I enjoyed seeing your roadmap with the squiggly line. Is that for all 2 years of operations? And I'm wondering, what's the total mileage you expect to put on the odometer over these 2 years for a nominal mission? And when do you expect to actually drill for the first time to collect a sample in the tubes? When might that be happening? Thank you.
Yeah, the traverse that I showed there is for an extended period of time. We expect that we might traverse up to about 10 miles in the prime mission, the 2 Earth years, 1 Mars year. And we expect that sometime in the summer we'll be ready to take our first sample.
Thank you, Ken, and thank you to Marcia. Our fourth call comes from Amina Khan with the LA Times. Good morning, Amina.
Good morning. Thanks for taking my call. I just had a few questions about firsts, 3, so I'm wondering if you can bear with me here. First one would be, is Perseverance the first machine, I guess, we've designed that could harvest an essential human resource, oxygen, on another world, or has that been done before?
Do you want to take that, Lori?
Yeah, I'll take that. It's a good question. I believe, and hopefully I'm not misspeaking here, that MOXIE is the first experiment that was specifically designed to execute in situ resource utilization, to take advantage of the local environment to transform that material into something that's usable either by astronauts or humans or for other purposes. Of course, we're looking at lots of other types of in situ resource utilization for other destinations such as the moon through Artemis, but we haven't flown those yet. So, but yes, I think MOXIE is the first.
Very cool. Thank you. And is it the first in 45 years since Viking landed to actively search for signs of extraterrestrial microbial life? Or have there been any missions that have done that in the interim?
So Ken, do you want me to take that one, or would you like to take that?
Yeah, you can go ahead, Lori.
Okay. Yes, I would say that Perseverance is the first real astrobiology mission since Viking. Of course, Viking had an intent to look for life, but it wasn't actually, now that we've learned and know so much more, not just about Mars, but about how life forms and how it exists, we know that the experiments that we designed probably weren't quite the right way to go about that exercise. And so we really have followed this more methodical approach this time, first making sure that we had the ingredients present on Mars and that we actually had those habitable environments that were sustained over a long enough period of time at about the right time in Mars's history to really help set us up for success. And so as a result of all of that new knowledge that we've gained over the last couple decades has really helped us to design, as I said, our first mobile astrobiologist that really is, it's one of its main purposes is to seek out those signs of past life on Mars.
Thanks. And when it comes to Ingenuity, is it fair to call it basically the sojourner of flying planetary drones? In that, this is basically here to prove that you can fly, and in the future we might expect more flying planetary explorers with more science capabilities on board.
I think you're right on with that comparison. I think Ingenuity is today's Sojourner. When I worked on Sojourner, and there was a lot of uncertainty at the time as to whether or not we'd ever really be able to utilize this technology. And we found very quickly that having a mobile capability on the surface of Mars was incredibly valuable. There's a lot of heterogeneity scientifically on the surface, and just being able to move even a small amount that Sojourner gave us was valuable. And I think in almost every way, when you look at Ingenuity, it looks very much the same. It's a technology demonstration. Its objective is not tied into the science of this mission, but the potential for aerial reconnaissance and exploration in the future using this type of technology is terrific. It's and not just on Mars and other places as well. And so I think it's a great comparison in every way. Looking at the team, they remind me a lot of our team from 20 years ago, to be honest with you. Yeah, so good comparison.
Very cool. And say that you guys don't find any signs of life in the samples using the tools on hand on Mars, and say that years from now, scientists look at the samples sent back successfully to Earth and don't find anything there as well. What could that mean for the future and the direction of space exploration? What does it mean for our search for life on other planets far outside our solar system?
Ken, can you take that?
Sure. I think the important thing to understand about the search that we are about to embark on is that this will be the first time that we have peered in great detail into a past habitable environment, both with the tools on the rover and with the samples when they come back. And we either will find life is there, and that will be a spectacular discovery, or, as you suggest, maybe we won't. But this is a very important observation, because it would suggest that not all habitable environments that exist are inhabited. And I think what that would mean is that we would need to look elsewhere. It isn't going to be a slam dunk. We can't just assume that everywhere that is habitable has had life originate and thrive in it. And I think there are already ideas of other places that can be looked at, both on Mars in the subsurface and as well as other environments, for example, in the moons of the giant planets. So it would be an observation, but I don't think it actually fundamentally changes the direction that astrobiology is pursuing.
Would it mean the end of Mars exploration in terms of the search for life?
I think that's probably a question for Lori.
Sure. And I'll go out and speculate slightly to say that I don't necessarily think it will be the end of exploration or the end of exploration on Mars and looking for life on Mars. What I think is the most likely outcome would be, if we don't actually get confirmation of past life, would be an inconclusive result, which would mean we still need to keep looking and look harder, maybe in other places. But again, if we are able to even conclusively determine that there's no longer life, there is still incredible science to be done at Mars. Mars has so much to tell us about the early history of the solar system, of the formation of the planets, and of the evolution of the rocky planets. Being able to have Mars in our kind of nursery of planets here in the solar system is a fantastic laboratory to really understand the diversity of planets and the diversity of geologic and climate evolution. So absolutely an incredibly compelling destination for many decades to come.
Thank you so much. I really appreciate it.
Now we're going to head to a couple social media questions. SidXX on Instagram asks, what is the heat shield made of? Caitlin, would you like to take that?
Yeah, so the heat shield and back shell are made of two different types of what we call thermal protection system material. The heat shield is made from PICA, which stands for phenolic impregnated carbon ablator. And I won't go into a whole lot more detail than that, but it's a complex combination of different materials that have. There's a whole lot of work that goes into developing these thermal protection system or TPS materials. A lot of testing, a lot of trying different things to determine what will work. And so PICA is on the heat shield, and then super lightweight ablator or SLA is the back shell.
Thank you, Caitlin. And back to the phone lines. The fifth call is from Jeff Faust of Space News. Good morning, Jeff.
Hi. Quick question for Matt Wallace or Al Chen. You showed the landing ellipse chart. It's in that green box where you want it, although it's near a corner. Have you ruled out any further maneuvers? Are you satisfied with that? What's the last time that you could make a decision in terms of making a maneuver if you needed to for some reason? Thanks.
I can take that one. We do have one other contingency maneuver opportunity late tonight if we decide to use it. However, I think it's very unlikely we're going to do that. The TCM decision criteria here, this bullseye, we're very comfortable pretty much anywhere within that green box, even here on the edge. I mean, really all that this is saying is that we've got a little bit more cross-track error. I think the key thing to remember for our system is that we have guided entry, and we have the ability to correct our trajectory in the atmosphere. So we're just going to take advantage of it. That's all.
Thank you, Jeff, and thanks to Al. Our next call is from Leo Enright from Irish Television. Good morning, Leo.
Thanks, Marina, and good evening from Europe. My question, I'm trying to nail down the hover time that is available to the sky crane. It's going to be placed in an area of 120 football fields of size. If it comes down right at the, if it lands right at the side of that, no need for a lot of fuel. But if it has to go 120 football fields, that's very different. What is the hover time available? And if I may add a supplementary, based on this traverse map we just saw, it looks awfully close to those cliffs. How big are those cliffs, and how close do you imagine you might land to them?
I think I can take those. Good question about the hover. Kind of an interesting misconception about our system is that we actually are never hovering, basically, except for the 1 second where we cut the rover loose. That's the only time the system's hovering. We're on our way down for the whole rest of the time, actually. But I think you're really asking, basically how far can we go and how much additional time that might add if we were to fly further away. We can divert up to about 700 meters in distance from the back shell separation point, roughly. That only adds, because we know we're doing that right away and we're making that correction almost immediately after back shell separation, that only adds a couple of seconds to our flight, basically none at all. If you just sat there trying to hover, our vehicle at touchdown will consume up to about 4 kilograms of fuel per second. So you can kind of understand it that way, we're adding a few more extra seconds of fuel to go the maximum distances. It's on the order of 20 kilos of variation or so. So that's kind of the first question I think you were asking. The second question you were asking, I think, was about the size of the cliffs. Those cliffs are about 200 to 300 feet tall. And you might have noticed that we're aiming right at the edge of that delta. And that's not an accident. The safest place in the ellipse that we would like to come down is at the base of the delta. We call that the landing strip. It's kind of that flat area that you can kind of see in the images. That's at the foot of the delta. So that isn't an accident. If I had my way, we'll end up there. We of course can end up in other places in the ellipse and are happy landing in other small parking lots around the place. But our desire is to end up in that landing strip.
Thank you, Al, and thank you, Leo. Another call from Ken Kramer from Space Up Close. Good morning, Ken.
Good morning. Thank you. Thanks for taking my question, and good luck tomorrow. My question is for Ken Farley. Actually, I'm interested in the map. If we go back to the map, maybe you could show that map again. Can you talk a little bit more detail about why you selected that route? What rocks and minerals are you expecting to find, and where would you find them? And where would be like the first sampling site that you mentioned in the summer sometime? Thanks.
Yeah. So the traverse that you see there is based on orbital data and the data that we have first and foremost tells us where rock outcrops. And if you want to understand any sort of geologic system, you don't want to analyze, you don't want to study in great detail the rubble that's just laying around. So the first thing we did is identify where there is outcrop. And then we created a geologic map. It tells us how rock units relate to each other. And from that, we were able to raise certain kinds of questions, like, is this rock older than this rock, or is this rock younger than this other rock? And so these become hypotheses that we wish to test at each of these locations. So that's one whole set of criteria for where we're going to go, is where there is outcrop that can tell us something important. And then a whole other set of criteria have to do with the goals of the mission, in particular this seeking biosignatures. So we want a place that is both a record of a past habitable environment. For example, mud deposited in the bottom of a lake. That is a wonderful place to look. So we prioritize targets like that. And also we prioritize targets that could tell us things when samples come back to Earth that we simply cannot answer with the rover. And as an example, we have tentatively identified places where there are volcanic rocks. Volcanic rocks would be spectacular to bring back because then we can date them quantitatively and understand how to pin this entire geologic record into geologic time. So that's how we put the traverse together. It is just an idea, and we are certainly going to divert from it in either large or small ways as we move along and discover new things. And then I think the other question you asked is what would be the most likely first target? That's going to depend a lot on where we land. But if, as Al said, we land right in front of the Delta, I would, thumbs up, Al. We are super excited about that because the Delta is what brought us to this location in the first place. Spectacular piece of geology. And I think we would very likely look at the base of the Delta where there is mud that was deposited billions of years ago. And this is, as I just said, a wonderful place to look for biosignatures. And so I think there's a high probability that that will be, if not the first place, amongst the first places that we will take a sample.
Thank you so much for that, Ken. We unfortunately can't answer all the media questions on air. For those of you with additional questions, please call JPL's Digital News and Media Office. We'll also continue to answer social media questions online. Thank you for your questions, and thank you so much for our panelists joining us today. To celebrate Perseverance's Red Planet landing, cities around the country are lighting the town red. Here's a great look from New York yesterday. The Empire State Building lit up its tower for the Red Planet. Later today, here in Los Angeles, the pylons at LAX will be turning red, and several buildings along the Chicago skyline, including the Adler Planetarium, will also be joining in, so stay tuned today at 12 p.m. Pacific Standard Time as our next briefing will dive into the search for signs of ancient life on Mars and in samples we will be bringing back to Earth. Perseverance is set to land on Mars tomorrow, with commentary beginning at 11:15 a.m. Pacific Standard Time, 2:15 p.m. Eastern Standard Time, and we are offering lots of ways to ride along with us. To join the virtual NASA social and virtual guest events, register for the Mission to Mars Student Challenge and live stream the Mars landing. Visit go.nasa.gov/Mars 2020 Toolkit. For those of you interested in a deeper dive, we have a new press kit available online too, with lots of information and graphics describing the rover and its mission. There you'll also have a chance to sign up and send your name to Mars on NASA's next flight to the Red Planet and put yourself right into the action with our Perseverance photo booth. You can pose next to the rover, place yourself in our mission control, and even see what you might look like taking a selfie on the Red Planet. Again, it's all available at go.nasa.gov/Mars 2020 Toolkit. If you're on social media, join the conversation with the mission on Facebook and Twitter. Follow at NASA Persevere and use the hashtag Countdown to Mars. Thank you again for joining us today and watching, and go Perseverance!
as the countdown to Mars continues. The perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
NASA's Mars Perseverance rover left Earth 6 months ago. Now we are gearing up for touchdown on the Red Planet this week. The rover will attempt to land in Jezero Crater this Thursday. It's the most difficult landing site on Mars ever attempted. But the Perseverance rover and the team are ready. Welcome to NASA's Jet Propulsion Laboratory in Southern California. I'm Marina Jurica, your host today, as we bring you a closer look into Perseverance's mission and science goals. We will discuss the new advanced instruments on board, why this landing site was chosen, and how Perseverance fits into NASA's future plans for Mars sample return. As we are social distancing, I will introduce you to some of the key scientists on the mission here and joining us virtually. On our panel today are NASA Planetary Science Division Director Lori Glaze, Perseverance Deputy Project Scientist Ken Williford, Principal Investigator for the Sherlock Instrument Luther Beagle, Principal Investigator for the Mastcam Z Instrument Jim Bell, Principal Investigator for the SuperCam instrument from the l'Institut de Recherche en Astrophysique et Planetologie, known as IRAP, in France, Sylvestre Maurice. For anyone watching who would like to submit a question, you can do so by using the Countdown to Mars hashtag. Our phone lines are now open to the media. You can ask a question by pressing *1 and enter the queue. To start, I'd like to welcome Lori Glaze. Good afternoon, Lori.
Good afternoon. Nice to see you, Marina. So NASA has been exploring Mars for more than 50 years, and we are just getting so excited as we prepare for Thursday. Although we now know that Mars now today is cold and dry and a place that's bombarded by cosmic rays, really a place that's inhospitable to hosting life today. What we've learned over the last couple of decades in our exploration of Mars is that Mars was much warmer and wetter a few billion years ago, and that some of the environments on Mars actually could have had all of the right ingredients to support microbial life at about the same time that life emerged on Earth. If I could have the first graphic, there it is. You can see on the far left, we began our rover program in 1997 with Sojourner, and all of these rovers have helped pave the way for our understanding of the Mars environment and what Mars is like and how it has evolved over time, and led us to the Perseverance mission that we're waiting to land on Thursday. So the Sojourner rover kicked it off in '97, followed by Spirit and Opportunity, shown there towards the left. Spirit and Opportunity were really following the water on Mars, trying to identify, was liquid water ever present in substantial quantities over an extended period of time on Mars? And they found rocks that really did require water to be present in order for them to be formed. The next step, of course, was the Curiosity rover, and Curiosity went to Gale Crater, looking to identify, searching for habitable environments, exploring habitability on Mars. And in Gale Crater was able to confirm that yes, liquid water was present on Mars for an extended period of time, long enough to deposit sediments on the floor of Gale Crater, to generate and create clays that are found in some of the units there at Gale Crater. And also we found complex organic molecules. So with the water and the complex organic molecules, two of the real key ingredients to life were present, and in a habitable environment there that life could have possibly started to take form. And all of that led the way and prepared us to design the Perseverance rover, which is really now our first mission, our first mobile astrobiologist that's out really seeking the signs of life. Perseverance is our next step in exploration. And we've learned from everything that we've learned, we've been able to better identify exactly what kind of site we wanted to visit that had the highest probability of having preserved ancient microbial life, and Ken Williford's going to speak a little bit more to that in a few minutes. We also are now better prepared to design the instruments and the experiments that we want to conduct on the surface of Mars, specifically designed to look for those markers, those biologic markers that can give us a hint that perhaps there was life early in Mars's history and that it might be preserved in those rocks at Jezero Crater. And then, of course, the next step beyond Perseverance will be the ability to bring samples back. So Perseverance is going to identify rocks that we'd like to bring back to Earth, drill the rocks in soil, save them on the surface for that next mission that you see, which is Mars Sample Return, which will launch those samples back to Earth, back into orbit, and then captured and returned back to Earth eventually, and then preparing the way for human exploration at some time in the not too distant future. The Mars Sample Return project, of course, is probably the most challenging thing we've ever attempted within NASA, and we don't do any of these things alone. Between our partnerships on Perseverance and partnerships for Mars Sample Return, we have almost a dozen international partners that we work with, and together we are hoping to learn if life ever existed in the ancient past on Mars. And so with that, I'd like to hand it over to Ken, who's going to talk a little bit about what we might find in Jezero Crater.
Well, thanks, Lori, for that great introduction. And I want to start out by just sharing with you all how fortunate I feel, how excited I am to be, just days away from really a momentous occasion. Technically, with all the work it's taken to get our spacecraft to where it is now and in the state that it's in now, and then also scientifically. Just for me personally, the opportunity to be a part of this mission, which is directly looking for life on other planets, it's really a scientific dream come true. It's not an exaggeration. So it's going to be a big week for us. And pulling back a bit, if you take a minute to think about it, the implications of the science of this mission are really enormous. I mean, where Mars 2020 and Mars Sample Return, as Lori described, are about really an age-old question. Are we alone in the universe? We say that a lot, but about these astrobiology missions, but it's a big question if you stop to think about it. We know that life exists on Earth. We know Earth is a very hospitable planet and has been for billions of years. Life obviously thrives here today. But are we alone in a sort of vast cosmic desert, just flying through space, or is life much more common? Does it just emerge whenever and wherever the conditions are right? Big basic questions, and we don't know the answers yet. So we're really on the verge of being able to potentially answer these enormous questions. To start to get a feeling for the kinds of things we might hope to find at our landing site in Jezero Crater, a group of us from NASA, some NASA scientists and some ESA scientists, European Space Agency scientists, went to Australia to a place called the Pilbara. So if we could just get the video. And this place in Western Australia holds what is really the best early evidence for life on Earth. So this is the rocks that were deposited about 3.5 billion years ago here on Earth, where pretty much any scientist who works in this field can agree we have very good evidence for life there. And what does that look like? And so here you see us actually exploring the shores, actually not in this specific spot, but we did on that trip explore the shores of an ancient lake. And I'll just hold up this rock sample that I brought back. Hopefully you get a good focused image of that. You can see it on your screen as well in a picture. But this is a stromatolite sample that I brought back from a 2.7 billion year old lake deposit. So it originally would have been oriented like this with a dome of microbial mats. And so these are structures that form when little microscopic single-celled organisms like bacteria join together in communities and layer one on top of the other, and sometimes exude these sticky substances that can trap and bind sediment,
particles there. The organisms themselves can also stimulate the precipitation of minerals, thereby entombing themselves, sort of making their own microbial fossil, which, as we can see in the case of that rock I showed you, can be preserved for billions of years. And so, in a sense, to answer these big questions, we're going back in time 3 to 4 billion years ago to look at this very ancient lake system and look at all the different sub-environments in and around that ancient lake, and asking, what was this environment like? Could it have supported life? But then taking that next step, as Laurie said, and looking for any evidence that life may have left behind, like these stromatolites, or what we might more likely expect, something significantly more ambiguous. So that ambiguity that tends to be a part of the search for the most ancient record of life on Earth, and we can expect it to be the same on Mars. That ambiguity is why we need this incredibly complex and capable scientific payload. So to start telling you a bit more about that, I'll pass it to Luther Beagle, who's the principal investigator of the Sherlock instrument on Mars 2020.
Hey, Ken, thanks for that great introduction. I really appreciate it. When I got to JPL in April of 1997, we were getting ready to land Sojourner Rover on Mars, and it was a very exciting time to be here, and I thought stuff like that happened all the time. Didn't realize exactly how much hard work went into it until later on when MER and then MSL and now 2020 lands. But it's a great time to be here, and I'm honored to be part of this project. The science we're going to do is spectacular. As Ken mentioned, I'm the principal investigator of the Sherlock instrument. That's an arm-mounted instrument on the end of on the Perseverance rover. We chose Sherlock because we're going to Mars to look for clues. We're looking for clues for two specific things. One, we want to know whether Mars could have been habitable in the past. That is, were the conditions right to have organic material turn into microorganisms and with the origin of life. The second thing we're looking for is evidence of that origin of life. We're looking for clues with two different things. And this is a picture of the instrument that you're seeing here now. We have two different cameras on this instrument. The camera on the right is we call Watson, which is like a magnifying glass. Sherlock always has magnifying glass with him. And what Watson does is Watson takes microscopic images, and it also takes panoramic images as well. So you can take a picture of the rover. You've seen the rover selfies. That was done with Molly on MSL. This is a reflight of that camera. And we were able to take pictures of the rover, and we're also able to take pictures of the rock. And we can actually zoom in on the rock and get down to really fine spatial scales. The second camera is the spectrometer part of the camera. We take even finer images with that particular camera, and we do spectroscopy. We do two different types of spectroscopy. Raman spectroscopy, which tells us what kind of molecules are present on the surface, which gives us organic material, chemicals, and mineralogy, and fluorescence spectroscopy, which identifies organic materials. So how we work on the end of the arm is this is a movie you're about to see, and it shows how Sherlock actually is moved on the robotic arm. This robotic arm, you can see Sherlock on the outer part of the arm here. We're attached to the drill. Pixel, our sister element, our sister instrument is on the other side of the rover, and Pixel does elemental abundances the same way we do on the microscopic scale. We're looking really at really fine scales on Mars on the order of 100 microns. That's about the size of a human hair, and we're looking for clues in those very small regions. This is the way the arm moves. This is a video showing how we get deployed. We don't bring the sample to us. We go to the sample. So you can see really how slow the arm moves and how deliberate it is. The arm is really, really big, and we can actually, we command it to about 5 centimeters above the surface. We're a contactless instrument. And what we are actually doing is, slide one, is we're able to map things out. We're able to take an image of a very fine microscopic image, and we're able to take our laser and raster it across the surface and identify organic material, minerals, and the like. And we're able to do that with Pixel too. So the image on the left is a stromatolite like Ken showed that we obtained from Australia, and we took two different images at the bottom. The Sherlock one is in the small red box, and the Pixel one is in the larger red rectangle box. Pixel identifies where different elements are, and we map them out. And so we can map out context of in the images with actual organic and mineral maps on the right. And this tells us a lot more about the rock than just doing one instrument by itself. So we can take our measurements and combine them with Pixel and then combine them with SuperCam, which we'll hear about in a second, and get a really better idea of what the entire sample is all about. The next slide shows a stromatolite. And this particular stromatolite is from the Pilbara region, and we got it a few years ago, and we wanted to show what we could do with Sherlock. And so what we did was we scanned across the surface. We took an image, that's the top image, and we scanned across the entire image, and wherever you see deep blue is where there was a microorganism, a single-celled organism existed, and where you don't see any dark blue, you see there's no little or no organisms there. So we scan across, and where you see organic, or excuse me, when you see microorganisms on the outside of the rock, you can see them in cracks, you can see them in fissures, which is where you would think that organisms would live because they have accessibility to both water and nutrients. There were two features on this particular scan that we weren't quite sure about. One is in the upper right-hand corner, the dark blue on the rock, and then one is on the bottom left-hand corner, the purplish feature down there. What these two features are actually the fingerprints of a postdoc that accidentally picked up the rock. So this shows you exactly how sensitive Sherlock is. We actually were able to identify the fact that he picked up this rock without any gloves on, which then contaminated the surface, and we could get his fingerprints from that surface. So that's kind of what Sherlock does. And for the to understand where our samples are looking at in context, I'm going to throw it over to Jim Bell, who's the principal investigator of Mastcam-Z. Jim?
Hey, thanks, Luther. I am super excited about being able to talk about the science of our mission, and I'm also just super fortunate to have been able to participate in all 4 of NASA's rover missions to Mars so far in my career. And so this upcoming 7 Minutes of Terror on Thursday will be my 5th ride down these particular Class 5 rapids, and just really looking forward to the great ride the engineers are going to give us, and then the great science that we're going to do with this mission. I'm here in the Mission Operations Center at Arizona State University in Tempe. This is the Mission Operations Center for the Mastcam-Z camera-mounted instruments on Perseverance. This is where our part of the science and engineering team will be watching the landing. Because of COVID, the 400 or 500 members of the science team can't be all together at JPL like we normally are and jumping up and down, yelling and screaming with the engineers. We can't do that. So we're all back at our home institutions, and we'll be running our part of the investigation here from campus in Tempe. So we'll be doing the day-to-day health assessment of the cameras, the calibration, the image processing, and getting that information out to the rest of the science team, as well as to the public via the JPL and NASA public websites. So if I could have my first slide up. So this rover is loaded with engineering and science cameras galore and microphones, and you'll hear more about those later. This rover and this mission is going to be a feast for the eyes and ears. It's really going to be spectacular. 23 cameras on the rover and its descent stage itself, plus 2 more cameras on the helicopter, 25 cameras total, the most camera-heavy mission of deep space robotic exploration ever sent out there. So very, very excited about that. And the cameras that we'll be operating and using to help achieve our mission goals are called Mastcam-Z. If you go to the next one, please, next slide. You can see them up on the mast, and the technician here doing some final cleaning and checkout. Those square aperture ends there, you can see, and I've got a little model here I can show off. It's about the size, each one of those is about the size of a typical can of tennis balls, for example, and we have 2 of them. The 2 of them give us stereo vision. The Z in Mastcam-Z stands for zoom. So we can go from wide angle stereo view of the landscape all the way to telephoto, super close up, high resolution view of the landscape. We can resolve features on the millimeter scale close in to the rover, and on the centimeter scale off at the distance. We can see, for example, something and resolve something the size of a housefly at the length of a football field. So here's an example of the zoom capability in the next slides here, taking the cameras and pointing them out the laboratory window. We go from the wide angle view of that ridge, it's about 1 kilometer away, all the way zooming in to full telephoto. So we've spent the past 7 years designing, manufacturing, testing these cameras in close collaboration with our colleagues at Mail and Space Science Systems in San Diego, who have done a lot of really great deep space cameras. We took the engineering model cameras out in the Mars yard just last week. This is the engineering model rover. We used this to test everything that we're going to do on the real rover. And we took this beautiful 360-degree panorama at a relatively wide angle setting. So about 142 images go into this RGB color panorama. And so we can see all the way around and the rover itself. And this is an example of one of the early products that we'll get from one of the early sols on the mission. After we pop that mast up and take our first 360-degree look around. We can also project that into a selfie. Here's the same view projected looking down onto the rover. Of course, the cameras tilt up and down as well. We can look down on the rover and take a picture of the deck for characterizing the things on the deck that the engineers are interested in, as well as our calibration targets, which we're very interested in to make sure we get the colors right. So these are just some examples of the kinds of things that we won't be seeing the Mars yard in JPL. We'll be seeing Jezero's backyard on Mars starting next week. So we're super excited about that, and really excited especially about sharing all these images with the public as they start coming down. Okay, so you saw a bunch of stuff going on that mast, up on top of that mast, including the mast cam-Z as well. We share that space with navigation cameras and with another science instrument called SuperCam, and you're going to hear more about that. I'll turn it over to Sylvestre Maurice for more details. Take it away.
Yeah, thanks so much, Jim. Thanks, really great. I'm Sylvestre Maurice. I'm the Deputy PI of SuperCam, and I'm glad to attend this briefing from Toulouse and my home institution here in France. Very lucky to be here. SuperCam is largely inherited from ChemCam, a very active instrument on Curiosity that has shot its laser more than 800,000 times so far. Similarly to ChemCam, SuperCam has been built by the Los Alamos National Lab in New Mexico and France. But if SuperCam seems just like ChemCam, it is actually very different. Let's look at the video now. SuperCam is made of 3 parts. The mast unit is at the top of the mast. It's as high as 2 meters, and it looks like the Perseverance high. In a rover body, you have the body unit that handles communication with the rover. And at the rear, we have calibration targets to obtain reference measurements on well-known standards. SuperCam consists of 3 spectroscopic techniques. Just like ChemCam, the mast unit fires an infrared laser, creates a plasma, and within the body unit, the return line is being analyzed. And thus we find the atomic composition of the targets, how much iron, titanium, sodium, and so on. We also have 2 new techniques. Raman spectroscopy, it's a green laser to vibrate the molecule, just like Sherlock, with a different kind of laser. We're also analyzing infrared light from the sun as it's being reflected by the rocks. These are very new. Both techniques yield molecular structure and possibly organic molecules. To find out where we're shooting at, we have also a microscopic imager. It's another camera on Jim's list. High resolution, very small field of view for ourselves. And at last, but not least, we have a microphone, one of the 2 microphones on a rover, to listen at the wind, listen at the rover, and also the infrared laser shooting at Mars. Well, you can see that SuperCam is quite a complex instrument, and yet a very powerful one. It can work at the atmosphere, at rocks, from 2 meter distance to up to 7 meters without moving the rover, and at scale as small as 1 millimeter. So SuperCam will characterize in situ the habitability and search for traces of life. It will support sample caching. That is, we're going to help to find the best sample to pick up. And also we're going to document their geological context. That is SuperCam. Back to you, Marina.
Thank you so much, Sylvester, and thank you so much to our panelist presenters. We are now ready to take media questions. Remember to press *1 to get put in the queue, and please direct your questions to one of the panelists in particular. We're also taking questions through the hashtag Countdown to Mars. Our first caller is Chelsea Goad with Space.com. Good afternoon, Chelsea.
Good afternoon. Thank you for taking my question. My question is for Ken Williford. You mentioned that you and the larger team studied stromatolites in Australia to demonstrate finding and scanning microorganisms in rock cracks and fissures. Do you expect that if and when Perseverance does identify evidence of ancient organisms on Mars, that these organisms might be similar to the microbes you studied as an analog in Australia?
Wow, yeah, it's a fantastic question. So we did go to this specific location in the Pilbara in Western Australia for an important reason, and that's because, in a certain way, looking at the earliest evidence for life on Earth is our best analog to the challenge we have in front of us. So the similarities are many. The environment we were looking at in Australia, in the case of at least this sample that I showed you, was an ancient lake. We looked at ancient lake environments there. And I think it's fair enough to say, of course, I could go on forever on this topic, but it's fair enough to say that life that we're looking for, sort of a life as we know it, would be cellular. That prior to, we know from the record of life on Earth, that complex organisms, complex multicellular organisms like we're familiar with today, animals and plants, didn't evolve until fairly late in the history of the Earth after oxygen rose in the atmosphere to appreciable levels. So we don't think anything like that happened on Mars. And so we think it's as likely as not that anything that was alive on Mars 3.5 billion years ago would be similar to Earth bacteria and other similar organisms called archaea, which are the kind of organisms that we think made these stromatolites that we find in Western Australia.
Thank you, Ken. Our next caller is Deanne Divis from Al Jazeera. Good afternoon, Deanne.
Good afternoon. Thank you for this opportunity. This one is to Ms. Glaze. It was mentioned in the last briefing that NASA hopes to use activities on the lunar surface to inform future Mars exploration. I was wondering if that might also be true from the Mars work that your team is doing. Will it inform the work that will be happening through Artemis or any other lunar activities?
It's a really interesting question, and I think everything that we do is helping to inform everything across the board. We're working together, always science and exploration working hand in hand, science enabling exploration, exploration enabling science. And certainly I think some of the things that we're going to be doing on Mars, thinking about how to take advantage of resources that are local. Of course, they would be a little differently when we're talking about the moon, but thinking about how we do this actually in situ are things that will feed forward. So there's a lot we can do there working together. I don't know that I have anything specifically as far as a direct link, but as I said, we work together really closely.
If I might ask a follow-up, RIMFAX, could you speak to RIMFAX and what you'll be looking for with RIMFAX?
I can speak a little bit to RIMFAX, you bet. So RIMFAX is a really interesting instrument that is actually a ground-penetrating radar that's going to be able to see several feet, tens of feet below the surface. And that allows us to actually better understand what the structure is beneath the surface that we can see and that we're going to be driving over. So like I said, we know that there should be these sediments that will be present at the bottom, beneath the rover, but somewhere beneath that we might be able to see if there's any other geologic structure within those sediments or maybe even the base of those. So using RIMFAX, we'll be able to better understand the full three-dimensional scope of what the geology looks like in Jezero.
Thank you.
Thank you so much, Lori. Our third caller is Leo Enright from Irish Television.
Thanks very much, Marina. I was wondering, your mission is clearly to collect science, but it is also to collect samples. And I'm wondering how you balance the two. In the old days, back in Apollo, I was actually in the Mission Control Center, and there was somebody with a stopwatch timing the astronauts at each sample point and saying, now you've done your time, move on. Is there going to be that sort of pressure because you have, in a sense, the future looking over your shoulder?
I can take that one. I'll take that one, Leo. It's a very, very good question. And you're absolutely right. There is some incredible science that we're going to be able to do while we're in situ, the great science. But one of the main objectives of this mission is to collect samples, a diverse collection of scientific samples that can be collected by Mars Sample Return. And we do have those tubes with us. We want to make sure that within our prime mission, which is 2 Earth years, 1 Mars year, that we do collect a scientifically justifiable sample that allows us to return to Mars and collect those. So we will be doing science along the way. We'll also be using our science instruments to help us best identify the samples that we do want to collect and bring back to make sure that we are collecting a scientifically diverse set of samples. So I wouldn't say that the stopwatch is going to be on, but we are actually keeping an eye on that we're making progress and covering the ground and collecting as many samples as we can in diverse spots within Jezero Crater.
Thank you, Lori, and thank you, Leo, for calling in. Our next caller is Peter Warren with the Star Tribune. Good afternoon, Peter.
Hi, thanks for doing this. This question's for Silvestri and sort of more about the process and working with people on the actual science. What was it like collaborating with Roger Wiens on the SuperCam?
Well, thanks so much. I'm not sure I got all the questions. I'm sorry for that. Could you repeat the last part of your question?
Yeah, what was it like collaborating with Roger on the SuperCam?
Oh, that's an easy one. It was great. This kind of projects between two countries that are so complex, you need to have an excellent relationship between the people first. So with Roger Wiens, we've been collaborating together for the last 20 years, I guess. First on ChemCam, now on SuperCam, and we have future project, hopefully. So it's fairly easy. The trick was for us to have an instrument that could define on different parts. We took in France the upper part on the mast with simple interfaces with the rover and just one link to the body unit. And they take care, and Roger takes care of talking to the rover. So you define your interface of your hardware, you have a good relationship, and life is easy, honestly, very easy. Good project.
Well, thank you so much for that, Sylvester, and thank you to Peter for calling in. Now we're going to switch over to social media. Remember, you can ask questions on our social media platform by using the hashtag #CountdownToMars. The first question is Carol on Facebook. She asks, does any of the science in the Mars 2020 mission give insight to benefit human health? Luther, would you like to take that?
Oh, I've never been asked that question before. I think that a lot of what we do does help benefit human health in that we're trying to make portable and miniaturize different instruments and different techniques, which you can easily move out into the commercial field. I know that a lot of what we're doing on Mars and what we did for Sherlock is going to be integrated into food chains to understand whether there's contamination, whether there's insects contamination and things like that. And that really it plays a part. It's commercialization. The laser that we developed will get smaller and more robust and be able to fit in food trucks and things like that. And I think every instrument probably can tell that same story.
Thank you, Luther. Conrad on Facebook asks, when can we see the first video and pictures from landing? Do you want to take that, Jim?
Sure. So everything goes according to plan on Thursday. It's possible we could get the hazard avoidance cameras, HazCam wide-angle images down in that very first downlink. Of course, we don't know exactly how everything's going to go, but if not then there's I believe Mars Odyssey pass just a few hours after landing, maybe 3 hours or so. That could provide an opportunity for some of the first images. And we land with the mast down, tucked onto the deck for safety, and so we won't pop that mast up for a day or two. And then once we do that, then the Mastcam Zs, the navigation cameras, SuperCam can really start to see the surroundings and the landscape. So I would expect, and certainly am planning, that sort of over the course of the weekend, as various press conferences and other events go on with updates on the mission, that the imaging data will start to roll out pretty quickly. Also, as part of those early downlinks, some of the movies that the cameras are taking as the rover comes down, there are video cameras that are recording the parachute from the rover looking up, that are recording the rover from the descent stage looking down, that are recording the ground getting closer as we get closer to the surface. Parts of those movies could start coming down within the first few days as well. And then looking a little bit into the future, as we get preparing for the helicopter operations, we'll be using the Mastcam Z cameras to take movies of the helicopter flights. And I'm really excited about doing that and sharing those movies with the public, as well as, of course, with the engineering team.
We are all getting excited to see that for sure. Thank you, Jim. We have a follow-up question from Leo Enright with Irish Television. Good afternoon, Leo.
Yeah, thanks again. Just actually for Jim Bell, you just mentioned the helicopter. How quickly is this going to happen? What they call their right moment? Is that going to happen very quickly?
I think it's going to happen early in the mission. It's going to take many days, perhaps several weeks, for the engineers to do all the checkouts that are required of the basic rover systems themselves, as well as the scientific instruments. All that has to happen first, a sort of initial checkout phase of the mission. And the helicopter folks are also doing some checkouts of the helicopter and its battery and its systems while it's still attached to the rover. And then, as you may have seen in the previous press briefing, it's a multi-day process, multi-sol process on Mars to release the helicopter, release its protective shield, and then deploy it onto the surface, and then the rover backs away, and there's a bunch of checkouts that happen there. So I would anticipate it could be, many weeks to perhaps even a month into the mission before we get to those first flights. But it's all going to depend on the reality on the ground and how everything is checking out during those initial days.
Thank you, Jim. And now we're going back to social media. Spiffy Billy on Instagram asks, what is the first science experiment to be conducted after landing? Ken, will you take that one?
Sure. Well, as you've heard a number of times now, the first weeks of the mission are about checking out all the systems, the engineering systems that are required to make the rover run, and the engineering aspects of the science systems. So the instruments are being tested. As we test the instruments out, just to make sure that they're functioning correctly, we will, of course, have an opportunity. For instance, the first time we test out the SuperCam laser, we will be interested to hit a specific target, and we'll start to get some science data in. But you asked the first science experiment, and to me, it's the first images that come down. I mean, as soon as we get data, image data really from the surface, we can start making scientific interpretations. So not only is it this sort of incredibly inspiring moment, to me anyway, when we see the first images from another body in the solar system or another place, on a planet we've visited before. It's just such a thrilling thing. But there's also science to be gained from that.
Thank you so much for that. And now we're headed back to the phone. Ken Creamer from Space Up Close. Good afternoon, Ken.
Hi, thank you for taking my question and thank you for doing this. My question is about taking these samples you're going to put in the drill. Can you talk a little bit about how the team is going to work together and which instruments they're going to use to figure out which samples to drill and to cache? And how many samples do you plan to take in the first Mars year? Thanks.
Ken?
Yeah. So another great question. It's similar to the one that Lori took earlier, looking at the balance between, as the previous person said, sort of science and sampling. Of course, the samples, the time we spend collecting the samples and documenting them very specifically is obviously in the interest of science. So those samples are scientific samples. A large part of the science we do while we're not, actively collecting a sample or in the few days leading up to that, is science that we're doing to provide context for those samples. And so I will just say that on this mission, we've known from very early in our development, that we had major challenges in front of us in terms of our operations planning. And this is because we have tried from the very beginning to pack in an enormous amount of capability to do things really well and to do things really quickly, because this opportunity to select scientifically and collect and return samples from Mars is so extraordinary that we want to be able to really make it as rich a mission as possible. And so we've been planning from very early on, strategically, if you like. It was a 4 or 5 year process that led us to select our landing site. That was all part of the planning. And then once we had the landing site, we could use the science team to plan strategically more specifically. And so as we did that, we would often go back to this quote that's attributed to Eisenhower. That's something like, I've always found when going into battle, that plans are useless, but planning is indispensable. And so we know that all this planning effort is indispensable. We have to do it. It helps us get better at refining our processes and finding that balance that we mentioned earlier. The time we spend with the stopwatch on collecting the samples and the time we allow ourselves to be driven a little bit more by our curiosity and letting this discovery lead us to the next. We have to do both of those things to make the best of this opportunity. And really it comes down to the time we spend planning and then our ability to flexibly adapt as Mars inevitably throws surprises at us.
Thank you so much, Ken.
You also asked how many samples we're planning to collect, which is a key question. So we have 43 sample tubes on board. So we hope to collect, around 40 samples, but the idea is that 30 samples could be returned. Those return missions, which are, not final yet completely, but that's the capability that NASA is looking at right now, is an ability to return 30 samples.
Thank you so much. Next question is coming from social media. Amal on Twitter asks, how will the microphone help you in exploring Mars? Can you take that, Sylvester?
Oh, yes, I can, because that's an excellent question, because it's the first time we're having microphones on Mars. Has been tried a few times, was never really implemented. So this time we have two. So one of them is mostly technology, is going to record the landing, and that is important. And if it works, after we land, it's going to be used for science, of course. The other one is part of SuperChem. The idea is it's opening a new world. We know there are sounds because we produce sounds. The rover produces sound, laser produce sounds, but there are also winds, different types of winds that create turbulence. That's one point. The second is that we have an atmosphere that propagates the sounds. It does not propagate very fast. Actually, it's slower than Earth. It doesn't matter so much. It's also dimmer. It's very loud. And the high pitch sounds don't propagate very well. But put everything together, yes, we will hear some new sounds. With the atmosphere, we're going to the winds. We're going to learn about the atmosphere turbulence, the convections, and small-scale temperature changes. With the laser is going to hit the rocks, and it's like knocking on wood, on whatever concrete you have. By just listening to this zap, we can infer what is the hardness of the rocks. So it's a new place, a new place to hear, and we're really excited with these two microphones.
Thank you, Sylvester. We go back to the phone lines with a follow-up question from Leo Enright with Irish Television. Leo?
Thanks very much, Marina. Sorry for dominating, but since the opportunity is here, I wanted to ask Dr. Maurice about the French Operations Center for Science and Exploration. I think the acronym is FOXY. Can you talk a little bit about how that is going to operate during the time that the rover is on Mars, and what opportunities are there for young Europeans, French obviously, but also Germans and even Irish, to get involved on Mars with FOXY?
Well, thanks for this great question. And Laurie could introduce that. It's an international, it's a NASA mission, but with an international partnership. And to build the instrument, to do the science, but also to operate our instrument. We have an operations center here in Toulouse at CNES, and it is to support SuperCam operation. But when you operate SuperCam, you need resources from the rover. You need to find what Jim is doing with his camera at the same time, because we're sharing the same mast. So operating an instrument is kind of being part of big game, operating the whole rover together. And for that reason, we have an operations center in France for SuperCam every other week. Rest of the time it's in Los Alamos because we also need to rest. But there's an operations center at Jim Place and at JPL. In Europe, we have another one in Spain for the MEDA instrument, in Norway. So everywhere we are operations center. Of course, it is for the team. We are welcoming our students. It's a great way for them to learn how we operate a spacecraft. And it is by operating a spacecraft, an instrument, you can really dive into the science. And that's really the spirit of this mission, that everyone who is doing science should try, if possible, to be part of the ops process, because that's where you define what kind of science you want to do. It can be in Europe, it can be everywhere. In the US, it's all together.
Thank you so much, Sylvester. And on that line of inspiring the next generation, Christina on Facebook asks, how will you be inspiring school children, and in particular girls, into science through perseverance? Laurie, can you take that?
Sure. I think that NASA takes that responsibility incredibly seriously. That we know that the work that we're doing is absolutely inspirational, and certainly, the Perseverance rover is no exception, and Ingenuity helicopter as well, no exception. These are absolutely inspirational, and so I certainly encourage anyone that's out there to make sure you check out. We've got materials that are available online at go.nasa.gov/Mars Toolkit, I believe. And make sure you check that out, because STEM Toolkit. I think it's the Mars STEM Toolkit. And make sure you check that out. There's all kinds of ways for students around the world to get engaged through the Mars Perseverance Challenge. Get engaged there. There's lots and lots of opportunities for engagement and to get involved with NASA and come along with us as we go through this incredibly exciting time to land, but also as we go forward. Stay engaged and follow us as we explore Mars.
Thank you, Laurie. And another question for you from Citizen Science. Are you going to accept volunteers to analyze information we get from the rover?
I can take that one as well. There are always opportunities for citizen science, and this is another area that we are really excited about, the incredible discoveries that citizen scientists are making across the board in so many different disciplines. And of course, we're going to have tons of data available through this mission, and I'm sure that there will be opportunities. I don't know of them specifically that I can cite right now, but I know that there will be specific opportunities, and I don't know if any of the instrument folks that are online with us know of anything related to their instruments they might want to share, but I know that there's going to be an incredible amount of data, and citizen science is a great opportunity, again, to enhance what we are able to do with our science teams, which are only so many people, and there's just an incredible amount of data out there.
A lot of ways to get
Yeah,
involved.
I could chime in a little bit on that as well, Marina.
Go ahead, Jim.
Oh, sure. So just a couple of things from an imaging perspective. We will be sharing all of the images from all of those cameras on the rover shortly after landing. They'll go out onto a website that JPL is hosting, and we've done this with previous rovers, Spirit and Opportunity, and other NASA missions. So that gets real data, imaging data, into the hands of anybody who wants to do anything with it, and sort of acknowledging the fact that there is a large community of amateur imaging enthusiasts and people who make their own Andy Warhol false color composites and mosaics and panoramas will have a place on the ASU MassCamZ website where people can upload the products that they've produced from MassCamZ data. And then we'll feature some of those and talk about what kids are doing or kids with their teachers for class projects or just other enthusiasts. So I totally agree with Lori that our aim is to involve as many people as possible, getting their hands on some real data and making some real contributions to this mission.
Yes, Ken?
Yeah, I just wanted to quickly say we are looking at some very specific citizen science initiatives that aren't ready right yet, but do stay tuned and join in with us down the line. But I also wanted to comment on the last question: what are we doing to inspire young folks? And I was just thinking about it as we were talking, and the earliest. So we're collecting samples with the intention that they could be returned to Earth for future work by maybe scientists who are currently working or future scientists. And so imagining people on a trajectory where they go, say, straight from an undergraduate science degree straight into graduate school and have a graduate school, a PhD project that's working on these samples. The earliest they will come back is 2031. So if a student is, say, 22, graduating from college, getting ready to go to grad school, that person could be 12 years old right now, 10 or 12 years old, out there just getting, really turned on to science. So I think Mars Sample Return, in that it's this intergenerational effort, is just a great way for, science teachers and us as a world community to get and stay excited about science. The potential is so enormous.
Thank you so much, Ken. Yes, that potential is there. We unfortunately can't answer all of the media questions on air. For those of you with additional questions, please call JPL's Digital News and Media Office. We'll also continue to answer your social media questions online for the rest of the day. Thank you for your questions, and thank you so much to all of our panelists for joining us today. Tomorrow at 10 a.m. Pacific Standard Time, we will have a briefing giving us a final landing mission update, and then at 12 p.m. we'll dive into a briefing on searching for signs of ancient life and the Mars Sample Return mission. Perseverance is set to land on Mars on February 18th with commentary beginning at 11:15 a.m. Pacific Standard Time. And we are offering lots of ways to ride along with us. To join the virtual NASA social and virtual guest events, register for the Mission to Mars Student Challenge. Lori mentioned this earlier. And live stream the Mars landing. Visit go.nasa.gov/Mars 2020 Toolkit. For those of you interested in a deeper dive, we have a new press kit available online too, with lots of information and graphics describing the rover and its mission. There you'll also have a chance to sign up to send your name to Mars on NASA's next flight to the Red Planet and put yourself right into the action with our Perseverance photo booth. You can pose next to the rover, place yourself in our mission control, and even see what you might look like taking a selfie on the Red Planet. Again, it's all available at go.nasa.gov/Mars 2020 Toolkit. If you're on social media, join the conversation with the mission on Facebook and Twitter. Follow at NASA Persevere and use the hashtag Countdown to Mars. Thank you so much for watching with us today, and go Perseverance!
revived American leadership in space. It's a particular pleasure to be back here in Florida on the Space Coast, and also to be here at the world's premier gateway to space. Join me in thanking the Kennedy Space Center and Director Bob Cabana for their tremendous hospitality and leadership for space. So it's wonderful to be here at this Apollo Center, Bob, and it's an incredible place. People have come from around the country and around the world to be inspired by the past, and now the present, and the future of American leadership in space. And we're truly grateful, Kennedy Space Center, for all that you've done and to continue to advance American leadership. Allow me to also bring greetings from a champion of American space exploration, someone who has revived Americans' leadership in human space exploration in just 4 short years. I bring greetings from the 45th President of the United States of America, President Donald Trump. Today at this 8th meeting of the National Space Council, we will have updates from all of our council's members about the progress that we have made, both in civilian, economic, and military advances in space. But before I start, let me at least acknowledge the passing of an extraordinary American whose life and contributions to American aviation have undoubtedly led to inspire the advances that we've made in the vast expanse of space. This past Monday, America lost one of our greatest heroes, one of the greatest heroes not just in the history of the United States Air Force, but in the history of American aviation, General Chuck Yeager. He was a man of a humble background, grew up in rural West Virginia, enlisted in the military. He would go on to become one of the greatest aviators of all time. Chuck Yeager was a war hero, shot down 13 Nazi aircraft, but was himself shot down over France. Flew more than 150 military planes, a total of more than 10,000 hours, 30 years of active duty, and as history records, was the first man to break the sound barrier. General Chuck Yeager has now left us, made his final ascent, but it was my great honor as we renamed 2 Air Force bases as Space Force bases just a short while ago to announce that at the direction of President Donald Trump, we are initiating today efforts to rename an upcoming United States military base after the late and great General Chuck Yeager. I think people here at Kennedy Space Center know, and all of us on the Space Council know, we literally would not be here today but for the achievements of General Yeager and all of those who've been inspired by his courage. And America will never fail, or never forget the life and contribution of General Chuck Yeager. So as we gather for this 8th installment of the National Space Council, allow me to express my appreciation to all of the members of the Space Council and to reflect for just a few moments before we get started on how much has changed over the last 4 years since the very first meeting of this council. You know, when you look at national security, the progress that we've made in civil and private space sectors, one thing is clear. In 4 short years, America is leading in space once again. It's true. When we took office, the National Space Council had lain dormant for more than 25 years. President Trump articulated an inspiring vision for renewed American leadership in space. In his inaugural address, the president said, and I quote, "We stand at the birth of a new millennium, ready to unlock the mysteries of space." And so we have set out to do. In our first year in office, the president revived this council to reinvigorate and coordinate space activities all across the federal government. The president brought together some of the best minds in government and the private sector to strengthen America's space enterprise. And so many of you are here with us today, and we're truly grateful. And whether it's providing for the common defense or growing our space economy across America, that's exactly what we've done throughout the past 4 years. In the very first days of our administration, the President signed multiple executive orders and presidential directives to reorient our space program to human space exploration. He took steps to unleash America's commercial space companies and to safeguard our national interests in the increasingly complex and competitive domain of space. In our first year in office, the President signed Space Policy Directive 1 and gave NASA a clear goal, that we are going to go back to the moon, and this time we are going to stay. We made clear in our first year that the moon is not a final destination, but it's a base for developing and training for future deep space missions. We're going back to the moon, and then we're going to Mars and beyond. As we gather here in this historic place, I can't help but think back 48 years ago, December 1972. To Apollo 17, the last Apollo mission to the moon. It would be December 14th, 1972, that Apollo 17's commander, a Navy pilot named Gene Cernan, and a graduate of Purdue University in Indiana, he prepared to depart for Earth from the surface of the moon. And he spoke words that have really echoed through our time as an ongoing admonition. He said, and I quote, "America's challenge of today has forged man's destiny of tomorrow." And he said, "As we leave the moon, we leave as we came. And God willing, we shall return with peace and hope for all mankind." Gene Cernan was the last man to walk on the moon, but he didn't want to stay the last. He spent the rest of his natural life advocating for America to go back to the moon. And we are going to honor Gene Cernan's memory by putting the next man and the first woman on the moon in just a few short years. As you'll also hear updates today, the President also set NASA and the private sector, the entrepreneurial companies that have been involved in space exploration and development, in motion to ensure that we would return to the moon. And then the next astronauts on the surface of the moon and all the economic development in space will be driven by American ingenuity. And we're going to ensure that Americans are going to be, we're going to be the very first. The very first not only to develop on the moon and Mars, but also to continue to develop the economic potential of space exploration. Even in this challenging year in the life of our nation, when Americans have sacrificed so much, we've continued to make steady progress toward that goal of renewed American leadership in space. This spring, it was my great honor to attend the first crewed launch, along with the President of the United States, from right here at the Kennedy Space Center. It's the first time we sent American astronauts into space from Kennedy Space Center in nearly a decade. And then, not to wait a minute further, this last November, I returned again to see the second crewed full-scale launch and mission of American astronauts from American soil back into American space. That's the result of real leadership and renewed American leadership in space. And what's remarkable is those rockets were built by American private enterprise in this new partnership that we have forged and built upon in the United States over the last 4 years. When a businessman turned president decided to renew our commitment to space, he knew it was important to unleash the power of America's private sector, and so we have done. As you will note out here today from the Secretary of Commerce, we went to work early on to cut and streamline out-of-date regulations that made the United States the #1 country in the world for space business, and will continue to accelerate investment and development in space. This past April, the President signed an executive order to recognize and promote the rights of private companies to recover and use space resources. That order, we believe, will provide the kind of clarity and stability that our businesses need to thrive. It will give our entrepreneurs the incentive to take our commercial space activity to all new heights. And just last week, NASA made its first commitments to buy lunar material from private companies and will continue to build on creating the kind of incentives that will generate investment and space development for generations to come. And even as we make great progress in expanding America's commercial activity in space, we also recognize the challenges of digital threats to our space operations. And that's why the President established cybersecurity principles for all of our space systems, whether government or private. The President put in place the world's first comprehensive space traffic management policy as well, and made it clear that we're going to use the resources, the capabilities, and the technologies of the private sector to make all space activities safer and more secure than ever before. It's amazing as you think about all these accomplishments in renewed human exploration in space from here in the United States, the difference that all these distinguished members of the National Space Council have made in America's future in space. But at the time that we acknowledge the progress that we have made in expanding human space exploration and reviving American space enterprise, we also recognize that there are challenges and even threats in space as well. As I just said, as we dedicated 2 Air Force bases now as the first 2 Space Force bases in America, space is a vacuum, but we aren't operating in a vacuum when it comes to our national security. The space race that began in the 1950s continues today. We are in the lead, but we are not alone. As you will hear today in the National Space Council from the Director of National Intelligence and others, China and Russia are continuing to develop space weaponry. Russia demonstrated a space-based anti-satellite weapon earlier this year. China is developing a new manned space station, and its robotic spacecraft will return samples from the moon in just a matter of weeks. In fact, China is increasingly emerging as a serious competitor in space, just as they are in other areas of the global economy and to the strategic interests of the United States. As the world witnessed, China recently landed an unmanned craft on the moon, and for the first time, robotically raised the red flag of communist China on that magnificent desolation. All of that competition, the investment of other nations on Earth in security in space, is among the reasons why our Commander-in-Chief took the unprecedented step of establishing the first new branch of our armed forces in some 70 years. President of the United States, now almost a year ago, signed into law the creation of the United States Space Force. Under President Trump, the highest priority of our administration is the safety and security of the American people. And where too often in the past, America has neglected growing security threats in space, this president called for extending our dominance on land and sea and air to the final frontier. It would be June of 2018 when President Trump laid out his vision for American military power in space. He called for the creation of that new military service that we spoke of today at the dedication of those bases. I believe it is a tribute to the President's leadership as well as the leadership of all the military personnel that are gathered here today, that literally in just a year and a half after our President first called for the establishment of a Space Force, after it had been talked about for a half a century, he was able to sign it into law. Extraordinary to think of the contribution that the United States Space Force will make to the security of our nation and the perpetuation of our freedom. As Deputy Secretary Norquist will reflect in a few minutes, the Space Force is growing stronger by the day. In fact, Secretary Barrett and I were not long ago in Colorado Springs when we saw the first 86 company-grade officers commissioned into the United States Space Force. And we're pleased to be joined today by the Chief of Space Operations, the man who has been working around the clock to stand up the United States Space Force. Join me in thanking General J. Raymond, who's with us here today. General. So we've made great progress. We evidenced that today in the dedication of Cape Canaveral Space Force Station and also Patrick's Space Force Base right here on the Space Coast in Florida. And I know the Lieutenant Governor of Florida is with us here today and is pleased to see that. But just like 42 years ago when Gene Cernan was on his way to the moon, and just like when Chuck Yeager was breaking the sound barrier in the 1940s, the United States continues to face an era of competition. But as members of the National Space Council know, it's a competition that America is winning today, and we're going to keep on winning in space for generations to come. And that's one more reason today, while I'm pleased to announce that the President, as of today, has issued a new national space policy that we will articulate at this meeting of the National Space Council. The National Space Policy provides the President's direction to the executive branch on all space activities. It emphasizes that space is critical to our security and our way of life, and lays out the fundamental principles to put America first in space. Dr. Scott Pace will go into more detail about the President's new national space policy in just a few moments, but it represents our ongoing commitment to, at the National Space Council and throughout this administration, to ensure American leadership in space. But for now, let me just say that because of the hard work of all the men and women of the National Space Council putting our President's vision into effect, because of the hard work of all of the dedicated men and women on our Space Council Advisory Group and the support of the American people and leaders in the Congress, we've made great progress in the last 4 years. But as you will hear again today, there is a renewed determination all across this nation and all across this government and all across every level of government to continue to build on the extraordinary progress that we've made. And today we will hear about that progress, the ongoing challenges and opportunities that America faces. So let me say once again, welcome to this 8th meeting of the National Space Council. Let's get to work. Again, let me call this meeting of the National Space Council here at the Kennedy Space Center on Florida's historic Space Coast into session. Today's meeting will include important updates and announcements from council members and the council's executive secretary. First and foremost, allow me to turn our attention to the economic progress that we've made. Policies have been advanced. The Secretary of Commerce, Wilbur Ross, has been a great champion of space. Even as we've seen the American economy over the last 4 years reach all new heights. I think we set another record on the stock market again today, Mr. Secretary, but let me just say how grateful we are for your immediate appreciation for the impact that space exploration and entrepreneurship could have on the American economy. And why don't you give us an update on the Department of Commerce's activities related to space traffic management, international space development, and investment, and other encouraging space news. But join me in thanking Secretary Wilbur Ross for his great leadership on this cabinet and on the National Space Council.
Thank you, Vice President Pence, for the opportunity to update the National Space Council on the growth of the space economy and the related work that is taking place at the Commerce Department. Here at Cape Canaveral last week, SpaceX executed its 100th successful commercial Falcon 9 rocket launch. They sent a crew and thousands of pounds of supplies and research gear aboard a Dragon spacecraft to the International Space Station. I'm reminded that it wasn't long ago when travel among the stars was merely a distant goal, before it was even a race among nations. Indeed, our country has achieved remarkable progress in the space sector, and now again, as American business people continue creating new ways to make space more commercially feasible. I toured such an example earlier this year, Astrobotic's new headquarters in Pittsburgh, one of the many small companies doing very creative things. Their facility will support unmanned missions to the moon and drive technological development that brings us closer to NASA's planned 2024 human moon landing. Such landmark accomplishments in the commercial space field come alongside record-breaking economic investment in space activities. Globally, another $4.9 million was invested in space companies in the third quarter alone. This not only marks the most productive quarter on record, but it also raises the total 2020 investment to $17.5 billion in the overall industry. And wonderfully, the U.S. accounts for 62% of the industry's total investment. Morgan Stanley projects that revenue generated by the global space industry may top $1 trillion by the year 2040. And the recent explosion of the industry here in the U.S. is due in no small part to the efforts of the Trump administration. The administration's pro-space agenda and the work of the National Space Council has already had significant impacts. NOAA has removed red tape that previously surrounded remote sensing technology by shortening the licensing timelines from 74 days to 28 days at present. This enables companies to sell data from satellites more easily and more efficiently, helping commercial satellite operators stay competitive in a rapidly changing global marketplace. Commerce Department has also taken steps over the last year at the behest of the Vice President to identify new space missions and get them the necessary authorizations to proceed in line with our treaties. The goal here is to alleviate the administrative and regulatory burden on emerging companies and technologies, and we enthusiastically continue in that mission. Financial indicators and regulatory procedures aside, one simple way to observe the growth of our space industry is to look at the number of satellites in orbit. This year alone, the number of active satellites in orbit is set to increase by more than 50%, 50%, to 1,250, of which about 80% are small sats. And the Satellite Industry Association estimates that up to 110,000 new satellites could be in orbit by 2030. This is good news for projects like SpaceX's Starlink, as well as for smaller companies that can benefit from the growing accessibility of private satellites. But the increase in satellites has also created a unique set of challenges when it comes to managing orbital traffic. We are seeing more and more frequent near misses that could cause unprecedented new amounts of debris. If two significant objects were to collide, they could create such a shower of debris that it could endanger the astronauts aboard the International Space Station. It could endanger billions of dollars of U.S. and other investment in space, and it could also interfere with the growth of space commerce. Fortunately, there's no shortage of brilliant men and women who have made remarkable headway toward managing this problem. In 2018, the Trump administration's Space Policy Directive 3 provided a unique approach to the management of orbital traffic. The Commerce Department's Office of Space Commerce and our interagency partners took on the missions laid out by this initiative. And today, I'm proud to report that we're in the midst of finalizing a Department of Commerce, Department of Defense MOU that will provide a detailed plan for the improvement of space situational awareness and ultimately space traffic management. We have also drawn on existing NOAA resources to establish a new open architecture data repository. This system allows both private and government entities, including those of our allies, to share data, increasing all parties' situational awareness amidst an increasingly crowded orbital environment. We continue to work with our allies in industry on the norms, standards, and best practices that will inform new rules of the road for space. We have also worked with private business and technology leaders from around the globe in this issue. In fact, just before Thanksgiving, the Office of Space Commerce hosted an industry day with over 250 companies participating, virtually of course, to discuss our approach to the open architecture data repository. We will continue to work collaboratively with the public and private sector to tackle this challenge. It's not the only one we face. China's lunar landing last week underscores that we are not the only ones invested in the business of space, and that competition for American companies operating in this sector is real competition. Similarly, Japan became the first country to bring back to Earth a soil sample from an astronaut. Looking ahead, my department's Bureau of Economic Analysis will publish within the next 2 weeks innovative experimental statistics that will help us further measure and understand the space sector. And I look forward to sharing this informative new data with all of you. The United States remains an incubator for greatness like no other, and I'm confident that we will retain our position as the premier hub for space-based exploration and business. Thank you.
Thank you, Secretary Ross, and more importantly, thank you for your leadership on the National Space Council on behalf of American entrepreneurial leadership in space. Truly extraordinary accomplishments. And my favorite one is that you said at the present point, $17.5 billion in investment in the last year, and more than 60% of that is invested in the United States of America.
Yes.
So thanks for helping to facilitate that. The Secretary of the Energy, a member of our cabinet, Dan Brouillette, is here with an update on space nuclear power efforts, and under his leadership, the collaborations between the Department of Energy, the Department of Defense, and NASA. Mr. Secretary, let me also thank you for your energetic and tireless efforts in forging exactly the kind of partnerships across government that are facilitating advances of American technology and space exploration. Secretary Dan Brouillette, the Department of Energy, everyone.
Thank you, Mr. Vice President. Well, thank you, Mr. Vice President, for that kind introduction. I'm honored to join you today to provide the National Space Council with a brief update on the initiatives that our department, the U.S. Department of Energy, has undertaken since the Council's last meeting in May. In July of this year, NASA hosted our first ever NASA DOE Executive Committee meeting right here at the Kennedy Space Center. The Executive Committee that was established under our new NASA DOE MOU that Administrator Bridenstine and I signed allows us to strategically pursue opportunities that will advance our cooperation between our two departments in space activities. At that July meeting, NASA and DOE agreed to establish 3 joint working groups. One group is focused on power infrastructure for the proposed Artemis Lunar Space Camp. The second group focuses on developing nuclear power and propulsion systems for future Moon and Mars missions, as well as robotic deep space exploration. And the third group, Mr. Vice President, is focused on pursuing space science and innovation interests, particularly high-performance computing initiatives that hopefully will address the challenges of traffic management that Secretary Ross just spoke about, weather issues, and planetary defense from near-Earth objects. These working groups will ensure that DOE and our national laboratories are effectively harnessing the capabilities of our world-class scientists, our engineers, our technicians, and our research facilities to partner with NASA to solve some of the greatest technical challenges facing the United States. Since our last council meeting, we've also continued our space-related engagement with the U.S. Department of Defense. In October, DOE senior leadership teams went to the Pentagon for a Space Technology Mini-Summit to discuss how DOD and DOE could cooperate more strategically on space-related challenges. Our senior policy teams and our technical leaders met with Acting Secretary of Defense for Research and Engineering, as well as with representatives from the Strategic Capabilities Office, the Space Development Agency, and DARPA to explore ways of strengthening DOE's contributions to the space mission areas of each of those offices. We were extremely encouraged by the outcome of the mini-summit, and we will continue to work with the Undersecretary's office as well as other elements of DOD. As DOE looks to the future, we will continue to leverage our global leadership in nuclear power technologies to provide sustainable power solutions for space applications such as radioisotope power, surface fission power, and nuclear thermal propulsion. Following the successful launch of the Perseverance Rover, which is powered by a DOE-developed radioisotope power system, DOE and NASA began formal engagement with nuclear aerospace and commercial power sectors to design and develop a surface power system for a lunar demonstration in the late 2020s. We're also working on engagement opportunities with private industry to advance thermal nuclear propulsion technologies. We want to move that ball even further forward. DOE, NASA, and DOD are also working with industry to establish advanced nuclear fuel production capabilities to support future terrestrial and space demand needs, and seeking to establish and maintain a nuclear supply chain capability that enables us to address a very wide range of applications. In addition to those things, DOE and NASA successes in ramping up plutonium-238 isotope production have now eliminated projected supply shortfalls, increasing the opportunities for deep space missions in the 2020s and beyond. Through our strategic investments, DOE and NASA have also modernized large portions of the radioisotope power system supply chain, eliminating single-point failures and improving reliability to support quicker mission tempos. Yet there's so much more that we at DOE can do, and we will do it. We're looking for ways to apply our next-generation computing technologies to address the tracking, modeling, and data analysis challenges of space weather warnings, space debris tracking and avoidance, and large-scale analysis of space radiation in cosmic microwave environments. Mr. Vice President, this is all possible because of your leadership of the National Space Council and the President's focus on significant space goals. And our work at the DOE is enabled by the great work of my colleagues across the interagency. So I'd like to especially thank all of those who have partnered closely with us, especially Jim Bridenstine and Jim Morhart at NASA, and of course Michael Kratsios at DoD. Finally, it's in this spirit of collaboration that I'm pleased to announce DOE's new space strategy, which we will soon publish. This decade outlook will directly support the national space policy and will focus DOE on being a key technology developer to support the space missions of our interagency partners. Thank you again for inviting me. Thank you for allowing me to join you. DOE, or as I like to call it, the Department of Exploration, looks forward to a future of powering innovation, of driving exploration, and for reaching for the stars. Thank you, Mr. Vice President.
Thank you, Secretary Briette, and I hope it's not lost, particularly on anyone looking on. I know all the experts that are gathered here, civilian and military, understand it, but the innovation that you're promoting through the Department of Energy on the development of nuclear power is what will precisely enable us to do deep space exploration and to put American astronauts on Mars. Even a layperson like me understands that when you've got nuclear power, you can run the engine the whole way there. And I've been assured it would take us about half the amount of time to get to Mars and get back from Mars with nuclear power. I just want to commend you for the way you've used the department. You've worked with the Department of Defense closely with NASA to promote the development of that innovation. Truly, it's going to be a game changer for American leadership in human space exploration.
Thank you, Mr. Vice President.
So thank you. Another round of applause for the Secretary of Energy. It's great. Someone that I've come to admire and appreciate very much, a key member of our administration, is the Director of the Office of Science and Technology Policy. He's been involved in advancing policies that will give us the capacity to continue to monitor planetary weather issues from space, so vital to the life of the nation. He himself is a legendary weatherman, and he's brought that discipline and that creativity to the National Space Council. Join me in welcoming Dr. Kelvin Drogemeyer. Dr. Drogemeyer.
Thank you so much, Mr. Vice President. It's an honor and privilege to be here today on this historic occasion. I really appreciate so very much your leadership of the Council and your extraordinary service to America as our Vice President. Thank you so very much for that. Under the President's leadership and under your leadership, Mr. Vice President, this nation has recommitted itself to space discovery and exploration and the advancement of humanity's expansion into the heavens. Today, I would like to highlight two areas where we have made really significant progress over the recent months and years, and where I believe our continued effort is needed. The first of these topics is space weather. Now, we're all familiar, as the Vice President said, with terrestrial weather, the towering clouds and beautiful thunderstorms that we see every afternoon in the summer here in Oklahoma, the very powerful storms that we see in the Midwest, like places like Indiana. They're beautiful, but they're also very destructive, and so we have to really understand and look to predict those. Well, space weather is basically no different. It encompasses a wide array of phenomena that are equally, in some cases, very beautiful, but also they complicate our exploration activities, and they really have the potential to degrade and even destroy some of the infrastructure that is most critical to our nation's security and our economy. So the importance of both understanding and forecasting and accounting for space weather is very, very important as we reinvigorate our human space exploration program. In October 2020, the President signed the Pro-SWIFT Act. It's an acronym which established as U.S. policy, and I quote, to prepare and protect against the social and economic impacts of space weather phenomena. The Pro-SWIFT Act also provides statutory authority for existing space weather coordination activities under the National Science Technology Council. Now, in March of last year, that same National Science Technology Council released a National Space Weather Strategy and Action Plan. And that very same day, the President signed an executive order on coordinating national resilience to something called electromagnetic pulses. Now, they're relevant here because the sorts of geomagnetic disturbances that occur in the sun that are disruptive, they're called space weather disruptive to our space activities. They're both a space weather phenomena, and they're also naturally occurring as EMPs. So since the release of those documents, federal agencies have worked very, very hard on their implementation, and together with the academic and private sector and also international partners, we've made great progress. And I want to highlight very quickly 3 areas. First, the U.S. Geological Survey is working toward completing a survey of ground conductivity across the United States. Now, we're familiar with conductivity, lightning across the sky, and conductivity on power lines, but there's actually conductivity in the ground. And these data help USGS and also NOAA develop new operational and geoelectric field maps, the actual mapping of the geoelectric field. It provides much more accurate estimates of electric currents that are generated by geomagnetic storms. And those things can then disrupt power operations and resilience and things like that. So that hazard map is going to be a very, very important tool that we have to sustain electrical power during geomagnetic storms. Second, as a result also of partnership between NOAA and NASA, NOAA's Space Weather Follow-On spacecraft is scheduled for launch in 2024, that magical year when we're going to return to the moon. This will ensure continuity of observations critical to space weather prediction and forecasting, and also to NOAA's geomagnetic storm watches and warnings that it issues regularly. And third, NOAA, NASA, and also the National Science Foundation have funded several research opportunities that are going to advance solar and geospace modeling and improve space weather predictions. Just like we have models to predict terrestrial weather, we have models to actually predict space weather. And that research targeted key administration priorities established through the space policy directives that the Vice President mentioned, including human space exploration and space traffic management, as Secretary Ross mentioned. These agencies are also working very, very closely together to implement a framework to accelerate transition of space weather research to operations, very, very important transition. And they will help inform key decision making for operations of critical infrastructure like our electric power grid. Finally, the second topic I want to address really briefly is planetary protection. Now, what is planetary protection? It's basically the practice of mitigating risks to Earth of harmful biological contamination due to space activities. Now, there's actually 2 sides of that coin. It includes protecting the search for extraterrestrial life by controlling the introduction of biological contaminants from Earth to other celestial bodies. We call that forward contamination. But it also includes protecting our own biosphere here on Earth from potentially harmful biological contamination from things like returning spacecraft. We call that backward contamination. So as we prepare for human exploration of Mars and other solar system bodies, as the Vice President mentioned, now is the time to review and update our planetary protection policy. Existing U.S. policy was established back in the Apollo program, and it's not really been substantively updated since then, so it's been many decades. Meanwhile, of course, as you all know, there have been very, very significant technological and research developments in the field of space, a lot of new actors, including a lot of private companies, and so things are accelerating very dramatically. So to address this challenge, OSTP and the National Space Council staff, all the wonderful folks here, have partnered over the past 6 months to co-lead an interagency working group on planetary protection. It's really a whole of government effort. And we deliberated several topics. First, of course, as I mentioned, how to accelerate commercial space exploration and development while we also preserve the scientific integrity in the search for life on other terrestrial bodies. We want to avoid that backward contamination to Earth. Likewise, we want to avoid that forward contamination as well. And then also, third, making sure that private sector activities are protected, because we all know that commercial activities, as we've seen here, are extremely important. So looking forward, planetary protection has to really be a key element of our strategy, and it certainly is, across all of the federal government, but also with our academic and our industry partners. We want to absolutely ensure a safe, sustainable, and predictable Earth and space environment as we continue to advance U.S. leadership in space exploration and commercialization. Mr. Vice President, I am completely grateful to the wonderful opportunity you've provided to me and others at OSTP to work with all these great folks on the National Space Council on these initiatives over the last several months and years. And we look forward to the wonderful days that lay ahead for America in space. Thank you very much, Mr. Vice President.
Thank you so much. Calvin, great job. One of the enduring lessons that I've learned as Chairman of the National Space Council is you actually have weather in space. So thanks for your great leadership on that, and so vitally important to our nation's economy and nation's security, as you mentioned. So thank you, Kelvin. Great report. We've talked a lot about the impact on the economy on this National Space Council over the course of the past 4 years. We've talked just as much about our national security, and as I reflected in my opening remarks, with the encouragement of all the members of the National Space Council, this administration has taken strong strides to advance our national security in space. So today I wanted to turn our attention to our security issues. For the first time in his role as Director of National Intelligence, John Radcliffe joins us today. He's going to provide an update on international space threats and the competition that we face. John, you and I have talked. You wrote a compelling piece over the last several days, particularly about the strategic competition that China poses us here on Earth, as well as in the heavens. We appreciate your leadership very much. But as I said before, I think you understand, the President understands, is space is a vacuum, but we're not operating in a vacuum, especially when it pertains to the security of the people of the United States of America. So join me in welcoming the Director of National Intelligence, our DNI, John Radcliffe, to the National Space Council.
Thank you, Mr. Vice President. And let me start. I know this is a common refrain as you listen to all of my fellow council members, but it's because we all marvel at your success and leadership over this Space Council. And I think everyone here wants to express our gratitude and appreciation from the Council and on behalf of a grateful nation. So thank you very much. To my fellow council members, thank you for allowing me to update you on the threats that we face in space and how the intelligence community is taking unprecedented action in order to increase the effectiveness of our national security space enterprise and to respond to the President's new space policy. By almost any measure, the dramatic increases in space-related capabilities and services over the past decade have been game changers with profound implications for life on Earth. Currently, over 80 nations operate in space, and 50 countries have dedicated government budgets for space. And governments are not the only players in space. Dozens of new commercial space companies have emerged with plans to launch tens of thousands of satellites in the coming years, more than all of the satellites that have been launched since the dawn of the space age. Over the past 5 years, U.S. companies have launched more commercial remote sensing satellites into orbit than the rest of the world. But today that trend is reversing. The National Geospatial-Intelligence Agency, which I oversee, predicts that in this decade, the rest of the world will launch at least twice as many commercial remote sensing satellites as the United States. Economically, the global space industry has grown rapidly in recent years and is now approaching $500 billion in annual revenue. But more critical is that broad sectors of the U.S. economy have come to rely upon space-related capabilities. Our estimates suggest that industries with reliance on space-based services now contribute over $5 trillion to our gross domestic product. Simply put, we depend on space systems as critical infrastructure, directly supporting the American way of life. If these space-based services are disrupted, we could see adverse effects on nearly all sectors of the U.S. economy, including consumer supply chains, transportation, telecommunications, agriculture, and finance. Mr. Vice President and fellow members, to a degree unparalleled in American history, the nation's economy and security rely upon space systems that our competitors are challenging and that our adversaries are increasingly threatening. To that point, America's vital interests are increasingly at risk as China and Russia develop and field destructive weapons to threaten U.S. and allied space capabilities. As I wrote in an op-ed published in the Wall Street Journal last week, the intelligence is clear. China poses the greatest national security threat to the United States, and that includes China's actions in space, where China is pursuing weapons capable of destroying our satellites up to geosynchronous Earth orbit, where many of our critical space systems reside. China has also deployed a ground-based missile intended to target and destroy satellites in low Earth orbit. Russia has a similar system to China in development that is likely to be operational in the next several years, and Russia has also fielded a ground-based laser weapon which could blind or damage our space-based optical sensors. And I'll note, that Russia in particular has recently demonstrated provocative behavior, creating a potentially dangerous situation in space. Over the past year, the Russian government, as the Vice President noted, launched a satellite that began to actively maneuver close to a U.S. government satellite. I want to make clear to the members of this council that we consider this to be threatening behavior, especially considering that the Russians have previously launched a very similar satellite that exhibited characteristics of a weapon when it released a high-speed projectile. Our Space Force Chief, General Raymond, agreed by recently saying this is not the behavior of a responsible spacefaring nation. In short, the threat to the United States and allied space systems continue to grow, and we should not allow that threat to grow unabated. And because of that, the President's new national space policy recognizes that space is and should be a priority intelligence domain, something the intelligence community has already begun to take action on and to move out. Earlier this year, we directed our intelligence agencies to increase support to space defense and added new funding to counter space threats. Although those numbers are classified, this represents a significant new investment which will directly address the emerging intelligence requirements of the Space Force. Additionally, we are working directly with the Space Force leadership to create a new National Space Intelligence Center which will deliver intelligence support necessary to achieve our national security objectives. The establishment of this new center will provide the nation unparalleled scientific and technical intelligence on space-related threats, and it will serve as the service intelligence center for the Space Force. As I described earlier, America's entrepreneurs and innovators are demonstrating amazing new capabilities in commercial space marketplace. The new national space policy recognizes that the rapidly expanding commercial space industry is a vital element of national power. Consistent with this recognition, I recently approved the creation of the Intelligence Community Commercial Space Council. This is a high-level forum which will facilitate collaboration across the intelligence community and with industry, focusing on the intersection of commercial space services and national security. The Council will deepen our understanding of the capabilities and trends of both the United States and foreign commercial space industries. It will provide recommendations to bolster our use of commercial space capabilities, and it will support the growth of a robust U.S. commercial space industry that is responsive to our national security needs. As an example of our increasing engagement with the commercial space sector, the National Reconnaissance Office, or NRO, recently conducted a national security mission on a small commercial rocket launched from outside of the United States, an achievement which was a first for our intelligence community. The new national space policy also recognizes that the intelligence community and the Department of Defense are co-equal partners in the national security space enterprise, with both operating a variety of spacecraft that perform vital missions to our nation. However, countering the increasing threats we face now and in the future will require an even higher level of collaboration and integration than in the past. Previously, we reported to this Council that the intelligence community and Department of Defense have agreed to align U.S. Space Command and the NRO under a new protect and defend strategy for the purposes of jointly guarding our vital space systems should a conflict ever extend to space. For the first time, there will be a unified structure that fully integrates intelligence and defense plans, authorities, and capabilities to ensure seamless execution of space defense actions. I'm pleased to report that the NRO and Space Command are testing this emerging construct in a series of war games and experiments that are designed to pressure test the new arrangement before Space Command reaches its full operational capability. Finally, I am very pleased to report that my team at the Office of the Director of National Intelligence is working with our Space Force leadership to evaluate the potential for the Space Force to become the 18th member of the United States intelligence community. We anticipate a decision on this history-making opportunity in the next month or two, which would profoundly strengthen the partnership between the Department of Defense and our intelligence community. In conclusion, as adversaries increasingly threaten our vital interests in space, the actions that I have described here for you today, plus many more of a classified nature that I cannot discuss publicly, will continue to provide us with a competitive advantage, will allow us to counter emergent threats in space, and allow us to achieve unified action should conflict ever extend to space. I want to assure each of you, my fellow council members, as well as the American public, that if our adversaries challenge us in space, they will face a truly united national security space team. Thank you again, Mr. Vice President, for the opportunity and members of the Council to address you on these important efforts. Thanks very much.
Excellent. Well, thank you, Director Radcliffe. Thank you for that stirring summary, but also thank you for the visionary recommendation. We very much look forward to that, and the notion of adding the United States Space Force to the infrastructure of our intelligence community. Makes great sense, and I want to commend you for leaning into this and making such a meaningful contribution to this 8th meeting of the National Space Council.
Thank you very much.
Thank you very much, John. There has always been a chair on the National Space Council for the Secretary of Defense, and successive Secretaries of Defense have played the role and have been full partners in renewing America's commitment to our national security in space. We're deeply grateful to them for their service, but a common denominator, a consistent ally and advocate for advancing America's national security interests in space has been the Deputy Secretary of Defense, David Norquist. And I just want to take this opportunity to thank the Deputy Secretary of Defense for taking the guidance of this National Space Council, taking the vision of the Commander-in-Chief, and moving out so quickly at the Department of Defense. You've made a great difference in the security of this country in the vast expanse of space. So join me in thanking Deputy Secretary of Defense David Norquist for a job well done.
Good afternoon, everyone, and thank you, Vice President, for chairing this meeting today. You just heard about some of the challenges and threats facing us in space. Since the last National Space Council meeting back in May, the Department of Defense has made tremendous progress in adjusting to the challenges of space as a warfighting domain. Today I want to highlight our developments across the Department, the U.S. Space Force, U.S. Space Command, and within the Office of the Secretary of Defense. And in doing so, I want to thank those around the table. Your efforts and partnerships are vital to achieving our nation's objectives in space. So let me begin with an update on the Space Force. In order to grasp the magnitude of what the Department of Defense has accomplished, it is worth pausing to reflect on the timeline. The Space Force was officially established when President Trump signed the fiscal year 2000 National Defense Authorization Act on December 20th, 2019, less than 1 year ago. It was originally planned that the Space Force would be established 1 year after the NDAA was signed. So, Mr. Vice President, that would have been 11 days from today, and I would have been spending today explaining to you the things we hoped to get done and might get done in the future. But instead, the President and Congress understood the urgency of strengthening our space-based military capabilities, and they directed us to get right to work. Following this spirit of speed, we have moved rapidly to advance the Space Force, and we have reached many milestones. Operationally, the Space Force has launched satellites into space and provided support to NASA's 2 successful human space flights launched from right here in Cape Canaveral. The Space Force has also engaged with our allies and partners to enhance cooperation in space. We have now seen them place a higher priority on this domain as well. The UK, which announced the creation of a Space Command last month, and France, which had adjusted from the Air Force to now having the French Air and Space Force. Through all of this, the Space Force has continued delivering new capabilities for the United States. In fact, in August, the National Aeronautics Association recognized our X-37B spaceplane with one of its most prestigious awards, a distinction also given to Orville Wright and the Apollo 11 team. Structurally, we have created a new and leaner field organization comprised of 3 field commands and 9 space deltas that cover missions such as intelligence, surveillance, and reconnaissance, space electronic warfare, and space domain awareness. The Space Force's success thus far are reflected in its people. Since its founding, it has grown substantially, which is a trend we expect to continue. Over the last 3 months, more than 2,100 members have transferred from the Air Force into the Space Force. We anticipate that an additional 3,700 airmen skilled in fields such as intelligence, acquisition, engineering, and cyber will transfer in the next 3 months. These men and women have great leadership in General Raymond, who will become a statutory member soon of the Joint Chiefs of Staff. With the right people and leadership in place, we are focused on cultivating the culture of the service. In this respect, we have also made great strides. For example, just 7 months after the Space Force was established, the service released the Space Capstone publication, its first doctrine document. This is a military service's fundamental responsibility because it articulates their unique purpose, identity, and operational mindset, and it informs the joint doctrine. Significantly, the Space Capstone publication identifies space power as a distinct form of military power that is vital to U.S. prosperity and security. The Space Force's motto, Semper Supra, captures their role well. Safeguarding U.S. advantages in the ultimate high ground requires them to be always above. Next, I'll provide an update on U.S. Space Command. Just as we have at sea, it is important to establish responsible standards and norms in space. U.S. Space Command is promoting these efforts and calling out those, like Russia, who violate these standards and norms. In August, we welcomed General Dickinson to the helm through U.S. Space Command's first change of command ceremony. He made history by becoming the first Army general to lead the combatant command. I should note that his predecessor, General Raymond, had served in a dual capacity, Chief of Space Operations and Commander of U.S. Space Command. The Department is grateful to General Raymond for stepping up to serve in these 2 consequential roles. Finally, I would be remiss if I didn't share the progress the Department has made within the Pentagon. In June, we released a new defense space strategy. Over the next 10 years, this document will guide the Department in achieving our desirable conditions for a space domain that is secure, stable, and accessible. Similar to our national defense strategy, we pursue our objectives through 4 lines of effort. These are: build a comprehensive military advantage in space, integrate space into national, joint, and combined operations, shape the strategic environment, and cooperate with allies, partners, industry, and other government departments and agencies. If you have not done so and had a chance to read it yet, I would encourage you all to do so. It will give you a clear sense of how the Department's thinking has evolved on space from a policy perspective. This defense space strategy served as a part of our Department's contribution to the development of the new National Space Policy, which we are proud to support. Another indication of our prioritization of space was creating an Assistant Secretary of Defense for Space Policy. I established this office in response to the bipartisan fiscal year 2000 National Defense Authorization Act and to fulfill your due out, Mr. Vice President, when you announced the Space Force in August 2018. Congress rightfully identified civilian oversight of the space enterprise as an area of necessary change. The Assistant Secretary of Defense for Space Policy will now be responsible for interagency coordination and international engagement on space policy and strategy. With this elevated level of leadership, we will bring heightened focus to the space domain as we prepare for long-term strategic competition and ensure alignment with the Space Force and U.S. Space Command. In conclusion, the Department of Defense has had a significant and successful past 7 months. We remain committed to continuing this important transformation of our national security space program, which just prepares us for deterring the high-end fight. Thank you all very much.
Thank you so much, Deputy Secretary Norquist. And again, I know I speak on behalf of the President and everyone on the National Space Council and our Secretaries of Defense over the last 4 years when I say how grateful we are. You are the get it done guy at the Pentagon, and thanks for getting it done so quickly and standing up our United States Space Force and in all the ways that you've described. Someone else who deserves a tremendous amount of credit is I want to call on for maybe just a few brief reflections following the Deputy Secretary's remarks. He's a former commander of the United States Strategic Command, led forces in Operation Enduring Freedom, Operation Iraqi Freedom, led and commanded Air Force Space Command, and now, fortunately, we arrive at a time in the moment in our history when, as we are standing up American military leadership in space, the Vice Chairman of the Joint Chiefs of Staff brings a lifetime of dedication and experience to America's military security in space. So let me invite all gathered here first to thank General John Hyten for his lifetime of service, and General Hyten, any reflections that you have on this first year of the United States Space Force. General Hyten, everybody.
Thank you, everybody. Thank you, Mr. Vice President. I have a million reflections. To choose from everything that's going through my mind right now is nearly impossible, because this is an exciting time. This is an important time. But it's a time that, as Director Ratcliffe clearly pointed out, we have a threat. And what we're doing and what we have been doing is about how do we respond to that threat. And the partnership we have with the intelligence community is as strong as it's ever been. And I was so excited to hear the concept of the Space Force being the 18th member of the intelligence community. That presents so many opportunities for us to do things in much better ways of how we do surveillance, how we do intelligence. All those things open up by just that simple idea. So as I sit here, I'll just say that Space Command and the Space Force have two basic functions. When you look at the Saturn V that's above us, you like to look up and dream. And I was involved in the previous edition of the United States Space Command, and I'll say that command really liked to look up. And we need to look up, and we need to surveil, and we need to understand the threat. And you heard the Vice President and the Director of National Intelligence talk about the Russian threat that we watch very closely through the partnerships we have with our own sensors, with the intelligence community sensors, so we know exactly what's going on and exactly what they're doing. But the reason the United States military is in space is really to look down and make sure that our planet is safe, and that we support the Army, the Navy, the Air Force, the Marines, all of the elements of our national security, support the joint force and make sure that it is secure. And if you look at everything that we do every day, and you heard the deputy talk about the amazing organizational changes that are under, but actually it's the mission and the people that do that mission every day that are the key piece of it. And you just look back in January when missiles were launched from Iran into al-Assad in Iraq, and you look at the warning that was provided immediately from the operators in the United States Space Command that allowed people to take cover, and the exquisite indications and warning that were put together by Space Command people, Space Force people, working together with the intelligence community to make sure that no American died in that attack. That's a remarkable piece. So, Mr. Vice President, thank you for your leadership. It is actually a joy to work with you in any meeting I've ever been in. And I want to say that I look forward to the future. You know, the one thing about all 4 stars, General Raymond, is that we're all circling the drain. You know, we're all pretty much done. But the other thing about all of us is, man, wouldn't you like to go back and be a second lieutenant in the United States Space Force today and do it all over again? That would be exciting. So, Mr. Vice President, thank you.
General John Hyten, everybody. I think it's worth noting for the record that I gave him absolutely no notice prior to those remarks. I think you can hear the heart and the mind of someone who's been absolutely committed for a lifetime to American security in space. And as I've said to you before, General Hyten, I can't help but feel that for such a time as this, you're Vice Chairman of the Joint Chiefs of Staff. So thank you for your stalwart leadership and a lifetime of service. Join me in thanking General Hyten one more time. Closer to home on security, and I apologize that I didn't give him any notice at all, the acting Secretary of the Department of Homeland Security. I've come to know him over the last 4 years of service, and have been deeply inspired at his implementation of American law, security on our border. But the members of the National Space Council deserve to know that under Acting Secretary Chad Wolf's direction, the Department of Homeland Security has also been working to increase outreach to the private sector to ensure cybersecurity in space systems, which is of equal importance to our economy, to the privacy of the American people. So for a few minutes of reflections on the progress, the efforts DHS has made, join me in thanking Acting Secretary Chad Wolf, member of the National Space Council.
Well, let me start off by, again, expressing my gratitude, Mr. Vice President, for your leadership of the Council, as all of our Council members have said today. The work that not only you, but the staff have done over the last 4 years in advancing American leadership in this area, I think, is a testament. The Department of Homeland Security, as you said, is hard at work at helping to implement the national space policy in two primary areas, and that's in cybersecurity and resilience. And so what we call the left of launch, or before launch, is a critically important time. Cybersecurity and supply chain security of space systems is paramount. And to support this effort, the department is leveraging our relationships and our processes with critical infrastructure owners and operators around the country through our Cybersecurity and Infrastructure Security Agency, or CISA. And CISA is leading the newly established Space Information Sharing and Analysis Center, or ISAC. And that's a forum for U.S. government and private industry can share information and best practices, and we do that through a number of other industries as well. We are also partnering with our colleagues at the Department of Commerce, Secretary Ross and others, to engage more small and innovative companies wanting to engage in this area as well. After launch, or to right of launch, as we say, DHS is leading in the testing, the resilience of federal and critical functions through the exercising of continuity of operation practices. These left of launch and right of launch approach will increase the security of our homeland, will certainly broaden our private sector and international partnerships, and will support the important work of the American space activities. So let me just close by, again, thank you, Mr. Vice President, for your leadership for this council, and the department stands ready to support its ongoing work. So thank you.
Thank you, Chad. Thanks for the kind words, and thanks for your leadership. Thanks for your leadership, Mr. Secretary. We couldn't be more grateful. I'm going to get a couple of people, put a couple more people on the spot who've played just a leading role in our ability to move out on the policies that have been advancing our economy and our security. Brooke Collins is the director of the President's Domestic Policy Council, and Russ Vought is the head of the Office of Management and Budget. And I can tell you that over the course of the last 4 years, both of them have been consistent partners in our effort to identify the resources on the security front and in reviving human space exploration here at NASA, but also in promoting the vital role that American leadership in space has played in our economy, as the Secretary has reflected momentarily. I also want to recognize Brooke Collins because while we are here at the Kennedy Space Center, we are on the Space Coast with Lieutenant Governor Nunez and a lot of proud Floridians. Texas likes to boast of their long history in space in Houston, and Brooke Collins is a daughter of Texas and Council Lone Star State home. So thanks for bringing all that natural Texas passion to your efforts on behalf of space. So I'm going to recognize Brooke Collins, Domestic Policy Council, and then the Director of OMB before we turn our attention to national space policy and to the Director of NASA's report. Brooke?
Well, this is unexpected, Mr. Vice President, but thank you. It will only be 1 minute, and thank you for the shout out to Texas. It's great to be here in Florida as well. I am struck as I sit here as the mother of 4 children. I know everyone's sitting in the room and watching in the audience and watching on TV at how inspiring that this group led by our president and also you, Mr. Vice President, we have reignited America's imagination. And for the young girl or young boy from the plains of Texas or from the coast of Florida or from the cornfields of Indiana, that one day they too could go to space, to the final frontier, and to reach for the stars. And that is America. And so what an honor it is to be a part of this. And thank you for your leadership and for everyone here today. Thank you.
Director of the Office of Management and Budgets, a man I've known for many years, and he is a tight-fisted steward of the public treasury. But I want to take this opportunity to thank Director Russ Vought for finding a way for the largest increases in NASA's budget in the modern era, and for also finding a way to make sure that our standing up the United States Space Force had the resources necessary. So, Mr. Director, thank you, and we'd welcome any remarks you'd have for the National Space Council today. Director Russ Vought, the Office of Management and Budget.
Thank you, Mr. Vice President. It is a privilege to be back here. And budgets are about priorities. And one of the things that this administration under the President and your leadership has been insistent upon from the very beginning is that we're going to get back to space. We are overjoyed that we've been able to increase the budget by 15%. Right now we're in the midst of hard-fought negotiations to get our 12% increase to make sure that we have the resources to get back to the moon and Mars and beyond. But I want to build off of what Brooke said, and that is to get to... But I want to build off of what Brooke said in terms of the national momentum that's been built around getting back to the moon and staying there. I've got 2 little girls, a 6-year and 8-year-old, and when there's extra cardboard around the house, they're building rockets. They've got pictures of astronauts in their room, and on Saturdays we change the channel from the football game to watch the launches. And so you are getting a sense nationally of the momentum that's building as a result of the leadership of the President and the Vice President, the Space Council, the important work of Jim Bridenstine. And we're excited at OMB to play a behind-the-scenes role to get the resources that are necessary to bring agencies together, to build consensus, to make sure that documents and regulations go out that reflect all one view of the administration. And I thank you for the honor to be here.
Thank you so much, Director Russ Vought. Thanks for your efforts, and thank you for that. Thank you for talking to us about your little girls. I think it's one of the points you make, one of the points Brooke made is that having revived America's commitment to human space exploration and innovation, rededicating ourselves to American leadership in space for our national security, I can't help but feel that it's going to inspire kids to pursue STEM education and to have their eyes on the stars. So thank you both for those without any notice remarks. Very inspiring. I'm going to ask Dr. Scott Pace, who has been the Executive Director of the National Space Council over the last 4 years, has been my right arm throughout this effort to come forward. Today, President Donald Trump signed an updated national space policy for the United States of America, just in time for this 8th meeting of the National Space Council. And I've asked Dr. Pace to give us a very brief update. You all should have a copy, and for those of you looking on, the new National Space Policy of the United States of America will be available online for all of the country to review. But Dr. Pace, maybe you could just update members of the Council on the policy and specifically how it differs from previous space policy at this important moment in the life of this program and in the life of the United States Space Force. But before I do that, I do want to give all of you a chance. We are only as good as the people who are behind us, supporting us, advising us, informing us. And I must tell you, it's been one of my great privileges over these past 4 years to enjoy the friendship, but the extraordinary professionalism and guidance of Dr. Scott Pace. So would all the members of the National Space Council join me in showing our appreciation for Scott Pace for the great job you've done.
Thank you, sir. And as several people have heard me say in speeches, there's nothing more terrifying than having a boss who cares about what you do. Your caring and the caring of the President have been absolutely instrumental to whatever progress we've been able to make. With the strong leadership from the President and your National Space Council staff has been working closely with all the members of the Space Council to develop the new national space policy. I promise not to read it. It's rather thick, and it's there in front of you. And I wanted to take the opportunity to express my personal thanks and appreciation to the members of the Interagency Working Group that contributed to this policy. About 11 agencies, 5 White House councils. There's a lot of folks who are part of this effort, and as well as the thoughtful advice from the members of the Users Advisory Group. The National Space Policy is the President's direction to U.S. government departments and agencies to advance the interests of the United States in space for the benefit of the American people. And this policy outlines fundamental principles of the United States regarding its activities in space and details future goals and executive branch tasks to achieve them. The policy reaffirms the nation's interest to act responsibly in space to ensure safety, stability, security, long-term sustainability of space activities. And as such, it's similar to past policies in that it reflects long-standing efforts that extend back decades, the beginning of the space age, while recognizing new challenges and new opportunities in front of us. The National Space Policy at top level gives primary emphasis to 4 topics: commercial space activities, international cooperation, exploration, science, and national security, which undergirds everything we do. And the policy expresses the nation's commitment to leadership in space. The major point I wanted to make, as we have heard around today, is that the international environment we're in is very dynamic. It's influenced by competition and threats to the space capabilities on which we rely. And consequently, it's important that the U.S. space activities across all sectors, civil, commercial, and national security, be coordinated at the highest levels in an integrated manner to advance our national interests and those of our allies and partners. A policy of sustainable space exploration and development depends on an alignment with enduring national interests such as security, economic growth, scientific advancement, and a stable international environment. Space does not exist for its own sake. It exists to serve the interests of the nation, and our alignment with those interests is crucial to our success. Establishing U.S. capabilities to operate routinely out to the moon and beyond will deliver strategic assets not only for ourselves, but for all like-minded nations who share our values: liberty, democracy, rule of law, free market economic principles. It is our values we carry with us into space, not merely our machines. Space exploration and development are not confined to one-time missions or any single destination. Closer to home, the United States is going to encourage commercial activities to lower the public burden of maintaining and enhancing space capabilities. And as the United States journeys again into deep space, it will do so with commercial and international partners. And at the frontiers of exploration, the United States will continue to lead, as it always has done. The United States is leading in space, but we also face determined competitors and adversaries. The President's National Space Policy continues the quest to explore and develop the unknown while securing benefits for the American people, which has driven our country since its founding. This drive, rooted deeply in the spirit of the United States, will ensure that as humanity expands into space, it will be the home of a free people. With that, Mr. Vice President, thank you for the opportunity, and be happy to take any questions.
Thank you, Dr. Pace. And the National Space Policy of the United States, I was there Literally, when the staff secretary brought this into the president late yesterday, I know people worked around the clock on an interagency basis to get this completed before the 8th meeting of the Space Council. And where might people be able to review this today? We'll make sure it's on whitehouse.gov. But
I'm pleased to say the White House Digital Services has been great, and it's available online.
Okay, available online, National Space Policy, and would recommend it to the attention of any American interested in a broad outline of what our priorities are and what our objectives are with regard to American leadership for our economy and our security in space. But thank you so much, Dr. Pace, for the report. But another round of applause for really a tireless public servant and all the work he's done. Finally, we will now turn our attention to NASA's activities with a report and a very exciting announcement today from the administrator of NASA, Jim Bridenstine. Many of you may not be aware that prior to serving as the 13th administrator of NASA, Jim Bridenstine was a Navy pilot, flew combat missions in Iraq and Afghanistan, flew more than 1,900 hours. I first met him when he was a congressman from Oklahoma, serving on the House Armed Services Committee. But very early on, it was apparent to President Trump that this was a man who had a deep passion for American leadership in space. And I must tell you that when I think of all the progress that we've made in reviving American leadership in human space exploration, when I think of the historic steps that we have taken in the last 4 years to ensure American military dominance in space as much as on land and sea and air, I am truly grateful, as I know the President of the United States is, for the service and tireless efforts and enthusiasm of the 13th Administrator of NASA. Join me in thanking Jim Bridenstine for all that he's done and for the important announcement today.
Wow. Standing ovation from the Vice President of the United States. I will tell you, sir, it's been the joy of my life to serve this little agency called NASA that does just amazing things. I will also say, and sir, I know you've heard it today all day long from all of the people sitting around this table, but this has been a game-changing administration as it relates to space. From day one, this administration came in committed and not just giving it lip service, but moving out on it. And you're hearing it not just from me, but from everybody around this table who has served with and for you, sir. And your leadership here has been astonishing. I have said, and I'll keep saying it, one of the best things President Trump did was reestablish the National Space Council. And right after that, putting his #1 guy, the Vice President of the United States, in charge of it. And it's been just a real pleasure serving on this council with you, sir. So I'll go through kind of where we are with the Artemis program, which of course is our return to the moon, not just with the next man, but with the first woman, which was a very direct order from the Vice President of the United States, who is carrying out the direction of the President of the United States. And So here's where we are, sir, and I'm very pleased to report the core stage of the SLS rocket is complete. It is at the Stennis Space Center being tested. All 4 RS-25 engines have been integrated, and we have now completed 6 of the 8 tests for what we call the green run. Right now we are in the midst of the 7th test, which we call the wet dress rehearsal. And of course, the next test after the wet dress rehearsal is, no kidding, a live fire test of all 4 RS-25 engines. So we are very excited to be where we are. The SLS rocket, of course, is the moon rocket. I know we're sitting underneath a Saturn V, and this, of course, reminds us of the history, but we are here today talking about the future. And I want to assure my friend, the Director of National Intelligence, John Ratcliffe, that Saturn V is very secure. So we are not going to need a new DNI today, and I made sure of that. So I do think it's important to note that the SLS rocket, Mr. Vice President, is back on track and moving forward. The Orion crew capsule is complete. It has gone through environmental testing. We have done the launch abort testing, which is also complete and has been successful. It is mated to the European Service Module, and of course it is here at the Kennedy Space Center waiting for some more processing. So that again is good news. As we move forward, one of the big things that you gave us direction to do, and this was at the IAC, the International Astronautical Congress, was to make sure that we partnered with freedom-loving countries. And we have done that. We put together the Artemis Accords, which establishes what are the norms of behavior, what are the things we expect our partners in space exploration to do as we explore space together. And so we wrote out the Artemis Accords. We had great support from the State Department. I want to really tip my hat to what the State Department did. The Artemis Accords are complete. We're looking for transparency from all of our international partners. We're looking for interoperability. We're looking to make sure that if there are astronauts in distress, we all support each other. We're looking to make sure that the future of space exploration is peaceful. And all of this was enshrined in the Artemis Accords. And of course, one of the reasons to do all of this is because when we go to the moon this time, it's going to be with international partners, which we didn't have last time, but also this time we're going to have commercial partners. And we need to have the processes by which we can all agree to explore the moon safely, both with commercial and international partners, as the United States of America leads this coalition to the moon and eventually onto Mars. I want to be clear, we already have 9 countries that have signed up, 9 freedom-loving countries that signed up, and we just announced the Artemis Accords earlier this year. There are more countries that we're talking to every day that are interested, but here's the thing, and this is my experience as the NASA administrator. Everybody loves Artemis. All of our international partners want to be part of the Artemis program. That gives us a great tool of soft power to say, we want you with us, but when you come with us, there are basic standards of behavior that we need you to abide by, and all of those standards, by the way, are enshrined in the Outer Space Treaty of 1967. So all of that is very positive. The Gateway, our little, it's not really a space station, but it's an outpost around the moon, but it's going to give us the extra energy that we need to get to low lunar orbit, to the surface of the moon, and then back to the Gateway. The Gateway is under development. We are rapidly moving forward on the Gateway. The power and propulsion element and what we call HALO, which is Habitation and Logistics Outpost, is under development. We're going to put those two together. We're going to launch them on a single rocket, and we're going to do that by the year 2023. So the Gateway will be underway by 2023. We're also very excited that the Gateway, in fact, and this is for Dr. Drogemeyer, we've already selected 2 science experiments to be on the Gateway in orbit around the moon, and those 2 science experiments have to do with space weather and the radiation of deep space. So this is going to enable us to get more science than we could otherwise get, and of course we all know Dr. Drogemeyer. He mentioned Oklahoma earlier. Dr. Drogemeyer comes from Oklahoma, very amazing weather scientist, and now expanding that field all the way to space weather. So we're there with you, sir, and we'll keep moving forward on that. We think about our European partners. Recently signed an MOU with us on the Gateway. So we can very proudly say that when we go to the moon, we have already got commitments from the European Space Agency, not only to have astronauts with us, but also to provide hardware that is going to be very significant for our sustainable return to the moon. So we have also opened up the aperture a little bit when we go to the moon. One of my first initiatives, Mr. Vice President, as you know, was we're going to go commercially, as directed by you and the President of the United States. So we initiated the Commercial Lunar Payload Services Program to take NASA payloads to the surface of the moon. where we buy a service. We don't own and operate the hardware, but we buy a service. We now have a number of companies that have signed up to be part of this program. Sir, you mentioned earlier that we're going to actually buy some of that regolith on the moon. We're going to buy resources, and we're going to prove that this is a model of operations that is workable. And of course, the Artemis Accords are a big part of that as well. I saw Sean Mahoney is here from Aston Space Systems. I think Secretary Ross, you mentioned Astrobotic. So there are a lot of small, innovative, impressive companies raising money and moving out because of the policies that we've put in place to go to the moon commercially. So all of that is very exciting. Finally, I'm gonna anchor real quick on the human landing system, which of course we have the SLS rocket, we have the Orion crew capsule, we have the European service module, we have the Gateway. The one thing we have not had since 1972 is a human landing system. And now we have, Mr. Vice President, because of your leadership and the leadership of the President, we have a human landing system funded for the first time since 1972. We have 3 companies, yes. We have 3 companies that are under contract. There's a lot of companies involved, I want to be clear, but 3 prime contractors that will be leading the efforts for the human landing system. We're in a base period right now where we're looking at how we're going to land on the moon. And ultimately, by February of 2021, we're looking to do a down select from 3 to 2 so that we can come to a resolution on how we're going to land on the moon by 2024. Now, I want to be clear when I talk about the human landing system, Mr. Vice President, the budget request, thank you to the Director of OMB, Russ Vogt. The budget request gave us what we needed to achieve a 2024 moon landing. And as of right now, this agency is meeting all of its milestones. Yes. We are in the midst of, as the Director of the Budget has said, we're in the midst of negotiating to get that lander funded. The bill passed in the House, funded it to the tune for 2021 about $600 million in the Senate. It was about $1 billion. Now, $1 billion is a lot of money, and I want to be really clear. We are so grateful for the bipartisan support for this. That's one of the biggest things that we have to have moving forward. This has to be generational in nature, which means strong bipartisan support is necessary, and we're grateful for that. But ultimately, if we don't get the $3.3 billion, it gets more and more difficult. So I'm making sure to communicate, as I do always, to our legislators. If there's anything you can do to help with the $3.3 billion, we are certainly asking for that. Sir, I've been told we're going to show a video here, but I can see, did you have anything to say before we go to the video?
Well, I think we've got a very exciting announcement coming up, but I just couldn't be more grateful. For those of you looking on that are just now taking an interest in the program, we are beneath an Apollo Saturn V rocket, but we're about to see a major and historic step in setting into motion in one more way the Artemis program and the Artemis rockets that will take to the skies over the next several years and on to the moon and ultimately to Mars. I want any school children looking on to know that Artemis is the twin of Apollo, except Artemis is going to go a lot farther and inspire the world once again. So join me in thanking Administrator Jim Bridenstine, and then we'll move on to a very exciting announcement.
The Apollo missions were a daring success
and highlighted what a generation of ambition can accomplish.
We choose to go to the moon, but in a whole new way.
Not as a destination, but as a beginning.
And not alone, but with a global coalition of explorers.
This calling is part of what makes us human.
And it is this generation's turn to set the tone.
We are going
to lead a journey of discovery
that benefits our planet with life-changing science.
To use the moon and its resources as a technology testbed to go even farther.
To learn how to establish and sustain a human presence beyond Earth.
This time, we're going as the Artemis generation.
We will discover, prove that it's possible,
and bring all that we learned back home. To benefit all of humanity.
And then we will take the next giant leap.
Mars.
Welcome.
Welcome. Welcome to the Artemis generation.
Welcome to the Artemis generation. A lot of you in this room, you've heard me talk about the Artemis generation. I'm the first NASA administrator in history that wasn't alive when we had people living and working on another world. And of course, it is our goal that I'm the last NASA administrator in history that wasn't alive when we have people living and working on another world. Our goal is to go to the moon sustainably, to learn how to live and work on another world so that ultimately we can take all of that knowledge onto Mars. And the Vice President of the United States came to the Marshall Space Flight Center in Alabama, and what he said to us at that time was he directed us to make sure that we go back to the moon, this time sustainably, and we go back to the moon with the next man and the first woman. And that's what this program is all about. And today we have this very special and unique milestone where it is time to announce who those people will be. And Mr. Vice President, if you would come up to the front here and share with the audience who our astronauts are going to be. This is the first cadre of our Artemis astronauts. I want to be clear. There's going to be more. And of course, there's going to be astronauts that are in low Earth orbit that are going to go to the moon, and astronauts that go to the moon that are going to be in low Earth orbit. But Mr. Vice President, please do us the honor of introducing who these folks are, and you'll see on the video their images when he announces them.
Thank you, Jim. It's now my honor to announce the names of the Artemis astronauts who will take us back to the moon and beyond. Joe Acaba. Kayla Barron. Raja Chari. Matthew Dominic. Victor Glover. Woody Holberg. Johnny Kim. Christina Cook. Kjell Lindgren. Nicole Mann. Ann McLean. Jessica Meir. Jasmine Mogbeli. Kate Rubens. Frank Rubio. Scott Tingle. Jessica Watkins. And Stephanie Wilson. And now it's my special honor to welcome 5 members of the Artemis generation who are here with us today at the Kennedy Space Center. Jessica Watkins. Matthew Dominic. Ann McLean. Joe Acaba. And Jessica Meir. My fellow Americans, I give you the heroes of the future who will carry us back to the moon and beyond, the Artemis generation. Well, thank you all for stepping forward and for the excellence that you've shown throughout this program. And congratulations to you and all of those that were just named that are part of the Artemis generation. It really is amazing to think that the next man and the first woman on the moon are among the names that we just read, and they may be standing in the room with us right now. We started today reflecting on a great hero of the past. The Artemis generation are the heroes of American space exploration in the future. Would you join me in showing our appreciation for their great heroism and their character one more time? Well, thank you all. We're going to wrap up very quickly here, this 8th meeting of the National Space Council. With gratitude to these heroes who stepped forward, and let me just say a personal note of gratitude to all of the dedicated men and women and the staffs who stepped forward to serve the National Space Council over the last 4 years. I think you could tell today in just summary fashion the extraordinary difference for our economy and for our security that the National Space Council, under the leadership of President Donald Trump, has made in renewing American leadership in space. And join me in thanking all the members of the National Space Council one more time. Would you please? I also want to take the opportunity to thank members of the User Advisory Group. This is an extraordinary group of Americans that come from the very heart of the American space enterprise. And they brought their incredible professionalism and their incredible experience to bear on ensuring that we had the very best guidance to take the steps necessary to promote and expand America's space enterprise. There are a few that are with us here today. And first, I want to thank from afar Admiral Jim Ellis, who has led the User Advisory Group of the National Space Council with such great distinction. Join me in thanking Admiral Jim Ellis for his great work. There are 28 members of the User Advisory Group that have given us great counsel all along the way. They've dedicated countless hours to giving us their very best advice. A few are actually with us here today for this 8th meeting of the National Space Council. So in addition to Admiral Ellis, allow me to thank Lieutenant Governor Jeanette Nunez of the great state of Florida. Thank you for your contributions to the space program. Eric Stallmer, who is with us here today, who is a great space entrepreneur and pioneer. Thank you so much, Eric. Another great space entrepreneur who's been leading the way and has become a great, great champion of American leadership in space, Fatih Osman and his wonderful wife. Thank you for your great leadership. And to a great entrepreneur who brought great business acumen to this, and the great counsel of his wife, Judy, has assisted all along the way. Join me in thanking Indiana's own Fred Klepsch for his contributions to the National Space Council. I come to this 8th meeting of the National Space Council just with a heart filled with gratitude. I'm humbled by the efforts of all of those that are gathered here. The military leadership from the Department of Defense, Secretary Barrett, General Raymond, General Hyten, and others who have stepped forward to really transform the commitment of our nation to ensuring the security of the American people from space, but also the vitality of America's ideals in space for generations to come. But I know I speak on behalf of the President as well when I just express my appreciation for all the members of this administration who caught the same vision. I love what Dr. Pace said a few moments ago. He said there's nothing more terrifying than having a boss who cares about what you're doing, has an interest in what you're doing. And all I can say is I can relate. I'll never forget the day, Jeanette. It was when we were campaigning for this job 4 years ago that I got a phone call. I was on my way to the Space Coast. And then our candidate called me up and he said he wanted to revive something called the National Space Council. And he wondered if I'd be willing, as other vice presidents had done in the past, to be willing to chair it. And so there have been many kind words expressed for your vice president today, but let me invite all of you to thank President Donald Trump and all of those that have served alongside him for renewing American leadership in space. And as I close this meeting and in the company of these extraordinary Americans, let me just also say that I think the best days for American leadership in space are yet to come. And I know with the caliber of the men and women that have stepped forward in this program, Artemis, that we're going to make all new history. We're going to fill up places like this again and again. And I just want to assure all of you that we'll be carrying America's aspiration and ideals into the great unknown, that you go with the confidence of the American people. You will have the support of people all across this country as you inspire the world. And I'm very confident that you will go with the prayers of tens of millions of Americans who are grateful for your courage and your service and the service of all of those that we announced today as part of the Artemis generation. And my prayer will be in those ancient words that you would be confident that as you rise on the wings of the dawn, settle on the far side of the sea, but as the good book says, even if you go up to the heavens, my prayer is that you know that even there his hand will guide you and his right hand will hold you fast. So join me in thanking the Artemis generation, the National Space Council, our user advisory group, and every American who has contributed to this cause these past 4 years. Because of all of you, America is leading in space once again, and we will be leading for generations to come. Thank you very much. God bless you all.
At NASA, we have always answered the innate call to go.
With Artemis,
we are going to stay.
Proving that humanity
can live on the moon,
Mars, and other worlds,
and share the wonders of the solar system with all.
Our story is one of people.
All those who make this journey possible.
From advocates across communities,
to companies across industries,
to countries around the world,
we achieve
this collective endeavor.
Our efforts create impact for all.
Technologies that revolutionize industries.
And jobs that bring prosperity to people.
The discoveries from space
benefit the way we live on Earth today.
And those from the moon
will create a better future
for generations to come. But to do that,
we must go.
Hi, I'm Chell Linger. My name is Raja Chari.
Kayla Barron.
Kate Rubens.
Hi, I'm Christina Cook.
NASA astronaut Joe Acaba.
Jessica Amir.
Woody Hoberg.
Ann McClain.
Stephanie Wilson.
My name is Johnny Kim.
Nicole Mann.
Victor Glover.
Jessica Watkins.
Hi, I'm Matthew Dominic.
Jasmine Morbelli.
Frank Rubio.
Scott Tingle.
This is what we do.
This is what we will do.
Let's go.
We go to the moon to learn how to live on other planets.
For the benefit of all.
Going to space is awesome. My first flight was on the space shuttle. You get into the vehicle, you're all strapped in. You know, we have the countdown timer that's going on. You get to 0 and the launch begins. In your mind, you're thinking, I can't believe this is actually happening. It's the coolest experience ever.
Hola, Joseph. ¿Es tu padre?
Hey, Pops. It's good to hear your voice. Thanks for the support. The launch was awesome.
When I look back to who inspired me, it started with my grandfather. He actually had the old films of the Apollo missions that we would watch. I've been fortunate that I've had those mentors that have supported me and motivated me to be where I am today. I was born in Southern California, reading, playing sports, enjoyed being outdoors, spent some time in the United States Marine Corps Reserve, was a U.S. Peace Corps volunteer, did a lot of different jobs until I found the one that I felt was the most important job on the planet, which is being a school teacher. It was one of the jobs I never thought I would leave until I was given this opportunity to become a NASA astronaut.
NASA astronaut Joe Acaba making his third flight into space.
I've had the opportunity to go on 3 space missions, and I've spent about 306 days in space to actually walk on the moon. For me, to have that as a possibility is just incredible. This is our next step to explore places we have never been before.
All right, NASA family and friends, our first astronaut, Kayla Barron.
I think the thing that's most important to me is just the inspiration of exploration. I think we all have this innate sense to explore, whether you're the one who actually gets to step on the moon or not. I think it changes all of us to know that we can actually do things that would be unimaginable to the generations that came before us. 9/11 happened 8 days before my 14th birthday, so I was in 8th grade. And I was really inspired by how our country responded to that really tragic event. It really made me realize that I wanted to serve and commit myself to something that was bigger than just me. And there's a huge diversity of opportunities in the Navy, whether it's flying a plane, driving a surface ship, driving a submarine, being a doctor. And I spent a week with the submarine warfare community, including a day underway. And I was so impressed by the sailors on that submarine. They just seemed like the kind of people who would teach me how to be a good leader. For me, the dream of becoming an astronaut cemented itself pretty late in my life. I went back to the Naval Academy to work for Admiral Ted Carter. And because I was working with him, I got to go to all of these really cool events and meet a lot of people who I had no business talking to, really. I met one of his classmates, former astronaut Kay Heyer, and she was telling me about one of her shuttle missions where they were building the early space station. And I said, you know, that sounds a lot like a submarine in space. She looked at me and she was like, it totally is. That's exactly what it's like. And that was sort of the lightning strike moment. As a kid, I knew about astronauts. I watched shuttle launches on TV. I knew we were in space, but never seemed like something that I could do. But I had really good mentorship at that time. You know, I shared that dream with my boss, Admiral Carter. He turned to me and he said, Kayla, do you know how you become an astronaut? You apply. And for me, that was the perfect mentorship I needed in that moment. I'm somebody who thinks really hard about everything I do, all the details. And he said, you know, it's actually pretty simple. You just got to put yourself out there and you never know what's going to happen. So I did apply and it ended up working out. Here I am.
You're one of my favorite people.
For me, every time I have an NBL run or every time I do a practice spacewalk and you get in that suit, like we call it the EMU, and feel the gloves go on, feel the pressure build, feel the fans start to flow and the air start to come over the back of your head, and you realize, like, this is it. That's when it really strikes me that this is actually not a dream. This is actually happening.
I'm Raja Chari. I go by Grinder. I grew up in Iowa, and I went to the Air Force Academy and then MIT, and then I was an Air Force test pilot.
If I ask my mom, she definitely has memories of me as a child talking about being an astronaut. Well, I always knew I wanted to do something related to aviation, but at the same time, I think I also started telling myself it wasn't really possible because it was just something to get let down from. Every phase of my life I had doubt, whether it was at the Air Force Academy and wondering whether I could survive basic training, whether it was when I was at MIT, or even pilot training, failing check rides, and thinking, again, maybe I'm on the wrong path. But I think in all those events, I've been blessed to have a supportive family, supportive spouse, supportive mentors and leaders who helped me at the time realize, like, hey, these are setbacks, and you get better by tackling those head on. For the Artemis mission, they're not just PowerPoint slides. They're actually metals being bent, shaped, formed to build the things that we're going to use. And as a test pilot background, this is a dream job to actually be involved in all of this. Now looking back, I would have told myself, hey, just pause and appreciate what's actually happening around you and the magic of the moment that you're in. Newton talks about, standing on the shoulders of giants. Now, I'm definitely not a giant, but if I can throw a little stepping stone out there, that would be my goal. My name is Raja Chari.
Very good. I like it. Go ahead.
Oh, what am I doing? We're videotaping this?
Everything you're doing.
Ladies and gentlemen, our newest astronaut, Matthew Dominic.
I think if you boil it down to it, I'm a father, a husband, and an explorer. For my whole life, I've always wanted to explore further. I didn't exactly know where I was going to go at any one time, but I always knew I wanted to go further or faster or higher. I remember as a kid going to air shows with my dad and just looking at airplanes, and I wanted to understand it, and so it was just drawn to it. Every air show I went to, I wanted to go get in that airplane.
I grew up in Wheat Ridge, Colorado. I went to the University of San Diego for electrical engineering and went to Naval Postgraduate School as well, naval test pilot.
It's certainly a sacrifice for family and friends. Being in the military, we would go on deployments and lose contact with them, and they understood the risk that we were taking. You think about the immense responsibility put on you at times. You don't want to let the world down, but it's about pushing humanity forward and keeping America safe. Watching rockets launch, right? I mean, watching shuttle launches as a kid was an enabler for me. It's like, how do I become a part of that? How do I join that team to go do that?
Godspeed to the class of 2017.
You find out you're getting this job, and that's huge. But really, that first time that you go put your hands into the gloves is just a very interesting moment. It's a pinch me moment. And you realize that this is real. This is going to happen. We're going. My previous job was to keep the world from going backwards. This job is about getting the world to go forwards.
Pojo brings a lot of energy to our team, and he is always definitely 100% in anything he does.
NASA astronaut Matthew Dominic.
My earliest idea of who I wanted to be growing up was my father. My father was a police officer, and so I wanted to be a police officer. And then I saw a shuttle launch on television, and I thought, I really want to drive one of those. And yes, I said drive because I didn't know any pilots or engineers even for that matter. I'm a public servant, and I have been for 22 years, since January of 1998. And so I ask myself, have I done all that I can for my country and for my family? I have fantasized about stepping on the moon. It's my dream. My dream is to work on the surface of the moon. And being able to launch humans from American soil is a very big part of that. I was sitting at my desk in the Russell Senate office building, and I got a phone call from a Houston phone number, and by the time I answered, I missed it. And so I called back, and after a lot of waiting and being transferred, I was transferred to Janet Kavandi, who was the chair of our board, and she asked me if I wanted to come to Houston and commence training. And I actually pinched myself several times walking back to my office. There is no way that this is a real thing. I'm going to wake up and be so disappointed. When I woke up the next day, and I actually had an email from Janet saying it was not a dream. That was actually unreal.
He's a lieutenant commander in the United States Navy, where he flew F-18s. He came to us from Washington, D.C., where he was serving as the United States Navy Legislative Fellow in the United States Senate. Victor?
Being selected for this job, you can't help but to think of, I've got so many friends that I know could do this job well. And that feeling of, wow, why didn't they get it? And, feeling like you're not really good enough cut out for the job. And I felt all of those things. Being a father, a husband, all of those things come with doubt. And I think you have to learn to get comfortable with the doubt. They call things moonshots when people accomplish something amazing. No matter how good a story you tell, people are captivated by real-world accomplishment. It's our generation's opportunity to have our own literal moonshot, and then to continue inspiring future generations to reach for the moon.
They not only have the right stuff, they represent the full tapestry of American diversity. Their journey begins now, and the nation will be right beside them, reaching for the stars.
I actually thought that I was not experienced enough, didn't have the credentials I needed to actually become an astronaut.
The reason I'd want to go to space with Woody isn't just because he's brilliant, which he is, but it's because he carries his brilliance in such a way that you don't feel like you're an idiot when you're around him.
It's funny, all the little decisions in life that get you to where you're going. My earliest memories, I remember building little toys out of wood. Over time, got to building like 21-foot tall rockets, and one of those is still up at my parents' place, stored in their barn. I remember agonizing over what my major should be, and finally I sort of threw up my hands and said, I really like airplanes and things that fly, so I'll do aerospace engineering. One of the best decisions of my life was taking summers away from grad school to work search and rescue in Yosemite. One of my favorite parts of the job was getting thrown into situations where I wasn't quite sure what to do. The confidence I gained from that was that I can deal with the unexpected and adapt and overcome.
The other great thing about Woody is he applies that brilliance across all phases of his life, whether it's in the outdoors, where he basically saved half our class from getting severe hypothermia like it was no big deal. And then on his very first space station sim, nonchalantly directed the whole team through an emergency response like he'd done it 100 times.
I've always had a slight tension in me between sort of the engineer, analytical, problem-solving part of me and this sort of operational side of me that wanted to be out experiencing the world with my hands. I feel really lucky to be here now where I have an opportunity to do operational things, but also solve really hard technical problems. When we go do hard things and challenge ourselves in that way, we will learn new things that will benefit us.
Ladies and gentlemen, our next newest astronaut, Woody Hoberg.
I'm an engineer, I'm a pilot, I'm a climber, and I'm now an NASA astronaut.
Ladies and gentlemen, the newest NASA astronaut, Jonathan Kim.
You're a Navy SEAL with a degree from Harvard Medical School.
Dr. Jonathan Kim.
That's just ridiculous.
Exploration is written in our human DNA. When I realized that being an astronaut is really the opportunity to expand our understanding of the cosmos, to make our world a better place, all while inspiring the next generation of children.
You, Julian.
The same children that didn't have the confidence to dream like I did. That was when I realized that I absolutely wanted to be an astronaut. Like a lot of immigrant families, my parents moved to America with the hope of the American dream, that their children can have a better opportunity in this world. I had a hard time growing up as a kid. I lacked a lot of things, but the biggest thing I lacked was confidence. I wake up every day and I think about the opportunities I've had. It's hard for me to believe that I'm that same person.
No, you just beam, right? You spend so much effort and hope, and then you try to give whatever the student needs to grow and get where they want to be. And then when you see that they get there, it's just thrilling.
It makes me immensely proud to be part of an organization to achieve such a monumental challenge like returning to the moon. And that's what really excites me when I think of Artemis. The lives that we're going to positively impact on this endeavor. It's hard to articulate all of those emotions, but it's, wow. I am an astronaut, and I have this amazing opportunity to serve my country and humanity.
To me, he is service above self. I would trust my life to him, and I'm very proud to call him my friend.
Today's spaceflight will be the very first for NASA's Christina Cook.
We have to answer humanity's call to explore. We have to set ourselves as the leadership in proactively seeking out challenges and learning that when we focus on one thing and we focus on it together, we can achieve anything. I am someone who has loved exploration on the frontiers since I was little. I used to be inspired by the night sky, and throughout my career, it's been this balance between engineering for space science missions and doing science in really remote places all over the world. I loved things that made me feel small, things that made me ponder the size of the universe, my place in it, and everything that was out there to explore. And I put that stuff to work making science gadgets for NASA space science missions and working really hard in that career, but also setting goals in hobbies that I had. I learned to rock climb, I learned to sail, finally learning surfing at this point in my life. And so I think working hard on all fronts to be a better person and to contribute the most to the world is really what's important to me. I really don't remember a time when I didn't want to be an astronaut. For me, I learned that if I was going to be an astronaut, it was because my passions turned me into someone that could contribute the most as someone contributing to human spaceflight. So I didn't necessarily live my life according to checkboxes of how you can become an astronaut, but I followed those passions, and one year looked at who I had become and the skills I had gathered, and I asked, could I sit across from a table and present myself as someone who could do this well? And I thought, I'm going to give it a shot. You know, there was a moment where it came to me that this was the most exquisite personal and professional moment of my life, a moment of career culmination where everything I had learned personally, professionally, every skill I had been taught, every hero I had emulated, it was all coming together in this moment. And I realized that I wanted my work to tell every single person on Earth that they could have that moment too if they worked hard for it. And I wanted every single person on Earth to feel that same feeling.
I've had that dream of becoming an astronaut for as long as I can remember.
Next, the U.S. astronaut Kjell Lindgren
the 217th visitor to the International Space Station.
What a privilege to have had that experience, to live and work on the International Space Station. When you go out of the airlock and you start moving around on the outside of the space station, looking through that plastic visor at that scene that occupies your entire field of view, to see the Earth spinning quickly below is breathtaking. It was really watching the Space Shuttle Columbia launch in 1981. And that's really when I had that eureka moment that people actually do this. People go into space, and maybe that's something that I could pursue. I was accepted into the Air Force Academy, and it was there that I actually discovered a passion for biology, and specifically the effects of weightlessness on the human body. But I remember very clearly going into Denver one night and unfortunately seeing a young woman get hit by a car right in front of me while I was on the sidewalk. And I felt like, you know what, I've been studying biology, but I want to know more. I want to know what I would need to do to actually help this person. And so my path shifted a little bit, and I ended up going to medical school. I had the great fortune to be hired on as a flight surgeon, a physician that takes care of the astronauts, the crew. And then an astronaut selection was announced, and I threw my hat in the ring and had the great privilege of being selected into the 2009 astronaut class. We go to the moon because it means further building that bridge of knowledge that is required to get to Mars, and an expansion of humanity in the solar system. I'm grateful to be a part of this team. You know, getting to do this job is not an individual accomplishment. It represents effort and work of folks that have been walking alongside me, my family, classmates, colleagues, teachers, mentors, coaches. I am grateful for their investment of time and energy in helping me to achieve this goal.
I definitely have heroes. My first heroes would be my parents. They've taught me perseverance and discipline. They gave me that foundation I needed as a young woman to then move forward and achieve my dreams later on in life. I was fortunate enough to get accepted to the United States Naval Academy. It was the summer before my senior year at the Academy that I got a ride in an F-18. And that's the first time that I realized I can be a Marine and be a fighter pilot at the same time. This is the best of both worlds, count me in. And so I was selected to go to test pilot school. And it was during that time that I started looking at what are my future options going to be in the Marine Corps? What do I really want to do?
NASA says it's accepting applications for new astronauts.
Of the roughly 3,500 applicants NASA is expecting, only about 15 will be selected for training.
And I thought to myself, well, that's crazy. There's no way that I would ever be accepted to become an astronaut. And I went home and I spoke with my husband about it. And he looked at me like I was crazy. And he said, why would you ever pass up such an incredible opportunity? If you never apply, you're never going to know if you could make it or if you could have made it. That really changed my perspective on life. So I applied to become an astronaut. And I was very fortunate enough to be selected in the class of 2013.
I'm thrilled to be joining the NASA team and looking forward to the next 2 years of training. Thank you.
And we've been training ever since, preparing to support current missions on board the International Space Station. And now we're preparing for the Artemis mission.
Just as the United States was the first nation to reach the moon in the 20th century, so too will we be the first nation to return astronauts to the moon in the 21st century.
Artemis and our mission to the moon is no longer some far-fetched dream or some science fiction idea. This is reality. We are going. What we're going to learn on the moon goes beyond space exploration. It benefits humans on Earth. It gives enthusiasm to our younger generation to go after their dreams and to help be a part of this evolution of our human race.
I think, if anything, I probably am a little bit of an impractical dreamer.
You know, be really unrealistic about your dreams, just be really realistic about your path. When I was a little girl growing up in Spokane, Washington, becoming an astronaut, like nobody did that. There was nobody that I could look to and say, that person walked the path that I'm about to go walk. The first step I took out of Spokane was to go to West Point. That was a huge leap out of my comfort zone. As I was flying across the country for the first time ever going to New York City, I remember thinking, like, if I had the opportunity to get off this plane and not do this, I probably would have taken it. But you push through that. I remember sitting on the airplane and flying down to NASA for an astronaut interview, and I had the exact same feeling as when I was flying to West Point as an 18-year-old kid, and it was like, maybe this is where I've reached too far, maybe this is where I've pushed too far, and this is where it all ends. What little girls from Spokane, Washington grow up to be an astronaut? I'm just not even going to try. And so when I say I'm an impractical dreamer, I mean, I never listened to that part of me that says, hey, you're probably not going to succeed at this. I always listened to the part that said, well, somebody's going to. Maybe it's going to be you.
We have liftoff of Anne McClain blasting through the Kazakh sky to the International Space Station.
You know, I've always been so focused on my goals, and I've always just sprinted toward those goals. And when I look back at all the achievements aren't actually what I remember, it's the people that I did them with. The person that wins the rugby match is the one that, despite all of those hits, despite all of the contact, actually thinks 10 steps ahead, thinks 5 steps ahead as a team, and it's a strategy game. Now, working here as an astronaut, one of the toughest things that we do are spacewalks. You have got to stay so mentally tuned in. You have to know that you can push your body further than you think you can. And I'm holding on to a handrail on the International Space Station, and I'm looking out at the vastness of space, and I looked back and I felt like this was my planet. I was attached to it through gravity, and I felt a closeness to the Earth, and I also realized how much more we have to explore. We haven't even started yet. Our destiny is always to go and see what's further and what's next.
I first started saying I wanted to be an astronaut when I was 5 years old. We were asked to draw a picture of what we wanted to be when we grew up, and I distinctly remember drawing an astronaut in a spacesuit standing on the surface of the moon next to the American flag. People always associated space with me. They called me Space Girl. They knew that it was this ultimate passion that I had and this goal.
In this historic moment, first time that 2 women have done a spacewalk together.
I wrote this in my high school yearbook. Under future plans, I said to go for a spacewalk. Never forget that moment coming out the hatch and looking down and seeing just my boots and the earth below. And it was such a spectacular and beautiful sight.
I probably didn't have the most traditional path of becoming an astronaut. It was biology and understanding more about animals that really drove me. And so that's what I pursued. I'm always telling people everybody should be scuba divers. There's this whole world underwater that most people don't get to experience. And for me, being in space shares a lot of the similarities of that underwater world. You're traveling around and moving in a different realm. You have to trust in your hardware, trust in your equipment, and trust in all the people that have helped you get where you are. In my experience as a scientist diving underwater or working as an astronaut in space, you're challenged both mentally and physically at the same time. And I think those are the times when I've really felt the most content in my life.
The thing is, it just keeps getting better and better. From the moment I arrived on the space station, I've had a huge smile on my face.
Following your heart and following the things that you're passionate about, you can still achieve your dreams and your goals, and that's exactly what happened for me. I think I've always looked up at the moon and thought about what it would be like to be there. We're going to the moon to explore, and we're going to the moon for scientific discovery. I don't look at this as my own accomplishment or something just for me. This is our mission. This is everybody's mission. Our entire planet's really. I'm NASA astronaut Jessica Meir.
I still wake up every morning and it feels like a pinch me moment
to think that I'm actually an astronaut right now. I am Jasmine Mogbelli. I think as a kid, I believed I could do anything. So to me, I was going to be in the NBA, I was going to be an astronaut, and I was going to be an Olympic skier. So to me, it didn't faze me. I've been very lucky to be surrounded by people that have always supported me. My husband, my parents, they 100% have supported me.
Jasmine Mogbelli.
As I started to overcome more challenges through my life, I realized, yeah, I could possibly really do this. I think it's 100% natural to have doubt. What's important is how you respond to that doubt, and just let that be your driver to work harder and figure out a different way to do things. I think there are a lot of reasons for going to the moon. Our curiosity. Who in the world doesn't stare up at the moon and just wonder, while we've been there before, we've only explored a limited region of it. And so getting to learn more about the moon, I think not only can teach us more about Earth and our own planet, but also can set us up for going further and going to Mars. And when you talk about the way we want to go to the moon for Artemis, one, going to the lunar South Pole, just landing on that South Pole with the lighting conditions. They're permanently shadowed regions, so we can't use solar energy necessarily. What resources are on the moon that we can use? How much of them are there? How can we use a base from the moon to go further? Anything that might jeopardize the mission, whether I'm on it or not, those are the things that kind of keep me up when I lay down at night, and those are the things that I think about. It's a deep question. Who am I? Well, I'm a wife now. I'm a daughter, my parents' favorite child, probably. I'm a Marine, and I'm an astronaut.
People ask you when you're a kid, hey, what do you want to be when you grow up? And I said, I want to be an astronaut, a biologist, and a geologist. So, when you're 5, this seems totally reasonable. Studying microbiology on station is very similar to the Earth, except for you're floating. You may be doing the same experiment, but you're conducting it on the ceiling because that's a convenient place to work. We're studying things like sequencing DNA, what happens to the human body in space, and even viruses are an issue in space. I get really excited about things, and something about viruses, about biology, I'm totally fascinated by it, and I want to get up and go work on this every day.
Became the first person to sequence DNA in space. With the addition of NASA astronaut Kate Rubins, these 3 are about to begin the first planned 2-orbit flight to the International Space Station with humans on board.
Space is both a place that is like this far off, almost fantastical thing that you think about and people dream about. But then on the other hand, to me, it's a home. I've been there. I've lived there for 6 months. I have friends there. I'm looking forward to going back there like you would look forward to visiting an old apartment. The moon is an incredible destination. We have been there, but we were there for such a brief period of time. Apollo, it united the world. And so to think, when we're having dark times, to think of the fact that we might have people on the planet able to look up and know that there's humans on the moon and that we've done this as a joint international collaboration. I can't even describe what kinds of the benefits that might be, both for our partnerships in the world and just for joy and inspiration in people's everyday lives.
Less than 10 minutes away from today's launch, this is Kate Rubins celebrating her birthday with a launch to the International Space Station.
I think if I was going to talk to my younger self, I would say, don't be so stressed out about what you're doing at the moment, because it's such an honor to be a scientist and to be an astronaut. Just enjoy what you're doing every day.
You know, I'm a product of a lot of sacrifices and great teams. I'm a son of a teenage single mom. You know, it was never an option to feel sorry for ourselves or to use that as a crutch. It was just, hey, you can do better, you can get ahead by working hard, studying hard. And so that kind of set a really good foundation of hard work equals results.
Good morning, Frank Rubio from Miami, Florida. Graduated from West Point, 98, Go Army, Black Hawk pilot, and then a family medicine physician.
The Army has essentially shaped me. I mean, it's given me all these amazing opportunities. The reality is I've just always been surrounded by people that are next level. Being around those type of people my entire career, I think has pushed me to do better and also kept me humbled. When Vice President Pence was announcing our class, he made an analogy to a turtle on a fence post, basically meaning that, hey, you didn't get there on your own. He was talking, of course, about our families, our loved ones, our co-workers, our teams, essentially, that allowed us to succeed and get to that point in our lives.
Frank is truly a wonderful person. He is a great American, an even better human being, and he's going to make an awesome astronaut. And I really look forward and hope I get the chance to go to space with him one day.
What the moon will allow us to do is to explore further than we ever have before. Anytime we've explored in the history of mankind, there's great benefits from a technological point of view. But I think deeper than that, there's a sense of pride and unity that comes with accomplishing incredibly hard things. And right now, probably more than ever as a nation and as a world, we need that. Watching how America comes together in those moments, in those bigger than life moments, is something that's really incredible to behold.
Right now, an American astronaut, a Japanese astronaut, and a Russian cosmonaut are strapped inside of a Soyuz spacecraft.
There's always the, why did you climb the mountain? Because it's there. We all travel down the street, we look out the window, we're in the backyard. There are moons out there. You can't miss it. It's beautiful. It's there every day. Why would we not want to go there? We need to go there.
1 minute, 10 seconds away from liftoff.
I was in junior high. The teacher asked, what do you want to be when you grow up? And everyone was saying, I want to be a plumber, I want to be an architect, I want to be an accountant. And I said, I want to be an astronaut. And literally everyone in the class laughed. But then the teacher looked at me and said, right on.
And liftoff. Scott Tingle, Anton Shkaplerov, and Norishiki Kanai on their way to the International Space Station.
Look, this is evolution. We didn't always have the technology and the capability that we have today. We didn't always have automobiles. We weren't always able to just jump in a vehicle and travel for 16 hours and get to the other side of the country. So this is the next step in evolution, to be able to take systems and hone our processes and get our operations down so that we can set up camp on a place that's different from Earth so that we can conduct science that'll better humankind. This was just a dream when I first met my wife. You know, was it going to happen? Was it not going to happen? Who knows? But we're here and we're doing it. And every step we take is both a challenge and a reward. And to be able to live that life and look back at the track that we used to get here is just amazing. Life is pretty busy when you have lofty goals and you're constantly focused, you're constantly working to get positive results. But that moment for me was coming out of the Soyuz on my first space flight and standing on the ground for the first time in 6 months and realizing that I did it.
A dream feels like a big, faraway goal that's going to be difficult to achieve and something that you might achieve much later in life. But in reality, what a dream is, or a dream realized is just putting one foot in front of the other on a daily basis.
And if you put enough of those footprints together, eventually they become a path towards your dreams. My name is Jessica Watkins, and my fellow astronauts would describe me as a rock nerd, endearingly, as what I tell myself at least. One of the things that I enjoy the most about geology intellectually is you kind of function as a detective. You're looking at different puzzle pieces, all kind of in different places, and you're trying to bring those puzzle pieces together to get a full story, a full history of what has happened in a particular place. For me, as somebody who was really interested in the planets, geology provided a means for me to study the surface of another planet, and particularly look at Mars, which was my passion, was just super exciting to me. In college, I was lucky enough to get the opportunity to learn to play rugby. It was one of the best opportunities in my life, getting to play with the rugby team at Stanford and play in national championships and even win one. I think one of the biggest lessons that I take away from my rugby career is the importance of teamwork. Rugby in particular has positions that are all suited to different types of body types, different strengths that people bring to the table. And I think that is not unlike our team here at NASA, where everybody comes and brings their different strengths, their different expertise to form a powerful and winning team. This endeavor to go to the moon is going to be hard. It is not something that we can do individually. It's not something that we can do on our own. And I think especially in these times, it's really important for us to recognize how much we need each other and the importance of coming together for one goal. And I think that going back to the moon really embodies that.
This is Mission Control Houston. We are now processing telemetry from the Orion spacecraft.
Mission Specialist number 3, Stephanie Wilson.
Making her first flight into space. She'll sit in that seat right between and behind the pilot commander.
NTD, MS3, contact.
MS3, this is NTD. I've got you loud and clear. Good morning, Stephanie.
Go for maintain start.
Every space flight is special. The first space flight is very memorable for everyone. On the day of launch, everyone's very excited. And it's very surreal when the solid rocket boosters and the main engines ignite. It's very apparent that we're going somewhere, and it's the best 8.5-minute ride ever. The view from space is spectacular. It can be very peaceful, very serene. The colors are so vivid. The vibrant orange of the Sahara Desert, the blue-green color of the oceans. It's a wonderful sight to behold. And what is readily transparent is that while there may or may not be strife on Earth, it appears to us to be one unified planet. And having that perspective of one Earth and one humanity is one that we definitely appreciate having from space. I had a great curiosity for what's unknown, and I like to solve problems. So trying to understand and have a better sense of the universe and what that means to humanity, who we are, what our history is, and how we leverage that knowledge to bring benefits to humanity was something that struck me and I hope to work with in the future. I have certainly benefited by having some great mentors in the office across NASA. One thing that veterans of space flights do is they share their expertise and their experience during the mission.
Christina on the UIA, check oxygen EM1 and 2. Oxygen EM1 and 2 are open.
And I do my best to pass along the experience and the knowledge that I have gained to others in the office and with the next generation so that we can have a better future for all of humanity.
At NASA, we have always answered the innate call to go.
With Artemis,
We are going to stay.
Proving that humanity
Can live on the moon
Mars,
and other worlds.
and share the wonders of the solar system with all.
Our story is one of people.
All those who make this journey possible.
From advocates across communities
To companies across industries,
To countries around the world.
We achieve this collective endeavor.
our efforts create impact for all.
Technologies that revolutionize industries.
And jobs that bring prosperity to people.
The discoveries from space
benefit the way we live on Earth today.
and those from the moon
Will create a better future.
for generations to come. But to do that,
We must go.
hi, I'm Chell Lindgren.
My name is Raja Chari.
Kayla Barron. Kate Rubens. Hi, I'm Christina Cook.
NASA astronaut Joe Acaba.
Jessica Amir,
Woody Hoberg.
Anne McClain.
Stephanie Wilson,
My name is Johnny Kim.
Nicole Mann.
Victor Glover.
Jessica Watkins.
Hi, I'm Matthew Dominic.
Jasmine Mobilli.
Frank Rubio.
Scott Tingle.
this is what we do.
this is what we will do.
Let's go.
we go to the moon to learn how to live on other planets.
For the benefit of all.
And welcome to the Apollo 5 Center here at NASA's Kennedy Space Center in Florida. Thank you so much for joining us. As you just saw in that video, the 18 astronauts from NASA that were named to the Artemis team is set. And we have 5 of them here with us today who are serving as ambassadors for that team. We appreciate you all being here with us for a conversation about what Artemis means, to get some reaction on you being named to that team, as well as take some questions from our media here. Of course, Vice President Mike Pence just announced the 18 astronauts on the Artemis team. The mission is to land the first woman and the next man on the moon, and then to learn to live and work on another world for the benefit of our world, as well as going on to Mars. I want to introduce the astronauts we have the pleasure of talking to today, and begin with Jessica Meir, NASA astronaut. We have Joe Acaba. We have Jessica Watkins. Matthew Dominic. And Anne McClain. Very good. We're going to start with you, Jessica, and a pretty big day today. Let's talk a little bit about your background. You are a doctorate in, you have a doctorate in marine biology. You're a veteran astronaut. You made history when you did the first 3 all-women spacewalks with Christina Cook. Your mom says you knew you were going to be an astronaut when you were 5 years old, but you were sharing with me that you had a memory of when you first realized you wanted to be an astronaut. Well, when was that?
Yeah, that's right. My mom tells me the story that I started saying it when I was 5 years old, but I don't know if you remember everything you said when you were 5. I certainly don't. My first distinct memory of it was when I was in the 1st grade. Our teacher asked us to draw a picture of what we wanted to be when we grew up, and I drew that kind of iconic image of the Apollo era of an astronaut in a spacesuit standing on the surface of the moon next to the American flag. So that was what I said really from that moment. I never changed that line of what I wanted to do.
That's incredible to think about you making that drawing, and now here you are on the Artemis team.
Yes, thank you so much. It is really incredibly exciting, of course, to be part of this exceptional team. You saw all of these faces, and I know that everybody in the astronaut office and all of our international partners are so ready to support this next chapter of human spaceflight.
And what are you looking most forward to in this mission?
For me, the Artemis mission is important for 3 main reasons. First of all, for exploration. I truly believe it is an innate characteristic of the human species to explore. Secondly, an easy one for me as a scientist, for science. If you look at the scientific experiments that were conducted on the Apollo missions, they changed the way that we see our solar system. And we are still, to this day, learning from those very samples using newer technologies all the time. But there is so much yet to discover. I'm sure our colleague Jessica Watkins can tell you a lot more about the exciting geological opportunities that remain for us to uncover on the moon, that we will uncover, as science is a very critical component of the Artemis missions. And lastly, if you think again to those Apollo missions, they had a profound impact on many other aspects of our culture and society, stimulating participation and interest and growth of all of the STEM fields, science, technology, engineering, math, and of course, those had ramifications far beyond that of exploration that our society still benefits from today. I am certain that Artemis will continue to have all of those same effects.
We appreciate your confidence, too, as you get started with this team. I want to move on to Joe Acaba, a former math and science teacher, a veteran astronaut with 10 months in space of experience. But you also taught at Melbourne High School, just an hour down the road from right here at the Kennedy Space Center, and Denellen as well. So I want to start by asking you, yes, you were here, of course, when you launched on the space shuttle, but what's it like to be back here as a teacher in an area where you taught kids, as well as launched into space?
Yeah, it's great to be back here at the Kennedy Space Center out here in Florida. You know, being part of the shuttle program was amazing and quite the honor to have. I was here last month as part of the Commercial Crew Program supporting Crew 1 that just launched, so lots of history, but a lot coming up in the future. But to be an educator and be back here today where I taught, you know, down the road, I hope some of my students are watching today. My hair's a little bit shorter than it used to be when I taught.
You had some long hair.
I had some long hair. It's hard times being a school teacher. I hope they're watching. I know they were very excited when I applied to become an astronaut and when I finally got selected. But I hope that there's a new generation of students that are watching this today, and they're excited. You know, Jessica, you could hear her excitement and how she felt when she was 5 years old. I didn't think that when I was 5 years old, and I thought I found my profession being a school teacher, but here I am today. So it's cool to be here. The history is awesome, but we're all here to look towards the future.
And you speak very highly of teachers who choose that profession. I wonder, you mentioned the students, they are still in contact with you?
Yeah, so I do have some students now that, you know, they email me. I'm sure after this announcement, my name will be out there and they'll probably shoot me a line. So it's cool to hear from them, to share what I'm doing, but really to hear about what they're doing. And you know, there's no greater profession than being a school teacher, and it's that impact that we have as educators that just go on and on. So it's cool.
And that's fantastic. And as a teacher, have you thought about how you will share Artemis with everyone?
Boy, there's a lot of ways to do that. The program itself is exciting. You know, there is no kid out there, all of us here, that have not looked up into the sky and wondered, what would it be like to go up there and walk on that thing? And so what I want to do as an educator is to, you know, inspire those students that this is a possibility, but we're going to the moon to get to Mars. And it's those students that we're going to talk to that are going to get us there as engineers and astronauts.
And it's incredible. You talk about everyone looking up at the moon and wondering what it's like. I did as a kid as well. So we will be looking up at you and certainly rooting you all on. I want to move now to Jessica Watkins. Welcome. I understand you have some family here, locally in the area.
I do. That's correct. Yes, I have some family that lives in the Orlando area. And a few weeks back, a couple months actually, I was able to tie in with them. They came out to, my aunt is an educator, just like Joe, and she was able to bring her class, a lot of her school actually, come do a field trip out here at KSC. And I was able to tie in and say hello to them, so that was really excellent.
That's pretty neat. Let's talk a little bit about your resume. You're a geologist, as was mentioned. You study landslides on Earth and Mars. You're an aquanaut and a member of the science team for the Mars Curiosity rover. You also, I thought this was interesting, won a national championship with the Stanford women's Division I rugby team, which is pretty impressive, no?
That's correct. I was definitely privileged to be a part of that team and get to experience that win with them as well. Being part of a rugby team, as Ann McLean can attest to as well as a rugby player as well. There are a lot of similarities to a rugby team as to this Artemis team and the whole NASA team overall. On a rugby team, you have people with very varied skill sets. You have people who are smaller, people who are larger, or people who are stronger. People bring different strengths to the table. And I think that's true both of this Artemis team and NASA as well. And all of those strengths come together to really build a productive and winning team.
And I think one of your strengths is speed. I was looking at one of the wonderfully produced videos that are done on you, and there's this great clip of you scoring a try. Two defenders are coming to get you, and they're running in the same direction, and you split them on the way to score. But it's not so much that you split them, but you blew by them, and they were running in the same direction you did.
Yes. Well, so of all those skill sets, the only one that I have is speed, so I have to use it wisely.
It was wonderful watching that score. Let's talk a little bit about the mysteries of the moon, because you talk often about how geology helps us understand the history of what happened. What are you looking forward to in terms of solving the mysteries of the moon?
Absolutely. I'm happy that you asked that question. Certainly the moon, we have a lot that we can learn from the moon as well as learn about the moon. In terms of understanding the history of the moon itself, one of the big questions in the polar regions is looking at lunar volatiles. So understanding how those volatiles formed, where they are, their distribution and extent, which will also help us in the future as we start to look for a site to build our moon base and continue into the future. The moon also allows us to look at planetary processes, particularly looking at impact cratering, which is a process that we see on multiple bodies, rocky bodies in the solar system, and helps us understand ages within the solar system. The moon will also help us understand more about the Earth. For one, the moon-Earth system and the origin of the moon helps us understand more about Earth and how we can apply some of that knowledge to what we know about the Earth. And lastly, the moon can also function as a platform where we can start to explore the sun and astrophysics, start to observe the universe from a different vantage point and learn so much more.
And we need resources on the moon as well, right, if we're going to sustain a presence there, which is very key.
Absolutely.
Jessica, thank you so much. And now, Mr. Matthew Dominic, U.S. Navy test pilot and fighter pilot. You flew 61 combat missions. You're a double-E, electrical engineer. And interestingly, you were kidnapped aboard an aircraft carrier where your fellow airman or seaman rather shaved a stripe right through the top of your head. Right? Held you down?
That's correct. I'd be lying if I say I didn't deserve it. I had played a practical joke on them, and they got me back.
Well, I can only imagine what that looked like.
I had to finish the job and get rid of the rest of the hair, yeah.
Went full cue ball, shaved it all off. Well, that sounded like that was the right choice. In talking about, as we stand here, and this mission, the Artemis mission, we look at this great vehicle, the Saturn V rocket. I know you're a tinkerer, and you love to take things apart, understand how they work. When you look at this machine, what are your thoughts? What do you think about when you see something this impressive that made history here in America?
I mean, I've been struggling to listen and to see here as we stand in this room, the Saturn V building, and look at all the incredible hardware. And it's a thing of dreams, right? It's a thing, it instantly takes you to a childhood dream. You look and you imagine every bolt and every valve and every fuel line that runs to this hardware, or the quarter-scale Orion, or the SLS on the mobile launcher over there, and think about the people in the team in America coming together and our national partners coming together to make that work, right? You could imagine being the engineer waking up in the middle of the night and thinking, well, maybe I should change this to make the design a little bit better because there's a few really lucky pink bodies, 150 feet that way who are going to ride this thing, and you don't want to let the world down. right? You don't want to ever let the world down. There's an immense weight on your shoulders. So as I look around, I see the hardware. I imagine walking out to the launch pad in a dream, and you go up that elevator, and the building is creaking in the wind, and the wind is rustling through as you come out the door. Like the gas, the rocket has just been fueled, and it's creaking with the new stress and the new loads. Those are the things I think about when I look at this hardware. I instantly enter a dream world. This is the thing of dreams. Right. I'm incredibly lucky to be here.
I feel like you just took me there in the way that you described it. That's outstanding. I know that you've been involved. We were talking about your background and how you're applying it now as an astronaut, the interface between human and electronics. And so you've already been working with the team that's building Orion. Tell me a little bit about that.
In the Navy, I worked in, my specialty was human-machine interface, right? And it's been really incredible to have worked in the Navy, training and working and redesigning flight control laws to land on an aircraft carrier and revolutionizing how we did that. And now those same techniques, the same principles, as we sit down with all of the vendors, as we look at the human landing system to get ready to go back to the moon, having the same theoretical conversations with them about the human-machine interface necessary to go and do the task of landing on the moon. Like, you wake up every morning and you feel this immense burden for society and humanity that I need to do this well today. I am the one, a bunch of us, all of the astronauts in the Corps, all of the people at all the centers are in the arena trying to make this happen for humanity. And so it's incredible to see those just be working with the hardware and making the decisions in the room. And maybe it's COVID and maybe you're walking out of a Teams meeting, right? A video chat. And you realize, whoa, we just talked about landing on the moon today and how we're going to make it happen. So it's very easy to be motivated to come to work.
And it's interesting, you talk about the responsibility. I mean, there's inherent risk, obviously, with being an astronaut. That's always brought down by NASA in the best way that we can. But you were telling me that you don't think about that. You think about the responsibility that you have.
I think if you had to choose between two fears, what I'm more afraid of, dying on a rocket or letting down all of the people that worked so hard to make this happen, all of the international partners that came together, that toiled for their careers, decades to make something happen, and you maybe didn't study a little bit more so that you know the right time to throw the switch to make it happen. I think there's an immense amount of responsibility there. I think I'm more afraid of that than of dying, right? Like, that's the fear. That's the thing that drives you when you wake up.
That sounds like the right stuff to me. Thank you, Matthew, for sharing that with us. Ann McLean, welcome, and thank you for being here. A little bit about you: West Point grad, Marshall Scholarship winner in 2002, a military instructor pilot, veteran astronaut with a call sign Animal. Tell me a little bit how you got that call sign.
Sure. Well, as Jessica said, there's a lot of different skill sets on a rugby field. Some people run fast, and some people hit hard. And
which one are you?
I was in the latter. If Jessica and I were ever on the same pitch, I couldn't catch her. I think one of the important reasons I'd like to go to the moon is a fighting chance to catch Jessica there. But
no gravity evens the field, right?
That's right.
Well, that's outstanding. I want to ask you, you talk often about overcoming your doubts as you achieved some pretty incredible things in your career so far. As you look at the Artemis program, kind of what are you sensing about the challenge that lies ahead?
Yeah, you know, I talk to people often about the doubts that's in the back of our mind, right? Because we're all human, and this is human spaceflight. And the human in human spaceflight is the most complicated part. And we all wake up in the morning. None of us wake up and go, you know what, I'm going to do 100% correct today, right? We all wake up and there's like something in the back of our mind that makes us doubt. You know, and the people that achieve and that make things happen are the ones that address the doubt, respect it, and move on, right? Bravery is not the absence of fear. It's being afraid and doing it anyway. Okay, and there's plenty of times that everybody on this stage and everybody out here was worried about something, doubted something, wondered if that was the right path for them, thought something was going to be too hard for them to achieve, and guess what they did? They did it anyway. This crew and our crew at NASA is a group of doers. We are dreamers, but even more so, we're doers. And in order to do, you got to face those fears, face those doubts, and move forward.
And that's why, you know, people look up to you and the rest of the astronauts so much when they hear things like this and knowing what you do. You were telling me earlier that one of the biggest questions you get from the public is, Jessica, or Ann, sorry, are you going to be the first woman on the moon? And I thought your response was interesting. What do you say?
Yeah, we do get asked that, and especially I think even more so now we're going to get asked that. Is it going to be you? And one of the things that I learned from the first day I stepped in the halls at NASA is the caliber of people that we work with. And so right now, what I know is that I'm either going to walk on the moon, or one of my friends is going to walk on the moon, and both of those scenarios are beyond my wildest dreams when I was a kid.
Wow, that's special to hear that. And you're also one of the few astronauts that has a Saturday Night Live skit done about you. By the way, did you think that was funny?
I was just happy she got her uniform right. As an Army officer, it's very important to me to make sure that Patch is in the right place, so I hand it to him for getting it right.
They got the details right in it, right? Well, you folks really are an inspiring bunch, and thank you so much for taking the time to have a conversation with us. We do want to get to some questions from the media who have gathered here, and we'd like to ask you to say your name and affiliation, and to whom you would like to direct the question.
Sure. Hi, thanks for taking my question. I'm Amy from space.com, and I was just, whoever wants to answer, how excited are you guys to be in the first class for this program and to maybe be the first to ride on a new rocket and a new spacecraft?
How about Jessica? There's two of them on stage,
one?
Jessica
Which one's it
Meir
gonna be?
or Jessica Watkins.
Jessica, it's all you.
Yes, I can definitely tell you that all of us here on stage, as well as the 13 others back in Houston, as well as the rest of the astronaut corps, we are all so excited to be a part of this effort. We're so excited about moving forward, taking the next step, and making this dream of going back to the moon a reality.
Awesome. And then I had a question for Jessica Meir. I'm sure that you guys are all comrades and friends and get along really well, but how special is it to share this with Christina, who you got to share your spacewalks with and your time in space?
It's really amazing. I think it kind of goes back to what Ann said earlier about the fact that we are all colleagues and we all work closely together, but we are all friends as well. When I go to work every day, I know that I'm going to see people that not only do I love to work with, but I just love to hang out with in my free time and to spend all of these things of life. As you can imagine, becoming an astronaut is full of a lot of changes in our lives for all of us. And you really have an exceptionally close bond, especially with your classmates. Christina's one of those classmates. Ann's one of my classmates. All 8 of us in that class particularly like brothers and sisters. So it is an absolute privilege and honor, and it just makes it even more special to be sharing it with those people that I know that I love so much.
Hi there, Rachel Joy with Florida Today. Jessica Watkins, you very well could be the first woman on the moon. I'm curious why you think it's important that a woman should go to the moon.
Yeah, absolutely. And I think, it's a really big honor for all of us to be here, to be part of this team, to be part of this effort, and to know that we can contribute to that first woman, that next man on the moon. I think for me, what that means is just being a part of this Artemis generation. It's something that, as we've kind of described, is something that we've all looked forward to, or hoped for, dreamed of since we were little, and for that dream to be becoming a reality, really just for the nation, that we are going back to the moon, and I think is really exciting for all of us.
And let's broaden that out to our ladies on the stage with you. Jessica Meir, you have any thoughts on that?
I think Jessica captured it quite well. I mean, we are all ready to be part of this team, and it makes sense. When we came into this, when our class started, we were 50% female, 50% male, and it was the first time that had happened, but it felt normal to us. And this is something that, of course, I get this question a lot in talking about that spacewalk that Christina and I did together. And to us, it really isn't a personal achievement for us. It is paying homage and tribute to the generations of women and other minorities that really were the boundary pushers, that truly broke those glass ceilings to let us be here today. The great thing is for us now, it just seems normal. We are all going to go together to the moon, and we're going to go as a team. And the fact that that is just a thing that's part of everything we do now shows how far we've come. And that's really thanks to those generations before us.
And does it seem normal to you as well?
It does seem normal, and part of that is, when I was up on space station, and, we never even thought about genders or races or religions or nationalities even until somebody asked us about them. And so it has actually made us reflect on the reasons. And my takeaway is that the strongest teams are the most diverse teams. I can be a little hard-headed sometimes, I know that, and I flew my mission with a Canadian doctor. He and I have very different personalities. And the thing with a group is that if everybody's agreeing, nobody's thinking. Okay? And so there were decisions that I made during my mission that my crewmate said, hey, why don't you think about this? And that saved that day, and vice versa. The second part of it is representation. We represent all walks of life in America. And every kid in America, and across the world even now, needs to look and say, if you look like me, I can do this. And it's important for us to be able to look at them and say, you have an opportunity. The doors are open. Come on after us.
And you all three are very much an inspiration to young girls around the world. Another question?
I'm going to ask another question. So Jessica and Matthew, you're both newbies, right? Haven't been to space? Yeah? Okay. So Matthew, your first time going to space is going to be direct to the moon. Is that a little intimidating? I mean, that's like no space station trip first. What do you think?
Let's go. We're going. We go. Of course it's intimidating, right? And it's like I talked about before. You just don't want to let so many people who've worked so hard on this team, right? It's going to be an international coalition that's going to go do it. You don't want to let them down, and it just makes you study harder. It makes you tougher, makes you stronger.
Okay, congratulations to all of you.
All right, we have another question.
Hey everybody, Mike from Fox 35 News in Orlando. May I ask this Jessica a question first? We hear that when we go to the moon this time, it's going to be to go there to stay. And I wonder if you've thought about sort of how long you would be willing to be there. Have you thought about what if you could go, but you couldn't come back?
Yeah, that's a good question. And I can tell you that at the end of my 205 days on the space station, I was not ready to leave. If it were up to me, I would have stayed up there, even if there weren't, a COVID-filled Earth that I was coming back to. Even despite that, 205 days wasn't long enough. So I think when we are up there doing these missions, time passes very quickly because we are in this whole novel atmosphere with so many exciting opportunities around us, so much to discover and so much to do, that for me it just flew by. I think it's going to be exactly true, probably even more so when we get all the way to the moon, that we are going to have so much to do. We're going to have so many people to not let down, as Matt mentioned, and we're going to be there and ready to stay for as long as the mission dictates. And so I think personally, I always trust in the training that we receive and on the hundreds and thousands of people that are supporting us on the ground. They're the ones that are designing the correct mission architecture, so they will design the appropriate length mission to get the most out of it for all of us back on Earth. So absolutely, I'll be ready to stay for whatever duration that dictates.
Years?
Sure, yeah. I mean, I think absolutely. If we start talking about this first mission to Mars, it would probably be a 3-year mission, the way it's looking right now. And I would be ready to do that when the team has it all designed and ready to go.
Good for you. Anne, question for you. Is it possible that you could be involved in the Artemis program and also the Mars program? You've been to station, right? So they're choosing astronauts who have been involved in shuttle and low Earth orbit at the station. Do you think about, what if I could check both boxes, the moon and Mars?
Yeah, I'm glad you mentioned that because right now at NASA we're at a really unique time where we have a lot of overlapping missions, right? And just in our astronaut office, we have 50 astronauts, almost 50 astronauts right now, and we're training on 4 different vehicles. Some people are training to test a brand new vehicle. Some people are training to fly from a vehicle overseas for a 6-month mission to the space station. Some people are designing and looking at the lunar landers. And so all of us are involved in something different. And none of us are successful if all of those aren't successful. And so we are a very busy office right now. And so right now, the Mars missions at our office on our operational level, they're not quite there yet as a direct Mars mission. Obviously, the space station is one of our proving grounds. The moon's going to be our next proving ground. And if I can stay healthy long enough, then I'd love to check that next block.
We're certainly working on the technology to this moon will be the proving ground in order to build that technology to get out to Mars. Another question.
All right. Team, congratulations. Well done. Greg Paloma, Spectrum News 13, right here on Florida Space Coast. My question is, back in 1969 in July, there was a gentleman who said some very famous words when he went to a certain place for the first time. And this is for anybody who would like to jump in. Again, not a rigged question, but have you thought about what you may say, whether you're the next man or the first woman to land on the moon?
No. I mean, this is just, it's a dream come true for a lot of us just to be here. For me, it'd be a little premature, but, if I happen to be that person, trust me, there'll be some thought put into that. Like Matt said, that's one thing you don't want to mess up when you have that opportunity.
And Matt, it looks like you were pondering that in your head in this very moment.
Of course, and I was racking and stacking all of the things in the priority order, and that was way at the end of the list. Not ready yet.
There's a lot of work to do.
I think if that's something that's keeping us up, a lot of things have gone right, and that's really exciting. And if we know who it's going to be, I think we're going to be ribbing them a lot and say, you better think of something good.
Yeah. And maybe I'm not going to help you.
I can imagine it, even like the inspiration coming on the journey there, right? You might have something in your mind, and you might change it along the way, just as many writers do. A follow-up question?
If there's time, I'd love to throw this at you. If you could put some words in a time capsule for people 100 years from now about what this mission is, with the Artemis mission, what would you like to say? What would you like to say to people, and not just Americans, but people across the world, and maybe people will meet eventually on other worlds? What would it be 100 years from now? What would you like to say to them?
I think I see spaceflight as it's a very long relay race, and we're all really fortunate to be able to hold the baton for a short period of time. So if in 100 years, I would almost want to ask them a question, but I think what I would just say is, I hope that for the time I held the baton, I made this a better program, I changed lives for the better, the program for the better, and that your lives are better for it.
Hard to follow that up.
Yeah. Thank you. Good luck, guys.
Yeah. Well, thank you very much to our media members. We appreciate you joining in and asking the questions. One last question, though, for you that I have. With a show of hands, who would like to be the first woman or the next man to go to the moon? There it is, all five, in honor of the Mercury 7 press conference. We appreciate seeing that. Thank you all for being here, coming to Florida, taking time out of your busy schedule to meet with us and talk with us and share your thoughts and feelings about the Artemis program. We greatly appreciate it. And if you want to learn more about these astronauts, you can do so by going online to nasa.gov/Artemis team. Again, that's nasa.gov/Artemis team. Their biographies are there, as well as some very finely produced videos about them where you can hear them in their own words. I want to thank you all for watching and remind you to keep looking up. Thanks, everyone.
T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 5, 4, 3, 2, 1.
Good afternoon and welcome to NASA's Stennis Space Center in Mississippi. We are bringing you live coverage as Artemis fires up for today's Green Run test, a major milestone on America's mission to land the first woman and the next man on the moon with the Artemis program. Good evening, I'm Lee D'Angelo, and just a little over a mile behind me is the historic B-Test complex where NASA tested rocket stages for the mighty Saturn V rocket and the space shuttle. Today, in just about 30 minutes, we will test the core stage of our new Space Launch System rocket, also known as the SLS. What you see behind me mounted into the B-2 test stand is the most powerful core stage in the world. This SLS rocket is set to make its first flight from NASA's Kennedy Space Center later this year on the Artemis 1 mission, which will send an uncrewed Orion spacecraft beyond the moon and back to Earth. We're going to learn a lot more about Artemis, SLS, the core stage, and today's test, which we call the Green Run Hot Fire. We'll also be talking with NASA Administrator Jim Bridenstine, hearing from some of those who have made this all happen and getting a unique perspective from someone who knows how it feels to ride a rocket into space, astronaut Tracy Caldwell Dyson. We also want to hear from you, and for that we have Apollonia Acker standing by to help you connect on social media. Apollonia?
Hi, I'm Apollonia Acker. I'm a social media coordinator with the communications teams here at Stennis Space Center. And today I'm bringing your comments live to NASA TV. And we're glad to have you following along on all of our social media platforms. We also invite you to follow us at NASA Artemis on Twitter. And we are live on Facebook, Instagram, LinkedIn, Beta TV, Daily Motion, and Twitch. We're going to be sharing some of your posts, so submit your questions and your posts using hashtag AskNASA. Also, we've been asking you, what would you take on a trip to the moon in celebration of today's hot fire test? And you've submitted your moon kits using hashtag NASA Moon Kit. We're going to be tracking your reaction online, and I'm just excited to see this in person. Back to you, Lee.
Thanks so much, Apollonia. And I'm so glad we get to share this event online. We might normally have hundreds of folks on hand here to see this in person. But of course, we're following COVID protocols for social distancing. Those of us who are here are looking forward to some fire and smoke and a lot of noise. I've got Alex Cagnola here with me. He's a core stage engineer who can tell us about the test. Alex, thank you so much for joining us.
Absolutely. Thank you for having me.
I want to start with the basics. What is the core stage? How does it fit into SLS?
Well, the core stage is really the powerhouse of our entire space launch system. The core stage has two propellant tanks, one of liquid hydrogen and liquid oxygen, 4 RS-25 engines, more than 18 miles of cables, all of our electronics, avionics boxes, everything we consider the brains of the rocket, and of course all the plumbing that goes into feeding our fuel to our 4 RS-25 engines.
Sounds pretty big.
Yeah, it's very big. You know, our core stage is 212 feet long. You know, the most powerful core stage ever built, so we're super excited to see it be tested today.
So we're testing today. We're not showing. This isn't a demonstration. What does a successful test look like?
Right, and that's very important to remember. You know, we'll be testing the rocket. We're still, you know, learning things about our rocket as we further test. So, you know, we might hear some test conductor audio interrupt our talk, and we'll be relaying that message to everybody. You know, we might fire a few minutes before or a few minutes after our scheduled time. You know, we're really looking to get some engineering data once we do ignite all 4 engines, and that may include, you know, moving the engines a little bit or throttling up or throttling down. You know, we're going to be testing everything we can to get all the data we need.
You're the expert. I'm glad you're here with us. I'm going to have a lot of questions for you throughout the show, so thank you again. And we're getting set to chat with NASA Administrator Jim Bridenstine about the Artemis program. But first, let's hear this message from Stennis Director Rick Gilbrecht.
Hello, I'm Rick Gilbrecht, Director of Stennis Space Center, and I wanted to welcome you to today's Green Run. I'm here at the base of the B-2 test stand where you can see the Space Launch System core stage installed in the stand. That very stage will roar to life today producing over 2 million pounds of thrust for what we hope to be a 500-second full-duration hot fire. The SLS was designed at Marshall Space Flight Center, was assembled just down the road at the Michoud Assembly Facility by Boeing, is powered by 4 Rocketdyne RS-25 engines, and today we will do our part to verify it for flight. I'm always humbled and feel blessed to lead such a talented Stennis workforce, and also to be associated with all the talented folks in the SLS program. I'm proud of them, and you should be too. The men and women of NASA, Boeing, and Aerojet Rocketdyne have worked to make this green run a reality. They've overcome many, many challenges, especially this year with COVID, with a busy hurricane season, and a lot of technical issues that they've all overcome and persevered to make today possible. Personally, for me, this will be the highlight of my 29-year NASA career. I became hooked on NASA at the ripe old age of 7 when Neil Armstrong stepped on the moon for the first time in 1969. Well, guess what? We're going to make history again today, and I'm glad you're here to share it with me. Welcome to the Artemis generation. We're Go for Green Run.
We've shown you a little bit about what we're doing today, but now let's talk about why. Joining us for that is NASA Administrator Jim Bridenstine. Jim, welcome to Mississippi.
Well, thank you, Lee. It's great to be here.
I want to start with the overall picture. Talk to me about the Artemis program.
Well, we're going to the moon. This time we're doing it unlike we've ever done before. We're going with commercial partners. We're going with international partners. We're going to learn how to live and work on another world for long periods of time using the resources of the other world. We're going to use the resources of the moon to live and work with a purpose, because ultimately we want to go to Mars. So we're going to build the capacity to live and work on another world so that we can go to Mars. And the reason we have to do that, Mars and Earth are aligned on the same side of the sun once every 26 months. So when you go to Mars, once you're there, it takes about 9 months to get there. Once you're there, you have to be willing to stay as it orbits the sun until Earth and Mars are aligned again. The moon is always with the Earth wherever we are around the sun. So it's the perfect proving ground. And of course, there's tons of science we can get from the moon. We can get a lot of information of the early solar system because of the subatomic charged particles that have been coming from the sun for billions of years and impacting the moon that we can't get from here on Earth because we have a magnetosphere that protects the Earth and an active geology and an active atmosphere and a hydrosphere. So the moon is a lot about science and data. It's about the early solar system. It's also about astrophysics, looking deeper into space than ever before, because the moon gives us an opportunity to really have this very quiet area from an electromagnetic spectrum perspective, very quiet area on the far side of the moon where we can look way out into deep space and, in fact, look back into time, if you can imagine that. So we're going to the moon sustainably. We're going for science, discovery, exploration, but we're also going as a proving ground so that we can go to Mars.
It sounds like you're excited about this all the time, not just today, but let's bring it back to Earth. Actually, a little bit closer, just a mile away. Talk to me about SLS and how unique this is.
So the SLS rocket is the most powerful rocket ever built in the history of humanity. The core stage has 4 RS-25 engines. These are very similar to the Space Shuttle main engines. And of course, we're going to light this rocket today for a period of 8 minutes, which is the amount of time we're going to need to light it for a launch. So what we're doing today is we are replicating as much as possible a launch. And we have to remember that what we're testing today, this is a test vehicle. It's also the flight hardware. This is the same rocket that by the end of this year will be launching the Orion crew capsule around the moon. Now, by the end of this year, that Orion crew capsule will be uncrewed when it goes around the moon. But by 2023, we're going to send American astronauts around the moon, and by 2024, we're going to be landing on the moon.
Well, thank you so much, Administrator Bridenstine. I'm sure you want to get somewhere a little warmer where you'll be able to watch the test.
Great to be with you.
It's great to be with you, too. Thank you so much. It was just a few weeks ago that we announced the astronauts for the Artemis program. Let's take a look and meet those astronauts right now.
At NASA, we have always answered the innate call to go.
With Artemis,
we are going to stay.
proving that humanity
can live on the moon,
Mars, and other worlds.
and share the wonders of the solar system with all.
Our story is one of people.
All those who make this journey possible.
From advocates across communities,
To companies across industries, to countries around the world.
We achieve this collective endeavor.
Our efforts create impact for all.
Technologies that revolutionize industries.
And jobs that bring prosperity to people. The discoveries from space
Benefit the way we live on Earth today.
and those from the moon
Will create a better future.
For generations to come. But to do that,
we must go.
hi, I'm Chell Lindgren. My name is Raja Chari.
Kayla Barron.
Kate Rubens.
Hi, I'm Christina Cook.
NASA astronaut Joe Acaba.
Jessica Amir.
Woody Hoberg.
Anne McLean.
Stephanie Wilson.
My name is Johnny Kim.
Nicole Mann.
Victor Glover.
Jessica Watkins.
Hi, I'm Matthew Dominic.
Jasmine Mogbelli.
Frank Rubio.
Scott Tingle.
This is what we do. This is what we will do.
Let's go.
We go to the moon to learn how to live on other planets.
For the benefit of all.
If you are just joining us, welcome. The engines on the SLS core stage are expected to fire up at 4 o'clock Eastern, 3 o'clock local here at Stennis Space Center. Before that happens, let's get a closer look at the Space Launch System. NASA's Space Launch System is Artemis's super heavy lift rocket and provides the foundation for human exploration and scientific missions to the Moon, Mars, and beyond. Powered by 2 solid rocket boosters and 4 RS-25 engines, this rocket provides unprecedented power and capability. Designed to reach 23 times the speed of sound and an altitude of more than 100 miles in just over 8 minutes, offering more energy, volume capacity, and payload mass than any rocket built today. Under the launch abort system, Orion and the upper stage, and between 2 solid rocket boosters is the heart of every SLS configuration, the core stage, towering 212 feet with a diameter of 27.6 feet, and storing 537,000 gallons of liquid hydrogen and 196,000 gallons of liquid oxygen. This is the world's largest core stage ever built. The core stage for Artemis 1 fires up for the first time at NASA's historic B-2 test stand. So there it is, the Artemis 1 SLS core stage on the B-2 test stand. The teams on site are planning to fire up those 4 RS-25 engines at 4 o'clock Eastern. Now, Alex, I know this is a culmination of tests here, but it started way long ago. Let's just go back one step and talk to me about how this was built and assembled at Michoud Assembly Facility.
Absolutely. So originally the core stage was designed up in Huntsville by our SLS program team and also our Boeing team. And then, manufacturing began at Michoud Assembly Facility in New Orleans. It's our state-of-the-art manufacturing rocket facility. It's more than 44 acres under a single roof. And obviously through the production of that rocket, we eventually moved the core stage from Michoud Assembly Facility here. That process is no easy feat, a lot of coordination at Michoud to be able to ship that thing and get it here in the proper amount of time. And so
you're talking about moving a rocket on the Mississippi River.
Right, yeah. So, we have a barge called the Pegasus barge, and this barge is it's kind of our carrier for the core stage. It's a fully covered barge, and it carries our core stage all across the Mississippi and eventually to Kennedy Space Center.
And then when it lands here, how do you get it into the test stand?
So whenever the core stage does arrive to Stennis, we have a very talented and very experienced lift team, and they bring the core stage to the sand. They lift the core stage in a very slow process and lower it into the B-2 test stand, secure it, and then we begin our rounds of testing.
Your rounds of testing, what does that look like?
Well, we actually have a series of green run testing. This is actually the 8th test in a full series of green run tests that we've been performing over this past year. We start with modal testing, which is kind of testing the vibrations and the structure of the rocket to see how it's going to react when we do the hot fire. And then we do things like powering on the avionics, all the electronics equipment, and then we move into activating safety systems, testing NPS components, and kind of piece by piece building on what we previously did to finally get to the point where we are today.
And today we call it the Green Run Hot Fire Test. Why is it called the Green Run?
Well, the Green Run really refers to the parts in the rocket never being flown before. So, obviously all these parts have been tested by themselves, but they've never really been tested as one giant unit. So today we're really looking to get all that data and fire for the first time. And then obviously the run refers to all the series of tests we've done to get to this point.
Well, Alex, thank you so much. Again, we're going to be coming back to you. We're also later on in the show going to start hearing some audio from the control room, so I'm going to be relying on you, Alex, to let us know what they are talking about. And the hottest part of the show today will be those 4 RS-25 engines at the bottom of the core stage. An interesting fact, these RS-25s we're testing today are repurposed from the shuttle program. These 4 engines flew on some pretty iconic shuttle missions, including one of the Hubble Space Telescope servicing missions, the historic return to space of Mercury astronaut Senator John Glenn, 6 flights to the space station, and the final space shuttle mission in 2011. So you can trace a direct line from that final shuttle flight to the first flight of SLS. We've worked with our partners at Aerojet Rocketdyne to upgrade the 16 shuttle main engines, which will power the first 4 Artemis flights. And now we're building 24 new engines using 3D printing and other manufacturing innovations to reduce cost, complexity, and manufacturing time. And a reminder, the test teams here are looking at 3 o'clock Central, 4 o'clock Eastern for today's hot fire test. Of course, many of the teams who worked so hard for this day can't be here in person because of social distancing, but they are still cheering us on virtually.
Hello, I'm Terrence Jones, Human Resource Business Partner at Stennis Space Center, America's largest rocket engine test complex. We're so excited for our Green Run test team at the historic B2 test stand. We are Go for Green Run, Go Artemis, Go SLS.
The Aerojet Rocketdyne RS-25 engine team is extremely excited to show the world what our hardworking team has been able to accomplish. Our team is working tirelessly to build reliable engines to ensure the future of human exploration beyond Earth's orbit. Let's go back to the moon. Go Aerojet Rocketdyne. Go NASA. Go Artemis 1.
We are Boeing, and we are so proud to be part of Team Artemis. All right, guys, let's light it up.
It's so great to see the team cheering us on for this historic event. And you guys have been cheering us on online also. And in celebration of being one step closer to landing astronauts on the moon, we've been asking you, what would you take on a trip to the moon? Let's take a look at some of the entries that we've received. We have an entry from the New Orleans Saints. And Marcus Davenport from the New Orleans Saints, he would pack his helmet and a football. What is a trip to the moon without a helmet and a football? Who dat? We also have an entry here, Moon Kit from Storm Lake Elementary STEM. It's great to see the little ones packing their moon kits. Storm Lake says that our moon mission is back on track. Students K through 1 are preparing to blast off next week by packing their moon kits. And in their moon kits, they have a soccer ball, an astronaut suit, shades, and a camera. You never know if it's going to get bright out there. Good job. We love your moon kits. And how exciting is this? We have an entry from the one and only Marie Kondo. Let's take a look at Marine's moon kit. She is packing a blanket because she gets cold. I could use that right now. She has boxes to keep things tidy. She knows how to pack. And she also has a picture of her family because they spark her the most joy. Awesome. And in responses to what would you take to the moon, we've received some really creative entries. Let's take a look at some more of those entries that we've received. I'm really excited to see some more of these. Wow, it is absolutely incredible to see all of the moon kits that you guys have submitted. We literally have them from all over the world, and I'm being asked, what would I pack in my moon kit? In my moon kit, I would pack my Pomeranian Azania, and I would have a pretty big box so I could squeeze my 3 boys and my husband in my moon kit. What about you, Lee? What would you pack?
You're absolutely right. I'm not leaving Earth without my German Shorthair Pointer, Penny. And when I told my husband that, he was upset that I didn't say I was bringing him and my sister Casey as well. So we're just turning the moon into a family vacation. We've been telling you a lot about the hardware we're testing today, but none of this is possible without the thousands of people at NASA, Boeing, Aerojet Rocketdyne, and the companies around the country working hard through the coronavirus pandemic and multiple hurricanes to get to this day. From here at Stennis, where we test, to the Michoud Assembly Facility in my hometown, New Orleans, where we build, to our Marshall Space Flight Center in Huntsville, Alabama, where it all began. There is so much going on behind the scenes. Here's a look at Marshall's Software Integration Lab, which represents the brains inside SLS.
I am the lead of the team that is building and testing the core stage. All the boxes you see here and the miles of cables that you see, this is what the inside of the core stage looks like. So you can see it's very complex. And what we do here is we run a lot of simulations to ensure that we have validated the systems and integrated them together. So we actually have special software that's a version of the flight software, but it's really specific for our green run test. And so that testing has also been integrated into this laboratory and with all these avionics boxes to ensure we have a successful hot fire. Best part of the job is working with all the people and the teamwork. It's been extremely fun to watch how everybody has pulled together with the same goal in mind. We have more than 1,000 companies across the United States that support us. Some of them are small mom and pop shops all the way up to the big contractors. And each one of the individuals that have been working with us have a significant contribution, and they should be extremely proud, not only when we do our Green Run Hot Fire, but when we have our first Artemis mission launch.
If you're just joining us today, we are live at NASA's Stennis Space Center in Mississippi for the Green Run Hot Fire test of the core stage of our Space Launch System rocket. At about 4 o'clock Eastern, over there at our historic B-2 test stand, we are going to fire 4 RS-25 engines for up to 8 minutes to prove this rocket is ready to launch later this year on the first Artemis mission to the moon. Again, so many people have worked to get us to this day, and even if they're not here in person, they are ready for this big milestone.
On behalf of all of NASA employees and NASA contractors at the Michoud Assembly Facility, home of America's rocket factory, we wanted to show our appreciation to everyone supporting the Green Run Hot Fire. We are with you, and together we are making history.
My name is Preston Jones from NASA's Marshall Space Flight Center. I'd like to say congratulations to the SLS team, to the core stage team for this great milestone achievement. As we go into Green Run, let's say go Green Run. Go Green
Run! From everyone here on Team SLS, we want to wish Stennis and everyone down there at the B-2 test stand a happy and successful Green Run. Go Green Run and SLS!
We have an update for you. Again, this is a live show. We are hearing what you're hearing, and we are learning as we are moving through this day of test. Alex, do you have any update for us on why we might be possibly going faster or slower, or what this is like right now?
Yeah, so our test conductor just alerted us that they're working through a few issues on the stand. You know, like we said, this is a test, so we will see some delays or some possibly, some issues that we'll have to work through. It's all part of testing. So as we get more information in, we'll tell everyone and we'll work through it.
And we did talk about this. This is a test. This is not a demonstration. Why is it so important to test today?
Right. I mean, the whole point, right, is this is not a demonstration flight. You know, we're out here to test a rocket, learn as much as we can, and that'll really not only help us for the first Artemis mission, but for all of our future Artemis missions as well.
And so what are we actually learning? We've got a lot of different components, a lot of different pieces of the rocket that we're looking at. What do these tests really look like?
Well, we're really here to simulate almost what a launch would be like, right? The whole core stage with the computers and everything, it thinks that it's going to be launched. Even though we're holding it in place and testing it, we're basically going to put it through a round of testing that's going to simulate the launch. So the whole point is to make sure, one, to verify that the core stage can perform that way, and two, get the data that we will need for launch today.
You've touched on this, but how much do the NASA engineers really not know about this rocket? What are you really learning, and what are you just guessing or finding between the data points you're already guessing?
Well, obviously our team, you know, knows a lot about the rocket. You know, they've been part of this project for a long time, everywhere from, you know, the beginning of the production to designing the rocket to testing the rocket. You know, they've been part of every step along the way. But even then, you know, you're constantly still learning, and that's part of the whole process. That's part of the process with any new rocket. And so, you know, that's why Green Run is so important to us and so important to the team and so important to the future of the Artemis mission.
We've heard you describe the rocket almost like a human. We learned about the brains of SLS. You talked about breathing, so there's parts of the rocket that can actually move as the test goes forward today. Is that right?
Right, yeah. A lot of people don't realize this. You know, we're pumping all that propellant into the core stage, you know, and that's really, really cold. You know, you're talking about a lot of changing temperatures when you're hot firing the engine, and you'll have a lot of parts that'll be moving, not just, you know, tanks shrinking and growing by a few inches just because of that temperature change. So, you know, it's almost like a breathing human being. You know, you'll when you turn it on, it'll actually feel like, you know, it's rumbling. You'll hear it, you'll see it, and it'll be super exciting.
So when you turn the rocket on, that's got to be harder than just turning your car on at home. What's that like?
Right, absolutely. You know, we actually started vehicle power on a few days ago, and you slowly turn on individual avionics boxes, and then you have to charge the batteries, right? And so you're slowly turning it on one by one and doing verifications of each system as you do turn it on, finally to the point where you have one large core stage working all together simultaneously.
Simultaneously. And you talked about temperature changes. Can you describe the changes that the engines will go through today?
Right, absolutely. So the fuel that we're adding to the core stage, right, that's our liquid oxygen and liquid hydrogen. Both fuels are very, very cold. You know, they have to be very cold to be in liquid form and not in their natural gas state. So, you know, we're looking at temperatures negative 400 degrees, you know, a little bit more than negative 300 degrees for those two propellants. And then when it comes time for ignition, you know, in less than a second, you know, we're getting up to a few thousand degrees temperature.
That's a big difference really quickly.
Yeah, it's very fast, you know, and that's part of the thing which propels the core stage and the rest of the SLS off of Earth's surface.
I gotta say, you're keeping calm. You've got a cool level head right now, but I have to imagine you're excited about this. You've been working on this for years.
Yeah, you know, it's an absolute surreal experience, you know, for everyone who's been working on this, you know, for the last few years and even longer than that. You know, I think everyone's really excited about the core stage test. Everyone's excited to see it be launched for Artemis 1 and for the future Artemis mission. So I know the whole team's working hard. You know, the team in our test control center is working very hard. So, you know, I think everyone's just looking forward to it.
I do want to talk a little bit more about the team because we see some people here, but it's actually people across the country. Can you talk to us a little bit about the different companies that have gone into integrating with NASA here and how all that comes together?
Yeah, absolutely. You know, we have thousands of parts on the rocket, you know, and there's tons of companies and subcontractors, you know, small companies, big companies. And so, you know, we've had parts from more than 44 states across the nation. And then obviously, you know, our Boeing contractor, our lead contractor for the project, you know, they've been working hand in hand with NASA the whole time. Those teams have really been performing really, really well thus far. And then obviously our RS-25 engines supplied by Aerojet Rocketdyne. I mean, you know, all three of our teams have done a really good job of getting to today.
Well, Alex, thank you for being in the hot seat, explaining everything to me and to everyone at home. We are actually going to move forward now. We're going to give you a little bit of a break. Feel free to take some water and listen in. We actually would love for you to listen in to the control room so we can come back and ask you exactly what they're talking about. Give us a breakdown. I'm excited now to be talking to an astronaut who is here with us, Tracy Caldwell Dyson. Tracy, it's so great to meet you. Thank you so much for being here.
My pleasure. It's a real honor and a privilege to be here. So it's going to be exciting.
Well, first I want to talk to you about the act of launching off this planet. You have flown on the shuttle, STS-118 specifically, and one of those engines that flew you to space is powering this very core stage. That's pretty cool.
That is really cool.
All right, I have to ask you first basic question. What does it feel like to launch?
Oh gosh, there's so many feelings. Even before you even get inside the vehicle, as you're walking up to the launch pad, you see this mammoth rocket standing before you. And from the sensations to the things that you see to the things that you realize, you've got a job to do, but yet you're doing this incredible, you're having this incredible experience. From the light off of the engines to the lift off, the swaying of the rocket, the rumble, all of the vibrations, the controlled explosion happening underneath you, to the constant acceleration that you're feeling as you're propelled into orbit, to the engines are throttling. All you know is that you're just going fast, and then you're in there with your buddies. You've been training all this time. You get to the solid rocket boosters. As soon as they expend their energy and they separate from the vehicle, and you're just riding on those main engines, the RS-25s. I remember being so impressed with how smooth and powerful that ride was. It was like riding on rails. And then, of course, the moment you get into orbit, it's some of the most strange tranquility that you've ever experienced in your life.
I want to ask you to do something here. If you'll indulge me for a second, let's just take a look back, because we are about a mile away from SLS.
Well,
as you take a look at that, what's going through your mind?
You know, I have to give it up for the folks that are in the control room right now, because I can remember how I felt standing at the foot of the rocket before I launched on it. But all of those folks, like Alex was mentioning, that have played a role in this, plus the ones that are around the test stand, that is their baby. And when those engines light, there's a lot of hands and eyes and hearts and soul that are in every ounce of thrust that are coming out of those engines. And so I think when I look at that, I just think about all of the people who make up the body of that rocket and the thrust that's coming out of it. And I'm really excited for them.
Excited for all of us.
Yeah.
And it's exciting for all of us here. And what's the difference with the excitement in the astronaut community?
Oh, goodness. Well, I tell you what, there's a whole lot of other blue flight suit folks that wish that they were here today. We are just genuinely excited about this opportunity to go further than low Earth orbit and explore again our moon, and to set a foundation along with those footprints, and to go beyond that, and to just be here at this time with all this excitement is a real privilege for all of us. But as a corps of astronauts, we're just really excited about where we're headed. So.
All right, you said moon. So as we progress towards the moon, talk to us about the significance of the human element in space. Why is it so important to put humans back on the moon?
Oh, goodness. I think there's so many ways to answer this, but I think, we have it inside each one of us to discover, to explore, to let out our creativity. And I think the reason it's important for humans, I mean, technically it's important because we know how to make decisions right then and there, especially with time delays and not having a camera view every single place you need to look. It's, I think, vital to have humans involved. But the spirit of exploration is within our hearts, and there's no other way to live it out but to send our humans to these destinations.
And there's a lot of people watching today, and a lot of kids watching today, young girls watching today. Do you have anything you want to say to them specifically?
Oh, goodness. Well, with what time we have left, I would say that the most important thing to do is to know what you enjoy doing, and start now taking note of those things, because what we really want is the best in you, and what brings the best in you out for everyone to see is doing the things that you enjoy. And so I would encourage everyone to go and explore all the things that you are doing right now, and ask yourself if you didn't have to get a grade in this, would you still be doing it? And so I just think that it's within their reach to fulfill their dreams, as long as what they're doing is what they enjoy.
Stay curious.
Stay curious, absolutely.
Well, Tracy, I'm lucky to be with you. We're both lucky to be here right now, but there are a lot of people at home who've got questions for you, too. Would you mind if I asked you some questions off of Twitter?
Please do.
All right. We're going to jump to a few questions we've gotten in. The first one is from Amber. Amber on Twitter asks, what is the main mission, or what do you hope to learn with these next series of landings?
On the moon, I think what we are trying to learn is just make sure we know how to get back there, and then to set up our mission so that we can come back. And our whole goal is to lay a foundation on the moon and make it sustainable so that we can continue to come back. And so I think the most important thing is to test our systems and to make sure that we can duplicate it.
So make sure we don't get lost and that we know what we're doing when we get there. Okay.
That is highly important.
That's a great answer. All right, another user on Twitter asks, what would be your final meal before leaving for the moon?
Oh, goodness. What would be my final meal? You know what? I would, this is going to be boring, but I would want a salad.
What?
Why? Because I want fresh food before I go, because the rest of it's going to be all dehydrated, I'm pretty sure.
Do you get queasy on the launch, too?
No, I didn't, and I think part of that's because you are so highly trained and you've got a job to do and you're highly focused. And with all the G's pressing against you, it kind of keeps your stomach still.
It's keeping it down.
Keep it all in there.
One last question for you. What is the coolest thing you've experienced being an astronaut?
Oh, I got to say that it is being in shorts and a T-shirt, living on board the space station, looking out the window and gazing at this beautiful planet. That probably is the most exciting, coolest thing I've ever done as an astronaut.
Well, Tracy, thank you so much for being here. I hope you get to enjoy the show. And thank you to everyone watching and submitting questions online. What we're going to do right now is we are just going to watch with you. We're going to take a step back. We are going to watch the test stand, and we're going to listen in. And we are going to ask Alex to please pay extra special attention, because we're going to come back and ask you what's going on in the control room. So again, we are going to take a step back and all just watch the test stand for just a few minutes. And a reminder, we are in a dynamic situation. The teams are in a hold right now. We are still well within our window for today's test. The teams are working towards getting an updated test time for today. So we have Alex with us, and Alex, we were listening into a little bit of the control room audio. What does it mean that we're in a hold, and what were you hearing from the control room?
Right, so right now we're still in a stable replenish, and basically what that means is we're still getting fuel into the tanks from the facility, and the replenish cycle is kind of meant to maintain topping off the tanks to their full capacity as some of that liquid does turn back to gas, and we've been off that gas. So we are in a stable replenish phase. Obviously, some of our engineers in the test control center are seeing some data that they don't like or might be not exactly normal from what they usually see. So those teams are off now, kind of having sidebar conversations with each other to kind of determine what we need to do to go forward.
So I want to go back, because all this might be obvious to you, but we're trying to figure out where we are in this whole process. We thought, we might just come here and see the engines light up, but that's not what happens. So what happened up until this point, and what are we waiting on now?
Right, so like we said, we've powered on the vehicle, right, over the last few days. We've repaired all the systems, we've tested all the systems, and then this morning we started tanking, by filling both our liquid hydrogen and our liquid oxygen tanks with propellant. And so that's really been the long process today. I mean, obviously we have to chill down our main propulsion system, so all of our mechanical parts have to be chilled down to a certain temperature before we do hot fire as well. So, right now they're obviously working through some issues in that process. And as we learn more, as they learn more, we'll learn more. And so whenever we do hear audio, we'll be able to give a better update.
So why don't you tell us a little bit about that process? We're talking about chilling down the engines themselves.
Right, and yeah, all the engines and all the components inside the engine section, which holds the engines, have to be chilled down to a certain temperature before you start the actual hot fire, the ignition of the engines. And that's just because they're meant to operate under those cold cryogenic temperatures. And then obviously when you're hot firing the engines, you start to heat up those parts, right? So you want to cool them down to a certain point, and then obviously you'll heat them back up whenever you're firing the engines.
So say this hold is lifted, what will happen next?
So when we do, or when they talk about the hold and they lift it to continue operations, from that point, we're at the point where we'll start to move into our T-minus 10-minute countdown. And that countdown kind of moves into our final sequence of activities to finalize right before we get to the actual hot fire. So there's a whole set of activities we get every few minutes, and that'll kind of determine what time we will fire, and then that we are actually going to fire.
Will we be able to see anything during that T-minus 10 countdown, or really not see anything until the last second?
Yeah, you'll probably see a few things, and a few of those things you might be able to see right now. The water suppression system is operating. It's not operating at 100% right now because we're obviously not hot firing the engines. But when we do, you'll be pumping 100,000 gallons of water every 20 seconds. You'll be able to see, obviously, some of the engines gimbal, which are moving in a few degrees in different directions. And that'll be part of the run-up until we actually do activate each engine.
And you've told me this before off stage, but I thought this was fascinating. So we haven't had a test like this since the Apollo era. And there was something that happened then with a giant plume that actually made it start raining on everyone out here. Can you tell us that story?
Yeah, absolutely. A lot of people don't realize is, we have our two propellants, our liquid hydrogen and our liquid oxygen. And when you react with those two chemicals, you're really just creating H2O. So when you see the big plume coming out, it's just water vapor, right? And, since when we tested Apollo, back during the Saturn V program, that the amount of water vapor coming out during that test is quite breathtaking, and also it's so much that it can create clouds and sometimes rain clouds, so sometimes you can get rained on from that.
All right, so we can expect possible rain, even though it's a beautiful, cold but sunny day today. What else can we expect to see?
Right, so you'll hear the test conductor audio when we get into our T-minus 10-minute countdown. So after that, you'll hear, every few minutes him come on the phone and say, hey, we're getting to this step. And then you'll hear the engines rev up for the hot fire.
Well, Alex, thank you so much. We are going to remain live. I might be coming back to you in a minute, in 10 minutes, but we are really excited to have you here explaining everything to us. And a reminder to everyone at home, this is a live test. We are still listening in for the control room teams as they review the data of the test up to this point. They are having a conversation right now about the appropriate steps to move forward. So Alex, we've had a little bit of a talk about those discussions. Again, we're going to be coming back and forth to you. And again, a note to our viewers, we're going to be hearing calls from the test conductor at regular intervals over the next 10 minutes or possibly more. When we hear those call outs, what we're going to do is we're going to pause and listen in. I might turn to Alex and have you explain them to us again. For right now, what we're going to do is pause and listen for some of those so we can try to catch up with the rest of you and everyone in the control room, find out what's going on, and just take a step back and look at the beautiful SLS on the test stand now.